Hi, Lynn Parker is here.
Good morning, Liz. Dwayne Boniface with CPSC. Welcome and thank you.
Oh, great. Thanks. Glad you can hear me. Good to be here this morning. Thank you.
Hello, everyone. This is Jacqueline Campbell from CPSC. Just wanted to give you a heads up. We'll be starting at 9:05, just to give everyone a couple of more minutes to get logged in. Thanks so much.
Ready to go. Oh, wait a minute. Okay, good. Good morning and welcome to the U.S. Consumer Product Safety Commission Artificial Intelligence and Machine Learning Forum. My name is Nevin Taylor and I am the Chief Technologist here at CPSC. To kick off our forum, I want to introduce Dwayne Boniface, Assistant Executive Director of the Office of Hazard Identification and Reduction. Dwayne will share with you some thoughts about the agency's efforts on AI and ML and consumer product safety.
Good morning, welcome. Many thanks to all the participants. We've had over 200 people registered, and which is great to see. And I want to give a special thanks to all those who are helping us to have such a successful event. The presenters and panelists willing to share their time and thoughts, and to Nevin and the CPSC team for putting this together. CPSC has significant interest in artificial intelligence and machine learning in consumer products. Today's forum was directed in the fiscal year 2020 operating plan in recognition of the growing importance of these technologies. We held off on this forum until this fiscal year to allow us to benefit from the expertise of our new chief technologist, Nevin Taylor, who brings a wealth of knowledge and experience in this field. I see this forum as a key step in an anticipated longer series of discussions as we collectively work to ensure artificial intelligence and machine learning are applied safely. I also recognize that this discussion is part of a broader national set of discussions on artificial and machine learning. While the focus elsewhere includes dimensions such as ethics, security, privacy, and other dimensions, ours is on safety, although there are likely to be significant overlaps. In particular, today we look forward to hearing thoughts on the safety implications of artificial intelligence and machine learning in consumer products. I intentionally use a value-neutral phrase there. Some artificial intelligence and machine learning consumer products will bring significant safety improvements, helping to consumers to better operate various consumer products in a safe manner. For example, consider an artificial intelligence-enabled cutting tool that learns how I use it and stops if I use it inappropriately. Some artificial intelligence and machine learning consumer products will, however, present challenges. And here's where CPSC seeks to learn, as I'm sure we all do, how to get more of the positive. And we look forward to working together with stakeholders on developing associated safety standards. We also recognize that artificial intelligence and particularly machine learning present unique challenges for product testing as product customized through the learning process. And I particularly look forward to learning more about these and the other aspects. Again, many thanks to all for your time and attendance, and I look forward to a great event. Thank you, Nevin.
Thank you, Dwayne. That was a great introduction to today's event. Again, my name is Nevin Taylor, and as Chief Technologist here at CPSC, I'm leading the agency efforts related to artificial intelligence and machine learning, and how these and related technologies impact the safety of consumer products. On behalf of the Commission, I want to thank you for your participation in today's forum. Before we get started, I wanted to highlight that this presentation and all of the CPSC staff participation in the forum has not been reviewed or approved and may not reflect the views of the Commission. Neither the Commission nor its staff endorse any particular AI or ML product. In today's forum, we will look broadly at the product category and not at any specific product or manufacturer. We request that questions or information be provided with this goal in mind. Additionally, this forum will be recorded and potentially made available to the public. So today's forum will allow the agency to hear from experts about policies, standards, programs, and the future potential these technologies offer the consumer. As illustrated in the public notice for this event, the Consumer Product Safety Commission is taking a proactive approach to assess and analyze the safety implications of artificial intelligence and machine learning technologies to consumer products. Today's forum will allow the agency to hear from experts about policies, standards, programs, and the future potential these technologies have on these consumer products. We look to learn from industry, academia, and of course the consumer as to their view of and concern regarding the growing application of AI and ML consumer products. To that end, we are in the formulative stages and phase of establishing a program to, first of all, screen and identify the components of AI in consumer products. Second, we will assess the implications and the functionality of the many features they have to offer. Third, we'll analyze the impact they have to ensure the consumer's safety. And fourth and lastly, we will ascertain the iteration or how do they and do they adapt in this rapidly evolving marketplace. This proposed program will be discussed in first session this afternoon under what we call our 4I program or our 4I program panel. This program is the very initial stage of development, and so we look forward to hearing from our stakeholders as we continue to refine this program. Our first speaker and keynote is Dr. Lynn Parker. It is an honor to introduce Dr. Parker, who is the Deputy United States Chief Technology Officer, Assistant Director of the White House Office of Science, Technology, and Policy for Artificial Intelligence, and Director of the White House Office of Science, Technology, and Policy for Artificial Intelligence. And she has served previously as an intern dean of the Tickle College of Engineering at the University of Tennessee, Knoxville. And before that, was Associate Dean for Faculty Affairs and Engagement. Her service in government included Division Director of Information Intelligence Systems at the National Science Foundation, as well as Distinguished Research and Development Staff Member at Oak Ridge National Laboratory. She received her PhD in Computer Science from the Massachusetts Institute of Technology. So without further ado, it is my distinct privilege to present to you Dr. Lynn Parker.
Well, thank you, Nevin, and I very much appreciate this opportunity to talk with this group about some of the federal efforts that are underway to advance trustworthy AI. I also want to thank Nevin and the Consumer Product Safety Commission for holding this AI forum to get input on how best to oversee the design, development, deployment, and use of AI technologies in consumer products, certainly in this case focusing on safety. So in my talk today, what I'd like to do is to convey an overall approach for how the federal government can best provide this type of guidance.
Camera, grab those.
So do you have my slides up there, Nevin?
Yes.
Nevin, are my slides available there?
Yes,
Yes, they are, Lynn. They're up for you.
Great.
The first
Okay.
slide.
Okay, so if we could go now to slide 2. So over the last several years, 5 years or so, the U.S. has prioritized and advanced AI with a number of landmark national policy actions. These policy actions cover broad strategic directions, as well as important components of the national AI strategy that include topics like research and development, AI technical standards, guidance for the regulation of AI applications, leveraging cloud computing, and promoting the use of trustworthy AI in the federal government. So most recently, of course, was the National AI Initiative Act of 2020. So now if we can go to slide 3. This National AI Initiative Act of 2020 is bipartisan legislation, and it outlines the National AI Initiative. And you can see there are a number of goals of this initiative. First and foremost, to ensure continued U.S. leadership in AI. But the goal that I want to focus on in particular today, given the objective of this forum, is how the U.S. wants to lead the world in the development and use of trustworthy AI systems in both the public and private sectors. So this concept of advancing trustworthy AI is a key theme of the National AI Initiative Act. So if we move now to slide 4, the question is, what is trustworthy AI, and what's the meaning and the importance of advancing trustworthy AI? Well, clearly, the United States will not be able to fully realize the AI's potential if we don't trust it. So it's important for the federal government to take actions to foster that public trust and confidence in AI. Part of that is technical standards and risk management frameworks that help us understand what's how AI systems should work and what measures they should be evaluated against. And then, of course, there's also an important piece as it relates to AI regulatory approaches or policies. And overall, we want to make sure that agencies are continuing to promote innovation, the good side of AI, while at the same time, of course, protecting privacy, civil rights, civil liberties, and other democratic values. So at this point, really, there's two key questions I want to focus on. First, what is trustworthy AI? And then second, how do we best advance trustworthy AI? So moving on to slide 5, if you think about the concept of trustworthy AI, this has been a topic that has been explored extensively in the last few years with industry and academia and government and civil society, both nationally and internationally. So I think through all of these efforts collectively, we have a fairly good understanding of what constitutes trustworthy AI, at least kind of from a principles perspective. So just a couple of examples. Back in May of 2019, the U.S. joined with other OECD countries and other nations to agree to the OECD recommendation on AI. So this was the first intergovernmental consensus statement of AI principles. And the G20 shortly thereafter also adopted the same principles. They include concepts such as inclusive growth, sustainable development and well-being, human-centered values and fairness, transparency and explainability, robustness, security and safety, and accountability. And then in another action, U.S. Executive Order 13960 on promoting the use of trustworthy AI in the federal government also identified important principles for the federal government's own use of AI. And you can see there on the slide, it includes concepts such as lawful, purposeful, and performance-driven, and so forth. You'll see safe, secure, and resilient is also there, and I know safety is the main focus of this discussion today. And there are many others as well. So I think generally speaking, it's one of these things where we can sort of recognize trustworthy AI when we see it, maybe, if we can illustrate how the AI includes, has addressed concepts such as explainability, transparency, safety, privacy, and so forth, all of those topics that are listed there under the first bullet point. Now, a more challenging question, of course, is how do we advance trustworthy AI? So if we move now to slide 6, this really comes to a question of how do we best implement the fundamental principles of trustworthy AI. So there are many facets to this implementation. It includes certainly there are matters of research and development that need to be addressed, education and workforce development, international collaborations, governance, and more. So today, the piece of that I want to focus on is the governance piece. And fundamentally, it's a question of what is the right process for developing guidance for the trustworthy design, development, and use of AI. Now, certainly, the answer to that is different depending upon the particular area of use. So as you can see on this slide, there are many efforts underway across the nation and the world to advance trustworthy AI. So the one that I'm going to focus on today is the one in the rose-colored box there at the upper left, which is on the OMB guidance memo for the regulation of AI in the private sector. But that's not the only effort underway at the federal level or at the international level. For instance, the Executive Order 13960 on promoting the use of trustworthy AI in government directs OMB to develop a roadmap of policy guidance for agencies in their own use of AI in government. And many agencies are already doing this for themselves. For instance, the Department of Defense and the intelligence community last year identified their own ethical principles for AI and are working very hard now on the implementation strategies and approaches to do that within their use cases. Across the federal government also, there are efforts to help agencies to work together to learn best practices and strategies for implementing AI. So the GSA, for instance, has an AI Center of Excellence that's a hub of these kinds of activities to help agencies to better make use of AI and to do it in an appropriate and consistent way. And at the international level, there are a lot of efforts. I mentioned the OECD recommendation on AI. A follow-on activity to that is called the OECD AI Policy Observatory. And this is an international multi-stakeholder activity to catalog policy approaches that are being explored around the world and ways that we can actually implement the policies that are laid out, the principles that are laid out and the OECD AI recommendation. Helping in that translation to implementation is the new Global Partnership on AI, GPAI, which the U.S. is a founding member of and was launched last year. And that partnership has the explicit goal of leveraging the research in order to inform how best to move from principle to practice and to implementation. And this is just kind of scratching the surface of all of the many activities that are going on. But what I'd like to do now is to focus on the appropriate process for considering the governance of the use of AI in the private sector. And so this is that OMB Regulatory Memo M2106. So if we can move on now to slide 7. This AI Regulatory Guidance Memo was a deliverable from the executive order earlier in 2019 on maintaining American leadership in AI. The executive order states that this memo shall inform the development of regulatory and non-regulatory approaches regarding technologies and industrial sectors that are either empowered or enabled by AI, advancing American innovation while at the same time upholding privacy, civil liberties, and other American values. So in response to this directive from the executive order, in January of last year, in consultation with OSTP and other components of the White House and the interagency, OMB issued a draft of this regulatory policy to govern the development and use of AI in the private sector. So the memo was open for public comment, and then the final guidance incorporated that public feedback and was issued in November of 2020. So I really think that this memo provides a clear, forward-looking regulatory approach to AI that both promotes the application of AI and protects privacy, civil rights, civil liberties, security, and so forth. So as a top-line message, this memo begins by recognizing the promise of AI to improve efficiency, effectiveness, safety, and other important economic and social goals. But at the same time, it stresses the importance of fostering this AI innovation while also engendering trust and avoiding regulatory or non-regulatory actions that unnecessarily hamper the development and deployment of AI. Again, recognizing that there are many benefits that we can attain with AI. It also recognizes that narrowly tailored and evidence-based regulations that address specific and identifiable risks could actually provide an enabling environment for AI. It notes that we shouldn't hold AI systems to such an impossibly high standard that we cannot enjoy the numerous benefits of AI. So the memo itself, the body of the memo, is organized into 3 primary sections. And the first section provides the regulatory principles to agencies. And you can see here on this slide, those 10 principles. A main point of providing principles is to ensure that the guidance is flexible and long-lasting, so that as AI capabilities evolve over time, the underlying principles can still hold. And these are principles that also should apply to any sector of AI application. So as you can see, these 10 memos 10 principles begin with the first, which is, I think, fundamental to the rest, which is public trust in AI. Obviously, the regulatory and non-regulatory approaches to AI must promote reliable, robust, and trustworthy AI applications. A second is public participation, and this forum is an excellent example of that, of agencies providing opportunities for the public to participate in all stages of any sort of rulemaking process. A third principle, of course, is scientific integrity and information quality, making sure that agencies are developing technical information about AI through an open and objective pursuit of verifiable evidence that both inform policy decisions and foster public trust in AI. Next is risk assessment and management, noting that a risk-based approach should be used to determine which risks are acceptable and which risks present the possibility of unacceptable harm or harm that has expected costs greater than expected benefits. And this then leads, of course, to number 5, which is benefits and cost. So agencies are directed to carefully consider the full societal benefits before considering regulations. Number 6 is critically important because as AI adapts, we also want the regulations to be flexible. And so they should be written in such a way as to adapt to this rapid pace and change in AI capabilities and the application of AI. Number 7, of course, fairness and non-discrimination is key for agencies to consider. And in particular, making note of the outcomes and decisions produced by the AI application at issue to make sure that they are fair and non-discriminatory. Disclosure and transparency are important. Obviously, if you can understand what's happening under the hood, so to speak, then that can increase public trust and confidence as well. Number 9, of course, is integral to the scope of this particular forum, safety and security. Agencies should pay particular attention to what the controls are that are in place to ensure the confidentiality, integrity, and availability of the information processed, stored, and transmitted by AI systems. And then finally, interagency coordination. Obviously, different agencies have different regulatory domains, but we want to attain consistency across sectors to the extent possible. So interagency coordination will enable the agencies to share experiences and ensure consistency and predictability of AI-related policies, again, to advance AI innovation and growth, and at the same time, uphold privacy, civil rights, and civil liberties. So together, broadly speaking, these principles state the importance of targeted sector-specific regulations or policy instead of a one-size-fits-all approach. The guidance emphasizes performance-based and flexible approaches, lays out the importance of risk assessment, cost-benefit analyses, as well as non-regulatory approaches to overseeing the use of AI in the private sector. So now we'll move on to slide 8. The next major section of this memo also discusses non-regulatory approaches to AI. Again, based on the recognition that existing regulations may be sufficient or that the benefits of new regulation will not justify its cost, either at the time of the regulation or in the foreseeable future. So in those cases, agencies may either choose to not take action or to identify non-regulatory approaches that may be appropriate to address the risk that's posed by certain AI applications. Examples of non-regulatory approaches include sector-specific policy guidance, which can include non-regulatory guidance or testing and deployment frameworks. This can be done in collaboration with industry, such as through the development of playbooks and voluntary incentive frameworks. A second non-regulatory approach is pilot programs and experiments, which allow for safe harbors for specific AI applications for the purpose of improving our understanding of the benefits and risk in that application. A third is voluntary consensus standards. And this section acknowledges the relevant work of the private sector and other stakeholders in standards development, which can provide an important means for managing risk associated with AI applications in a way that's potentially more adaptable to the demands of a rapidly evolving technology. And finally, a fourth non-regulatory approach is voluntary frameworks. The memo states that regulatory agencies should both look to existing frameworks, including those specific to safety, cybersecurity, and privacy, which are also relevant to AI applications. The memo also calls on agencies to work with stakeholders to identify gaps in existing frameworks and to help address those gaps when needed. And that, of course, could include a risk management framework. And notably, the National AI Initiative Act directs NIST to develop a risk management framework for AI. And this will then be developed by building on their ongoing work toward that end. And then the third major section of this memo discusses ways to reduce barriers to the deployment and use of AI. It suggests, for examples, they include first, access to federal data and models for AI R&D, calling on agencies to make public access to government data and models more available where appropriate. Second example is transparently communicating with the public about the benefits and risks of AI in a manner that promotes public trust and understanding. This could be done, for example, through fora like this, and also by publishing requests for information in the Federal Register and communicating underlying assumptions and uncertainties about expected outcomes, both positive and negative. A third example is through agency participation in the development and use of voluntary consensus standards and conformity assessment activities. As another deliverable from the Executive Order 13869, NIST developed a plan for federal engagement in AI standards that directs agencies to use this plan in their involvement in AI standards development relevant to their regulatory authorities. And finally, a fourth example is through international regulatory cooperation. The memo highlights a presidential executive order from 2012, re-emphasizing that agencies should engage in international dialogues to promote compatible regulatory approaches to AI and to promote AI innovation, again, while protecting privacy, civil rights, and civil liberties. And then on to slide 9, the final section of the memo directs agencies with regulatory authorities relevant to AI to submit plans for achieving consistency with the memo. And you can see there the content of those plans that the agencies should be working on actually now. So with that, then I'll conclude on slide 10 by saying that the U.S. AI regulatory guidance is part of the overarching national strategy for AI, first begun by executive order in 2019 and then codified in the National AI Initiative Act of 2020. This memo is an important action that builds upon the critical progress made in a number of other high priority areas, including research and development, strengthening the AI research infrastructure, again, advancing trustworthy AI, training an AI-ready workforce, promoting international AI engagement, and then, of course, leveraging AI for government and national security. So with that, I'll conclude. My last slide just says thank you very much, and I look forward to learning more about the outcomes from this event and following CPSC's progress on these efforts going forward. So thank you so much for this opportunity, and I'll turn it back over to the floor. Thank you.
Thank you so much, Dr. Barker. We are so very grateful for your vision and appreciate your insights. We look forward to your continued leadership as we operationalize artificial intelligence and machine learning technologies. I'd like to now turn over and hand the presentation over to Joanna Matheson, who will introduce our esteemed panelists to share their views and offer their perspectives in the area of artificial intelligence and machine learning policy. Joanna?
Thank you, Nevin. Good morning. My name is Joanna Matheson, and I am a toxicologist and also the program manager for nanotechnology here at CPSC. And I will be moderating the policy panel. The goals and objectives of this session are to ensure that the design, development, and deployment of AI and ML technologies are safe, and that the parameters and principles of AI and ML application are safe for consumers. We have 3 presentations in this session, and the speakers will answer questions if there's time remaining in this session. So our first speaker today is Pablo Olivares Martinez, who will be presenting on developing AI policy in the European Union. Pablo is a legal and policy officer at the European Commission. His work includes development of a general framework for new technology and also assessing justice for consumers. So thank you so much for getting us started today.
Thank you very much, Joanna, and good afternoon, everyone from Belgium. Good morning there in the US. I'm really happy to be here and to share with you what's our experience in the European Union and what are we working on and what is our focus now. So as Joanna has introduced really well, we are working in the unit in product safety, and we deal with the general consumer safety, but as well we work on a daily basis with other services within the European Commission, working with new technologies and other policy areas that they relate to new technologies apart from product safety. But maybe coming directly to the presentation, and I can start with the first slide. I would like first to give a quick overview. I promise not to be really long, but to focus a little bit on what's the legal framework for product safety in the European Union and what we are talking about when we talk about product safety here in Europe. First, I mean, it's a really complex process. As you can imagine, we have 27 countries represented here, and and it's a single market and so on. So it's a really complex process. But to simplify, we have two main working bodies regarding product safety legislation. One is what we call sectoral legislation. So here we are speaking about specific products categories like toys, electrical appliances, radio equipment devices, machinery, cars, that each of those specific category products, they have one regulation, one directive that sets a specific minimum requirements that those products they need to comply. And they are applicable for all countries in the European Union and for all producers that they are targeting new consumers. This, as you can imagine, it's not possible to regulate all categories of products. So that's why we need a general product safety directive, an overarching regulation or act that regulates the safety of all the other products that are going to be consumed, that they are going to be used for consumers, but without entering in the specific requirements that each category of products they have. And this is why we have this directive that is we are in charge in our department, and the objective is a dual objective. It's to protect consumers, as I've mentioned before, but as well to allow the free movement of those products within the European Union from country to country and to build a single market product. Those both building blocks, the sectoral legislation and the General Product Safety Directive, they rely on standardization, on standards that they are developed by the industry, but they remain voluntary. So each producer, each manufacturer, they don't need to follow those standards. They can develop their own technical solutions, so legislation remains technologically neutral. But if a producer, a small company or big company decides to follow those standards that they are referenced in the official journal of the European Union, there is a presumption of safety, a presumption of conformity, and they don't need to prove to the authority that the design that they have followed for the product is safe. There is a presumption that they need to be removed. Please, next slide. So I was mentioning that the General Product Safety Directive is our general framework. We like to call it the safety net because it covers all products and all aspects and categories of risk that they are not covered by sectoral legislation. This directive dates from 2001, so you can imagine that at that time there were not so many connected devices, there were not so many products sold online. But anyway, we have carried out an evaluation recently, and the conclusion of this evaluation is that the directive has worked very well. It has fulfilled its purpose, but anyway, we have identified some challenges and some things that we think that they should be improved, and that's why we are currently working in a revision of this directive to try to improve it and to make it more aligned with the times that we are living. In particular, one of these main problems that we have identified is that the directive is not properly adapted to new technologies. We are talking about connectivity, but as well to artificial intelligence. This is why we have launched a consultation. We began to have this consultation from summer last year in 2020. And in the frame of this consultation, we have set up an expert group that has assisted to identify the main issues. And if we move to next slide, you will see that this expert group that we have set up, we set it up in December 2019, but it has represented a really wide range of stakeholders. It's coming from private sector, businesses, industrial associations, but as well consumer organizations, national authorities of market surveillance authorities here in Europe, academia. We have even some ethical hackers that they have helped us as well to understand how connectivity and cybersecurity works. And it has contributed really much to our internal thinking in the Commission, how to understand and how to adapt the legal product safety framework to new technologies. They have published an opinion in our website in January 2021, and this opinion is not binding for the European Commission, but anyway, we think it's a good piece of advice for us, and we are really taking it into consideration in our revision of the directive. That I forgot to mention it before. It's foreseen for the second quarter of this year. Probably for the month of June, we will have a new directive that it will go, of course, to the co-legislators here in Europe, the European Parliament and the Council, and we will need to have negotiations with them. So we hope that for late 2021 or the middle of 2022, we can have an approved legal framework for that. Coming to the next slide, and maybe to the content of this opinion, that is what I would like to focus the presentation today. It has focused in 3 different aspects. Not all of them they are specifically based for artificial intelligence, but one of the main conclusions that we have extracted from the experts on the group is that when we talk about one single technology, it's really difficult to differentiate the hazards when it comes to product safety. We need to have a holistic approach and to take all in consideration these new technological developments to try to have everything into account when we have a coherent approach. As well, one of the main conclusions of the opinion is that we are focusing only on the consumer product safety aspect, but when we talk about new technologies, there are other policies that they are really relevant as well, and they need to be considered in the whole picture. The opinion doesn't go that deep, and let's ask the Commission to take into consideration those policy areas and to take policy actions at this respect. We are talking about cybersecurity in general, data protection, privacy, fundamental rights, but we need to have a clear holistic approach, and this is as well a call for all authorities within governments and within institutions to break silos and to work in a coherent and more holistic approach, taking into account synergies. We are not in the time of working only separated for product safety and forgetting about cybersecurity. We need to work together. We need to exchange information as well at international fora like this one. So we are really happy that you are taking this initiative. Coming to the specific content of the recommendations from the experts, one of the first areas that they have focused is the new risks that they can come from different technologies. One is the pure cybersecurity aspects and a concept that they like to call cyber safety that we don't have in our legislation, but they have proposed to use. And this here is the example of, for example, a connected device, a connected cooker, a connected battery that is the product lacks a minimum cybersecurity features. Then it's accessed by a malicious third party and it explodes or it intervenes in a way that it can harm physically the safety of consumers. For this specific risks and hazards, the group, there was a consensus that this needs to be considered within the concept of safety and needs to be considered in product safety legislation. And there was a call for revised legislation to have this into consideration. Regarding other aspects of new risks that the group has discussed and identified, that comes to the personal security. And it's related to the previous one, to the cybersecurity, but here we're not talking about a specific and direct physical harm to the consumer, but the use of a connected device that is hacked and is accessed by a malicious party, and then is used as an indirect harm to consumers. Here we have the example, actually we had it in the European Union, of a smartwatch for children that it lacked completely any cybersecurity feature, so it was super easily accessible for third parties to access, and it was meant specifically for children to be protected and to give an appearance for parents that the children was going to be protected. That was not the case at all. There were tests that show that it was really easily to access, but it's true that the smartwatch itself couldn't harm the children or the child, but it could be a way for a malicious person to have access to the kit and maybe to access to him or her and cause damage and harm to the child. For this, the expert group concluded that this was a really important issue that the policymakers we need to take into consideration, but there was not clear consensus if that needs to be considered within the concept of safety or not. So there was a call for action for the European Commission and for the legislators, but to reflect internally if we need to consider this as an issue for product safety or to have other potential policy actions, maybe the cybersecurity, cybercrime, or other areas. The latest new risk that it was identified by the experts, actually it relates a bit closer to artificial intelligence, and it is the case of mental health. Those issues, they were widespread before connectivity, before new technologies, but it is true that with the new technologies and connectivity and artificial intelligence and machine learning, there is now more and more evidence that these technologies, they can pose mental health issues to consumers. We are talking about addiction, but also to robots that they are showing emotion, and maybe it's not easy to identify, and they can create a lot of issues. The concept of mental health, it was already considered within the concept of safety, because according to the definition of the WHO, health covers both physical and mental health. So according to our current definition that we have in the product safety legislation in Europe, it is covered, but there is no explicit mention to mental health. And there was a call from experts that these mental health issues, they need to be covered, but at the same time, there should be a clear causality link between the product and the mental health issue. Because here we are talking about connectivity and so on, and maybe there can be some mental health issues, but they don't relate specifically to a product. So they cannot be considered by a designer, a producer. So in that case, there should be really a clear test, and there was a call from experts to try to develop guidelines or to try to help to assess those risks. So that's when it comes to new risks, but there was also some discussions regarding the definition of the concept of product, and here we are talking about software. There were really passionate discussions regarding this topic in our expert group meetings, because it's really difficult sometimes to distinguish what can be called a product and what's not. But at the end, there was a clear conclusion, and maybe the definition of product regarding in our framework, in the European framework, is wide enough to cover both things, physical product and virtual product. But maybe that's a more academic issue, and what we should do, legislators and policymakers, to try to tackle the possible problems that software can pose to consumers. And when we talk about software many times is there are many definitions of artificial intelligence, but artificial intelligence takes the form of software in many cases. There are also other types of software that they are not artificial intelligence, but we are talking about both things together. In that sense, there were the group introduced the concept of substantial modification that applies actually mostly to software updates. And what they call for this concept of substantial modification is that once a product is already placed on the market, is in consumer hands, we have a smartphone, a smart fridge, a connected device, whatever. The product, when it's placed on the market, of course, it needs to be safe. It needs to have a self-certification by the manufacturer before being put on the market and placed on the market. But then software can be downloaded into a device. If that's the case, and this software update fulfills a specific criteria, like, for example, introducing new risks, new hazards, changing the functionality or adding new functionalities to a product, and so on, then this concept of substantial modification, what they ask for it is for a shift on the responsibilities of the producer that then the new software developers should take into account. So that is a call for software developers to have into account as well the physical consequences of a product, but only when it has a clear safety possible impact. Not all software updates they have that. If you download an application into a smartphone, but it doesn't have any interaction with the physical safety of a consumer, then there is no problem, and that's not an issue at least for the policy area of safety. But if there is some applications or some software that is going to interact with the battery of a product or with other functionalities that they can have pose a problem, then the software developer, they need to have this into account, or otherwise there can be a split of the responsibility. That was already present in some pieces of legislation, sectorial pieces of legislation for some products, but not in general for all categories of consumer products. And there was a clear call from the expert group on this issue. And finally, the main important issue that the expert group asked for it was a revision of the concept of placing on the market. As I said, products, they need to be placed on the market and they need to be safe at that moment. But with machine learning, products, they can evolve afterwards. And apart from the introduction of the concept of substantial modification, there was a clear consensus from our group and our experts that they ask for designers to have into account the whole and the entire life cycle of a product, to take into account that products, they need to be safe during the whole life cycle. And there was also specific calls of having into account for artificial intelligence and machine learning, training of data sets, and to have this into consideration that the foreseeable use and the foreseeable path that the artificial intelligence can develop at the end never endangers the safety of a consumer. Finally, for the content of the opinion, the expert group also asked the Commission and different countries to have a really clear, coherent framework and consistency between the different initiatives and different policy areas that the Commission is working on different member states. So that gives a clear protection of consumers, but as well legal certainty for producers and manufacturers, and at the end that helps to build trust on these new technologies that they can do so much so well. Finally, my final slide. I'm not going to enter in the specific details of the different initiatives, but just to mention that apart from the revision of the General Product Safety Directive, the Commission is preparing what we like to call an artificial intelligence package with different initiatives that they will try to tackle different policy angles of this new technology, as I said, to promote this technology, but to create trust and protect consumers and people at the same time. One is the horizontal framework of artificial intelligence, that the aim of this framework is to create a clear approach that is transparent and strengthens the accountability and facilitates the enforcement of different policy areas and so on. It will help a lot with not only with safety, that will be one of the areas, of course, but as well to fundamental rights, and we are talking here about non-discrimination and other issues that artificial intelligence can pose and so on. Coming maybe closer to the safety part and the product safety and so on, one of the sectoral legislation that is really key and essential is the Machinery Directive, that in Europe is the directive that regulates the safety of robots, and it's also been revised, and it will include the specific requirements for artificial intelligence. It is sectoral legislation, so it's more specific than the General Product Safety legislation, so it prevails for products falling under the directive, but for all the aspects that are not covered there, they will be covered by the General Product Safety Directive, as I mentioned, as our safety net for consumers. And finally, there are also the different initiatives on liability of new technologies that we like to call liability the other side of the coin of safety, because safety protects consumers ex ante and try to establish its requirements at design level. But sometimes, even if those requirements exist, there are incidents, there are accidents, and some people, they can be harmed. So liability, what facilitates is to give compensation to consumers, and as well, it has a clear deterrent effect for designers and producers to produce products so they don't have liability claims in the future. Those are some of the initiatives that we were working with, as well, data protection and so on, and those are the main ones that they will come also in the second term of this year in 2021. And this is actually what I wanted to discuss today. Thank you again for having me here, sharing our approach in the European Union. I'm happy to further discuss in the panel.
Thank you, Pablo. Next up, we have a presentation by Drs. Andrea Matwishin and Patrick McDaniel. Dr. Matwishin is the Associate Dean of Innovation and Technology at Penn State Law, as well as Professor in the Engineering Department. She is the founding director of the Penn State Policy Innovation Lab of Tomorrow. Dr. McDaniel is the William L. Weiss Professor of Information and Communications Technology in the School of Electrical Engineering and Computer Science. And thank you both for joining us today.
Thank you so much for inviting us to share some thoughts with CPSC. I'll start with a few legal and policy observations, and then I will turn things over to my colleague, Professor McDaniel, for a more detailed deep dive into some of the technical aspects. So if I could please have my next slide. Thank you. So to begin, just by way of framing, when we talk about product safety in the context of machine learning and artificial intelligence, sometimes commentators lose sight of the fact that at the end of the day, we are talking about software and hardware and all of the problems that have been experienced by us in the context of various predecessor software and hardware problems. They are offering us important lessons for the future of the way that we should think about these questions of artificial intelligence and machine learning. There are direct physical risks that will arise and are already arising because of some of the programming and hardware choices that are being made as companies build these various products. But in particular, one of the hype cycle concerns that exist in the market today is this idea that these artificial intelligences, these machine learning algorithms, that they are somehow the equivalent of human minds and that they are human replacements. They are not. They are nowhere close. Anyone who has tried to dictate an email recently in a somewhat technical subject area will realize quickly that we are nowhere near an artificial general intelligence. So what we are talking about when we are talking about the machine learning algorithms in these products, in our smart garage door openers and in our smart thermostats and in smart baby monitors, what we're talking about are ultimately a set of trained algorithms that rely on training data. And this brings us to the first component of the way that it's good to think about some of the safety risks that can come up in the context of machine learning facilitated consumer products. So training data involves the various pieces of prior information upon which a machine learning algorithm relies upon, and that algorithm arises in its recommendations from those underlying bits of information. We've already seen problematic inconsistencies in outcomes of machine learning algorithms because of certain framings of training data that reflect underlying biases, both in the way that the sample was drawn and in some of the generated examples. So currently, when machine learning algorithms are being trained, some of the training data is often computer generated itself. And in that way, when you are creating secondary rounds of data off of previously flawed data, you are again perpetuating some of the deficiencies that may exist in that data. So these training data issues are at the core of what product safety in machine learning should be considering. Secondly, the question of the way that these devices are built, the security of the processes and the manipulability of the information flows that might lead to changed outcomes. So there is a potential for an attacker to manipulate the outcome of some of these algorithmically reliant products and have an end result that damages human safety. So security and safety are intrinsically interwoven here. Safety is the outcome of the process of a well-built product, including the hardware and software design choices and whether those choices possess confidentiality, integrity, and availability. So where CPSC fits in from my perspective is in this two-part oversight. First, of the building processes and encouraging industry to engage with the state of the art of building knowledge in the way that software and hardware choices are done and implemented and rolled out in the marketplace. And secondly, CPSC plays an absolutely critical role in the future of pulling unsafe products off the market that are reliant on machine learning technologies. By way of just a quick example, before I offer a few concluding thoughts and turn it over to my colleague, imagine a baby monitor system that is reliant on machine learning technologies. And we don't have to imagine because such things are already on the market. So consider one. When we start to pull apart the functionality of that system, what we see is that those systems tend to rely on, for example, facial recognition accuracy. So they are checking out the face of the infant to determine whether the child is breathing, whether the child is having normal reactions, etc. Those sensors' ability to accurately detect the movements of the child and the facial expressions, and to then notify parents that might be sleeping in another room, is contingent on how well those sensors work. It's contingent on the software that is having those sensors talk to other pieces of the system, and it's contingent on the integrity of the code in that software and whether a third-party attacker has manipulated it, for example, or whether it's used examples in its training data that may perhaps not reflect faces of different races as well as they do faces of other races. That would have potentially a direct impact on whether a child, a particular infant, is accurately detected in the child's breathing patterns, and then a notification happening. So particularly at the intersection of these health-ish products, we have a space where the regulatory scope is overlapping across agencies. And so when I say that, what I mean is that there are some concrete steps that I would urge CPSC to consider in its harmonization efforts across agencies. So the FDA, which engages with the regulatory space of medical devices, would not reach that device that I described. That's generally fallen under CPSC. Similarly, the FTC would look at different aspects of the functionality of that product, not safety, but for example, the data flows around the privacy and security of those products' data flows. CISA thinks about the security of the Internet of Things and also machine learning. So here we have three agencies that might be able to collaboratively advance the conversation in a meaningful way across categories in order to take the existing standards that NIST has promulgated, that CISA has promulgated in various contexts, and to ensure harmonization across all of their regulatory conversations, guidance, and industry engagements. The idea of playbooks is one that's an excellent one. However, the timetable must be expedited. The extent to which these products are already in the market is increasing at a fast clip, and the problems will also increase at a fast clip. So in addition to harmonization across existing guidelines and across the other agencies that are working in this space, the timeline for reassessment of the currency of these incorporated guidance documents should be short. So particularly because of the pace of new vulnerability discovery and the negative interaction effects that can be revealed sometimes on a daily if not hourly basis, require that guidance documents and collaboration happen on a fast pace, and that reassessment of these approaches happen perhaps on a biannual basis, for example. The last point that I'll make involves the unique capabilities of CPSC with its laboratories to test products, and urge CPSC to consider in particular looking at interaction effects, testing more products, and to perhaps explore opportunities for crowdsourcing some of the testing. Because of the existence of a robust security research community in the United States, there are hundreds or even thousands of security professionals who are recreationally testing these devices in various ways to look for interaction effects that might happen on their own home networks. So for all of the security experts and programming experts who in their day jobs build these products or test these products, they're also consumers who use those products. So this dog fooding dynamic creates an opportunity for CPSC to leverage this expertise to feed in additional information and data about potential flaws, malfunctions, and safety risks that could arise from these machine learning facilitated devices, and then spur further engagement with industry and regulation where needed. So I will stop there and turn things over to my colleague, Professor McDaniel.
Thanks, Ingrid. I'm gonna first apologize that my setup has decided that GoToMeeting is incompatible with my webcam, so we'll just try to do this in audio form. Next slide, please. So I'm at heart a technologist, and what I really want to do over the next few minutes is talk about how these technologies, these new AI and ML technologies, can fail in the context of consumer devices and services. But I think, to set a baseline, I think the first thing you really have to think about is that the AI and ML, or artificial intelligence and machine learning, are two different things. So AI is a broad category of technologies that go all the way back to the 1950s and a gentleman named Turing, which seek to model on some level reasoning and intelligence in computer systems. So for example, you might think in a consumer space, something like a Roomba. So a Roomba, if you've ever seen one of these, they kind of look like Frisbees that roll around in people's houses, and it cleans up the floor. So the way a Roomba works is that it has sensors. It knows when it bumps into things. So you put it down in the middle of the floor, and it starts going in random directions until it uses those sensors to figure out what the geometry of that room is. And at that point, it understands what the layout is, and then moves into a second phase, first phase being discovery. The second phase is planning. Then at that point, it decides what is the most efficient way to move about that space to clean the floors. And it does something like some periodicity. It has to return to its base for recharging. But what you can sort of think about that is discovery, reasoning, and planning. And so that's a very broad category of artificial intelligence. Now, machine learning is one part of that broader technology. Machine learning, often referred to as statistical machine learning, is a very different kind of thing, in which the machine learning, what it does, it takes lots and lots of examples of things it's seen before, and what we refer to as generalizes about them. So the way to think about that is think about spam detection. Well, the way spam detection works is that some computer system sees lots and lots and lots and lots of spam and discovers, for example, if they see the word Viagra, well, then there's a high probability of that particular email being spam. But in that case, what we've done is we've taken many examples and trying to figure out what was common about them. And that's machine learning. And what's amazing about the advancement of technology over the last decade is that machine learning has brought us to the cusp of things we could not do computationally before. It can reason with incredible accuracy about photographs, about scenes, about data, about trends. It can see things that we could not detect before. And on some level, it sort of reaches the level of magic. But they both have their downsides. So, AI and machine learning can be manipulated because they're all set within some sort of environment. For example, generalized AI can be fooled if you move the furniture around in a Roomba setting, for example. And what we've learned in the technical community, particularly the cybersecurity community, is that if I know something as an adversary about what you have learned from your generalization of lots of examples, whether they be photographs or spam, then I can use that information to get around that. Now, where this affects products is that we can begin to see that somebody who has some ill will or simply by accident, we can compromise things like confidentiality, things we want to keep secret. Integrity, that means we can modify, we can have the environment changed by the adversary in some way that harms us. Privacy, which is different than confidentiality. Privacy is keeping those things private that we would like to, and I'll give some examples in just a second. And then finally, availability, and that is generally the availability of something that we hold dear, something that we need. And ultimately, the way that adversaries, and I'm not going to get into the technical details, but these systems can be manipulated in fairly transparent ways, fairly simple ways, to undermine the very tasks and services and confidences I've heard repeatedly today of the consumer. And what we're seeing right now, I think it's fair to say that the consumer products that have embedded ML are easily manipulatable. And there isn't a tremendous amount of effort within the builder community, the people that are developing products. And I don't think that's necessarily, like a problem of lack of interest, but I don't think we have good best practices for what makes good AI and ML, as our keynote speaker had mentioned. How do we develop the techniques? What are the engineering principles? What are the guidelines? What are the tests that we can do that we can provide the builders so that they can certify that the AI and machine learning is accomplishing what they would like it to? So let me end with three, I think, sort of distinct examples, two relating to some IoT devices, and one finally a safety example of how sort of existing products might fail in non-obvious ways. So one of the most prevalent AI-related consumer devices that are being put out in the market today are door cameras. So door cameras, they do the doorbell cameras. I'm sure you've heard of them. They're fairly controversial because what they're doing is they're recording the environment outside your door, and this can be a safety concern, or this can be a great tool for ensuring the safety, so you don't unlock your door. Sometimes when you have, package bandits, you can catch the package bandit, so it has some enormous utility. But when combined with other things, these door cameras can also provide for some dangerous settings. For example, we are now seeing these cameras being used as a virtual key to get into the home. As Andrea mentioned, we can use things like face recognition in order to unlock the door. So as you walk up to the door, hey, your camera can suddenly recognize it's you. And then suddenly you get inside the house, the door's unlocked. But that can be fooled by an adversary who wants to break into your home because the very nature of the statistical machine learning, which is used for this physical authentication. But that's only one part of it. The reverse of that is actually an availability problem, in that if I, as an adversary, know something about your training, where I can manipulate that AI, I can simply lock you out of your own house, potentially, at great peril. But there's some secondary issues which are less to do about safety and more to be about the safety of society, and that is that these door cameras have collateral privacy issues. So if you point a camera out your front door and it's pointed right at your neighbor's house, you are now in helping yourself, making your environment more safe. You're potentially invading the privacy of those across the street, particularly where those cameras are being used to monitor people across the street by whatever organization would want to use that. In fact, your employment of that technology is impacting their privacy, and they have absolutely no say and often no knowledge of that. So finally, I want to come up with end with a canonical example we find in the Internet of Things space, where safety can be a real problem, and not just simply because of the failure of an individual consumer product, but a combination of products. So something we've been modeling is in-home IoT. So think of two devices that are sitting in your basement. One is a moisture detector. That's to see if you've got a water leak or your water heater breaks or something like that. What it does is it simply, when it detects there's moisture in your basement, it turns off the water to the house so that it doesn't do more water damage in your house. Now combine that piece, which is totally safe in and upon itself, and combine that with a fire alarm that turns on sprinkler systems. So think about this. Now you've got a safe fire alarm sitting in your house, and you've got a safe moisture detector. But what happens in practice? Well, let's say there's a fire in your house and the sprinklers turn on. Well, the sprinklers turn on as the fire detector is doing its job. It detects the smoke, it turns on the sprinklers, and now the sprinklers go off in the basement. And now that moisture is detected in the basement, and so the moisture detector says, "Oh, we've got a water leak," and it turns off the water. And at that stage, the house burns to the ground because there's no more water to put the fire out. Now, neither one of these consumer devices was flawed in any way, but they are interacting in ways that are non-obvious. So it's important to remember from a technology standpoint that you simply don't need to just evaluate each piece of commercial product by itself, but you need to evaluate it within the context of all of the other AI and machine learning that is performing its own functions. And these interactions can end up being entirely unsafe.
Okay, thank you, Professors Matt Wischen and McDaniel. Just a note before we start our last presentation, there have been a lot of questions about the slides. The slides will be part of the official CPSC meeting log. So our final speakers in this session are Professor Ben Edwards and Julia Armendariz, whose presentation is on behalf of the Consumer Federation of America. Professor Edwards has served as a faculty member of the William S. Boyd School of Law at the University of Nevada, Las Vegas since 2017. He researches and writes about business and securities law, corporate governance, arbitration, and consumer protection. And thank you both for being here.
Oh, there we go.
There we go.
Wonderful. Well, thank you so much. Very, very pleased to be here. Thank you to the Consumer Product Safety Commission for the opportunity to present. Thank you also to the Consumer Federation of America for allowing us to put this work together on their behalf. So the presentation you're going to hear is based on a white paper we submitted to the Consumer Product Safety Commission, and the students involved in this are all upper level law students who've done an enormous amount of work to prepare for this. Julia Armendariz is going to lead our presentation, but this has also been put together by Kelsey DeLozier and Pete Reyes, and hopefully this is a very, very helpful high-level overview for you. With that, I'll turn it over to Julia.
Thank you, Professor Edwards. So as the professor mentioned, my name is Julia Armendariz, and me and two other law students today, Kelsey DeLozier and Pete Reyes, are from the Boyd School of Law, and we're here in association with the Consumer Federation of America. And we were asked today to put together a paper, and it was focusing on artificial intelligence and consumer products. And specifically, we really wanted to focus on how artificial intelligence is impacted when you look at children's products. And so we've addressed a few different types of risks that are associated with artificial intelligence in children's products, and then how the policy is going to come together to potentially help and meet these challenges. So next slide, please. So I just want to set the stage and talk about a quick story. This is about a little toddler running around a Palo Alto mall who came in contact with a droid that was equipped with artificial intelligence. This little child was running around, and he came in contact with a security droid that was supposed to detect his presence. The security droid was scanning the area. It was supposed to look for security concerns, but because of the boy's height or some other factors, this robot was not able to detect the child at all. It ended up running right into this toddler, knocking him to the ground, and running over his right foot. Next slide. And now, while we don't foresee, right, any huge 300-pound robots like this one was coming to your homes soon, we can definitely see something like an artificial intelligent housemaid. We see something like the Roombas that were talked about previously. And we certainly don't want Rosie, you can imagine from the Jetsons, running over our little Rugrats at home. Next slide. And when we can talk about this story, right, we think of it as being lighthearted, but it actually raises some serious policy challenges. I'm going to go ahead and skip this slide because it looks like the other policy panelists have identified these definitions, and in the interest of time, we'll go ahead and move on. So thank you. So we looked at some of the pros and cons associated with AI technology. So for example, you have a product that adapts and conforms to consumer preferences. It can act in ways that are outside the manufacturer's control. And some of the pros to that, that can enhance product efficiency, that can provide a heightened consumer experience. But then you see some of the challenges, such as establishing policies to address certain public concerns that arise. Next slide. And so what we've identified are just a few major challenges, and a few of these have been touched upon before. And one of the first ones is fostering appropriate understanding and consumer trust. So with this new technology on the market, consumers are going to have to learn how to manage and operate it. Just like when we transitioned from the horse and buggy days into automobiles now, consumers must become familiar with this technology, and so do lawmakers. Lawmakers are going to have to understand how this technology operates if we want policies in place that are going to adapt and are going to make sense to address the specific concerns. We've also seen that a difficulty with the outpaced technology. Technology is evolving rapidly, especially in the realm of artificial intelligence. And so you have a lawmaker who may try to put together a law, and by the time it gets to the legislature, by the time it's passed, the technology is simply outpaced the law itself, and it's no longer relevant to address the policy concerns. And then finally, we have applying human-focused law to non-human decision makers. That's been a huge challenge. You take negligence, for example. That's just the failure of a person right now to exercise ordinary care. But when you have a robot and there's no personhood, it becomes really difficult to think about how our liability models are going to adapt in a world where all of our laws are centered around personhood in some way. Next slide, please. And so we've identified some specific policy approaches that have addressed some of these challenges. And the first one, voluntary standards. So this would be a suggestion that companies, they need to start holding themselves accountable. They need to start training data sets on their own, and they need to have a commitment to conduct certain amount of training before they put these types of products out onto the market. This might mean using diverse data sets, certain types of materials that are up to par, labels, specified algorithms. We've also seen another approach that would be extending our current laws to cover AI and machine learning. The FTC recently issued a statement that said all AI is going to be subject to consumer protection laws, existing consumer protection laws, that is. But that could be challenging if you think about some of the things we talked about regarding, human-focused laws. So another approach would be changing the liability models altogether. And in this realm, we've seen certain levels of predetermined levels of care that have been suggested. Another suggestion has been conferring personhood on the robot itself. Finally, we've seen a theory of common liability, which would mean potentially strict liability across the board for everyone involved, from developers to manufacturers. If an injury results from the AI, then everyone would be jointly held accountable for that. Another approach would be an opt-out and information rights. So, not all AI products need to be operated with the AI technology enabled. So maybe manufacturers and developers of this technology could give consumers a meaningful right to opt out of the technology. We've also seen external audits. One challenge that we see is, why do AIs do the things that they do? So if we focus on product development in a way so that we can understand their decisions and we can have these external audits, then going forward, then we might be able to understand how this technology operates. And then we'll have outside bodies like regulatory agencies that will be auditing these products before they hit the market. And finally, we've seen insurance style solutions. If you have a business that has AI technology involved and they're worried about it being a danger to consumers, in order to protect consumers, there might be an insurance style solution. They could potentially contact their insurance carrier and see what types of options are available. And that might be something we see in the near future. Next slide. And so we've addressed some of the challenges and some of the policy approaches. And finally, we want to talk about how children's products plays a role and what type of risks are involved in children's products. Because this is a danger with AI, is now a lot of these children's products are containing AI. And so we've addressed 4 types of risks that are presented in children's products. And direct safety risks is the first one. And that's just a typical example of the child with the robot. The child encounters the robot knocks child to the ground and presents a physical safety risk from the malfunction of the AI itself. And then we have indirect safety risks. And these are dangers that occur from the presence of the AI in the product. For example, AI technology, it leaves open certain privacy concerns for an AI to maybe come through a baby monitor, like was discussed before, and hack into it. And that would present a physical safety risk to a child as well. We also see circumstantial dangers, and this is dangers that result from the AI's presence just in the external environment. You see parents lately relying on AI to maybe educate their child, to supervise their child in some way. But what happens when that AI goes and tells the child to do something dangerous? The trust that parents have in AI can become very risky if the technology isn't operated properly. And then finally, we've seen developmental risks. And this is just danger that comes from the child's interaction with the AI and impacts their development. So if you have a child, for example, who is really rude to an AI device, and that AI device always responds kindly to the child, well, now you have a child that goes into a classroom and tries to act that same way towards a real child. And again, now you have a physical safety risk that might be present to that child developmentally in that regard. Next slide. So with these concerns in mind, we've addressed a few policy approaches that kind of overlap with the ones we talked about earlier, but in the realm of children's products. First, we've seen an approach that would be useful, which would be standard guidelines. We start identifying hazards from the early stages of product development. Manufacturers that are using AI need to start thinking about training their AI devices to maybe detect taller individuals, shorter individuals, things like that. And the machine, it only learns what it's told. And so if we have a standard set of guidelines that guides how these are developed, these products are developed, then companies can manage risks in that way. Maybe certain types of products need to have rubberized bumpers so that an injury does occur, well, it's not so serious anymore. We also would suggest appropriate data sets for training, and this overlaps with some standardized guidelines, but appropriate data sets might mean having diverse data sets. You want data sets to, like I said, recognize tall and short people, but also recognize racial disparities in products, so that products can not only be safe, but can also be safe, but can also be working for all users and be, of course, safe to all users as well. And as far as appropriate data sets go, maybe there's an option to disable the AI functionality, the opt-out or the opt-out rights that we talked about. That would be another suggestion for appropriate data sets. And then finally, we have consumer education. Parents and others, they have to understand the products they're buying. They have to understand how this might impact their child in the near future. And so consumer education is going to be huge moving forward with AI technology. Next slide. So in conclusion, these are very broad solutions. We recognize that, but the CPSC, it's going to face a number of policy proposals. It's going to require collaboration from many stakeholders to ensure an effective framework. And while AI technology in children's products still remains in its infancy, It's essential for the CPSC to continue its work to understand this developing technology, as product manufacturers would benefit from early guidance to manage risks and consumers to continue to embrace these technologies. Thank you.
Thank you, Julia, and also Dr. Edwards. These were great presentations, and I actually would like to thank all of our panelists. Again, this has been a great session. To keep the forum on track, the questions that have been submitted to this panel, we're going to forward them to this afternoon's roundtable. So right now we're going to take a 10-minute break, and during the break we will play several CPSC videos on general consumer product safety. So it is 10:35 right now, so the forum will begin promptly at 10:45 a.m. and that will be with a talk by Helhem Tabasi from the National Institute of Standards and Technology on defining AI and ML. So thank you very much, and we'll start the break.
As we all shelter in place, CPSC has a few tips to keep your family safe at home. Laundry packets, disinfectants, and medicines should stay in original bottles and put out of reach of children. Test your smoke and carbon monoxide alarms and develop a fire escape plan. Keep high-powered magnets away from children. Prevent dangerous tip-over incidents. Anchor large furniture and TVs to the wall. Stay healthy. Stay safe. Find specialized tips for all age groups at cpsc.gov.
Hurricane season is in full swing, and CPSC has 3 tips to help you weather the storm. First, keep generators at least 20 feet away from your home when in use. Carbon monoxide is the invisible killer. It's colorless and odorless, so keep exhaust away from windows, doors, and vents. Second, make sure your smoke and carbon monoxide alarms have fresh batteries and they work properly. Third, place CO alarms outside sleeping areas on each floor of your home. Follow these tips to keep your family safe. A friendly reminder from your friends at CPSC.
Oops. Uh-oh. Sorry.
Get on top of it before they do. Every 24 minutes, tipped furniture or a falling TV sends an injured child to the emergency room. Preventing tip-over incidents is easy, inexpensive, and only takes 5 minutes. Learn how to secure your furniture and TVs to protect children at anchorit.gov.
Chance was loud. She was playful. Chance loved to dance and sing. She loved playing with her brother. Chance never met a stranger. She was just an awesome, beautiful little girl. She said, "I love you, Mama." I said, "Well, I love you too, Chance." I never thought that would be the last thing that I heard her say. I went into the room, and that's when I saw where the dresser was on top of her. I just screamed her name. I kept saying her name over and over and over again. I was like, "Chance, Chance, Chance, say something to me, Chance." The doctor came in and told us the TV falling on her was like her falling from a 10-story building. You're not supposed to bury your child. And so for this to happen, and it could have been prevented, we know God has a purpose and God has a plan for everything. But if we had known the steps that we could have taken, maybe it wouldn't have happened. We didn't know that you can buy straps to anchor those dressers. If we can tell one person and one person anchors their TVs and they fasten their dressers and furniture down, Chance's mission and Chance's purpose has been served. We don't want this to happen to anybody else. Don't take a chance on this happening to you, because no parent should ever have to go through this.
The last conversation I had with her was, "Good night, Mommy, I love you." 5 o'clock in the morning, I woke up to the sound of the TV falling. I did not know she was underneath it. So I called her name, "Janiyah, Janiyah, where are you?" And I turned around and I just saw her legs under the TV. You just don't think of televisions or bolting your dressers to the wall. You don't think of those things. They don't tell you to do that when you get out of the hospital with your baby. You need a car seat, but they don't tell you when your child starts walking, make sure your furniture is bolted down.
The majority of furniture tip-over injuries occur in the home to children 5 years and younger. Most devastating injuries that we see to children because of furniture tip-over are injuries to the brain, and also when a child is trapped underneath a heavy piece of furniture and suffocates. And the most important thing for parents to know is that most, if not all, of these injuries are preventable.
I urge parents to include securing TVs, furniture, and appliances in their childproofing efforts. Taking a few moments now to anchor and secure TVs, furniture, and appliances can prevent a tip-over tragedy later.
A television can be a child's best friend, but it can also be a parent's worst enemy.
Are your window coverings safe? Corded window coverings are one of the top 5 hidden hazards in the home. About once a month, a child dies from window cord strangulation. CPSC has recalled millions of window coverings in recent years. Window covering cords present the following deadly hazards. A child can wrap the pull cords around the neck and strangle. Or, if cords become entangled themselves or are knotted, a loop is formed in which a child can strangle. A child's neck can become entangled on a freestanding nylon loop or beaded chain. With Roman shades, strangulation hazards exist between the exposed inner cord and the fabric on the backside, or when a child pulls the inner cord. With roll-up blinds, strangulation can occur if the child's neck is trapped between the lifting loop and the blind's material, or if the child's neck becomes entangled in the freestanding loop. Additionally, strangulation can occur if a child pulls on the inner cord of a window blind. Consumers should examine all window coverings in their homes. Make sure there are no accessible cords on the front, side, or back of the product. CPSC recommends the use of cordless window coverings in all homes where children live or visit. For more information, visit cpsc.gov.
Welcome back, everyone. Our next speaker is Elam Tabasi. Elam is the Chief of Staff in the Information Technology Laboratory at the National Institute of Standards and Technology, better known as NIST. As a scientist, she has been working on various computer vision research projects with applications in biometrics, evaluation, and standards since 1999. Before we get started, as a reminder, this forum will be recorded and potentially made available to the public. Thank you for joining us today, Ella.
Thank you. Can you hear me okay?
Yes, we can.
Excellent. I want to start by thanking CPSC, Nevin, and the whole team for organizing such an excellent event. I really enjoyed the talks before me, and they gave a really good segue to my presentation, and also for the opportunity for me to come here and talk about AI, trustworthy AI, and standards for trustworthy AI, and plug in a little bit of the work that we are doing at NIST. So with that, and giving another round of thanks, I'll start the talk. The outline of the talk, what I'm going to talk to today is what is AI? What's AI good for? What's trustworthy AI? What do we mean by trust and trustworthy in the context of AI technology? And then because the panel right after my talk is about standard, get into a little bit of discussions about standards for trustworthy AI. So if you can go to the next slide, please. So I thought of starting by taking you down to memory lane and tell you about the history of where AI started. And everybody agrees that it goes back to a summer project back in 1956 at Dartmouth, that they put a proposal together, and they had this sort of modest goal of a 2-month, 10-man study of artificial intelligence during the summer. And the project was to understand how to make machine use language, form abstractions and concepts, solve kind of problems and of now reserved for humans, and improve themselves. And they thought that a significant advance can be made in one or more of these problems if a carefully selected group of scientists work on that together over a summer. Next slide, please. And as you can see that in the past 62 years since then, the community has been really busy working on many different aspects of the problem formulated for that summer, on natural language processing, on perception, recognition, object tracking, and all of that. One thing that has stayed sort of constant since then is that despite all the advances in AI, and today AI technologies promises to be the most powerful tools in generations for expanding knowledge, increasing prosperity, and enriching human experiences, we don't quite yet have a globally acceptable definition for AI. More and more people are coalescing around the concept that AI is not a single piece of hardware or software, but rather constellations and combinations of different technologies. I believe Professor McDaniel talked a little bit about the 3 waves of AI, that when this all started, AI was trying to, crafted knowledge to understand something about the problem that needs to be solved, craft features, and use methods of planning and knowledge to solve them. That was the first wave of AI. The second wave of AI started by statistical learning and applying statistical learning to, again, human crafted knowledge. And then in the past 10 years, we have seen the explosion of the data compute power, advances in statistical machine learning, paving the way for the third way or deep learning. And now the models can be trained to solve specific problems when all the features, all of the knowledge are being learned from the data by the algorithm themselves. So what I want to summarize here is emphasis on the point that there isn't a single definition for AI that everybody agrees on. This has been evolved in the past 60 plus years, and an emphasis that AI is the fields of fields. This is, I think, Edison mentioned for the electricity, and it's a combinations of the technologies that solve tasks requiring human-like perception, cognition, planning, learning, communications, or physical actions. Also technologies that may learn and act autonomously, whether in a form of software agent or embodied robots. And the versions of this also appeared in the plan that we put out in August 2009 that was based on the definition of the AI in the National Defense Authorization Act of 2019. And some of you that are following the National Commission on AI activities, yesterday they put out their final report, and they also iterated a similar definition of AI. Next slide, please. Professor McDaniel also talked about this, and I usually get this question about what's AI, what's machine learning, how they relate, similar, or they're different from each other. What you see here is a graph in the deep learning book written by Ian Goodfellow, Yasha Bengio, and Aaron Kurwell. These are the fathers of the deep learning, and all I want to say for this one is that machine learning is one subset, one aspect, one dimension of AI, and deep learning is a subset of machine learning altogether. So machine learning is any machine learning is AI. Let's put it this way, but not all AIs are machine learning. Next slide, please. I want to move on and talk a little bit about what is AI good for, why matters, why AI matters, and why we should use AI. And this is a slide that I took it from some of the resource material out of the National Security Commission of AI. As I mentioned, the final report was published yesterday. And they did a really, really nice job on talking about AI use cases, context, and many good recommendations for defense, but also other agencies in advancing AI, trustworthy and responsible AI. What I want to talk about here is on the top of the slide when they talk about why does AI matter, and they talk about AI is already ubiquitous in everyday life, and a lot of consumers, a lot of people may not know that they are already interacting with AI through their, for example, smartphone, Alexa or Siri, or their intelligent devices that they have in their house. Another reason why AI matters is that, or kind of a challenge and opportunity for us, is that deploying and not adopting AI is still a very hard problem. So while in decades ago, it might have been a niche science problem, now, as again was mentioned before me, it's an engineering problem right now, and we need engineering breakthroughs the same way that we need important scientific breakthroughs to improve AI, particularly trustworthy and responsible AI. AI tools are diffusing broadly and rapidly. While developing some of the AI, and particularly at the very beginning, it requires specialized knowledge, but by proliferation of the open source applications, development tools, and also that combined with semi-inexpensive cloud computing, it has become access to AI and development of AI to more than just the niche scientist. And then the last point is that AI is changing the relationships between human and machines, and that's really, really important. And in advancement of the AI, and particularly for the focus on the safety, it's important to remember that there is a team of machine and human, and how much of the automation is needed? Are we going to full automation, semi-autonomous? the role and duration and interactions of the human and machine. Study that, understanding that this is all going to be a technology, a human-centered AI is the technology that we want. And also important questions about what choices delegate to intelligent machines, in what circumstances, for what reasons. That all goes back to accountability and responsibility. Next slide, please. So with that backdrop and context about what's AI, where we started, how far we have come, I want to shift to discussions about trustworthy AI, what constitutes trust, risks, and what needs to be done to ensure trustworthy, responsible AI, again, with emphasis on the safety. Lynn Parker's opening talk also addressed some of these things. As mentioned, in the past 6 decades, we have been seen and observed remarkable advances, and particularly in the past decade, a lot of tasks that was unimaginable for the machines, or very difficult for human, are being now done by algorithms. So that has led to a very sort of a bipolar view that AI is the best thing. It's going to make a radical improvement and make all of our lives better. And there is this pessimistic view that it has risks, it has threats, and even some voices that it can be a threat to humanity. And of course, the truth lies somewhere in between, that while AI offers many positive benefits, it can also lead to significant unintended consequences for individuals, organizations, society as a whole. So what we need to do, we need to have a concerted effort around understanding AI risks, starting with the taxonomy, to be able to understand what it is that we want to measure, to be able to move on, to be able to measure them, assess them. And I believe, again, Professor McDaniel talked about the need for evaluation and certification. And those we cannot achieve them unless we know how to measure them, and we won't know how to measure them unless we have a good understanding of what they are. And that is one of the things that NIST is doing, working with the community to understand AI risks, their root causes, and how to mitigate them. Next slide, please. So understanding and identifying the risks is one aspect. And what I want to should probably mention right here is that Dr. Parker, at her opening remark, very nicely laid out the spectrum of the trustworthiness and the principles, the OECD principles, the principles laid out in the OMB guidance memo for development and use of trustworthy AI. What I'd like to emphasize here is that while those principles, as Dr. Parker mentioned, are really necessary to grant us, to give us foundations of what we want, but these principles, as of right now, there are high-level value-based statements. And the opportunity for us, the tech community, is to get these principles and translate them into technical requirements for the designers of AI systems, for the developers of the AI systems, for the testers, deployer, procurement, all those aspects, to be able to understand and measure and test and certify against those technical requirements. And that is what we want to do. So going to a governance, going to policy, going to towards the regulations, there are several important steps that needs to be addressed. One of them, as we talk, is development of a taxonomy for risks. I'll talk about risk, but the other aspect of that, the positive side, that is trustworthy. So if I'm talking about, for example, bias as a risk, the trustworthy aspect of that is mitigation of bias. But in a whole, what we need to do is first understanding the building blocks or technical requirements for a trustworthy AI. This is actually answering the question of what constitutes trust. What characteristic we want to see in AI technology to be able to have public's trust and confidence in that. And I'll talk about them in a second, in the next slide. Once we know that building blocks, when we know what are those technical requirements, for each of them, we need to develop terminology and taxonomy. So the whole community are on the shared understanding of what it is that we want to talk about, and we want to measure that. Example of that is, for example, explainability, that different community, for example, computer scientists, developers of AI algorithms, and for example, psychologists or sociologists have different understanding and expectations of explainability. So one of the things that we are doing at NIST, again, is to bring all the communities together to have a shared understanding of what each of these technical requirements means. We have started some efforts around understanding of bias in AI, explainability and interpretability of AI, as well as security and resilience of AI. Once we know what it is that we want to measure, we can move on to the development of the metrics and then evaluations and benchmark for assessing the technology to understand the limits and capability of the technology. And once we have all of these things, when we know the technical requirements or building blocks of trustworthy AI, what constitute trust, we have a shared understanding of each of them, what it is that we want to measure. We have metrics and benchmarks and evaluations, how to measure them. And we also know the trade-off among them, how improving explainability can affect, for example, accuracy. Then we can put them all together into a risk management for AI, where the level of risk, the type of risk, and the level of risk are being estimated and worked out based on the different use cases, based on the different applications. And the emphasis here is that one size does not fit all. Some of you may be aware of some of the efforts in EU for regulating AI, and their approach is by identifying quote-unquote high-risk technologies. The point is that you cannot get one technology and label it as high risk. An example of that, I think it was mentioned in the previous talks. For example, face recognition for law enforcement has a much higher and serious risk associated with that for issues such as accuracy and bias, rather than face recognition being used to unlock my smartphone. So the level of risk, the type of risk is going to be very different, depending on technology and depending on the use case. Next slide, please. So I talked about development of the core building blocks of trustworthy AI. This is really getting into technically, in terms of the technical requirements, in terms of basically the language for developers of the technology. What are the characteristics? What are the attributes that I want AI system exhibit? And here you will see the list of 8 that we have come up with the community, and also a question mark as we are exploring this. First and foremost, you want the system to be accurate. You want the error rate to be low. And that is where most of the attention and emphasis and the energy from the particularly from researchers and academia has been on development of the techniques that, for example, more accurate face recognition algorithm. But at the same time, we want them to be reliable. We want them to be secure and resilient. And again, the talk from Penn State talk about this. We have heard and seen and seen demonstrations of many vulnerability of AI system, where intentionally they can be manipulated by, for example, image poisoning to do things that they were not supposed to. So some of you might have seen the example of having a post-it note on a stop sign. The paper was published by Microsoft researchers, that any human brain and eye can see it and understand that this is just a post-it note on a stop sign, but the machine learning algorithm is confused and cannot understand the stop sign as a stop sign. So there are certain vulnerabilities to AI system that needs to be understood and measured. Robustness is another technical requirement. I think the talk before me just talked about the importance of having training data that are representative, that is large enough and representative enough of the application, but also environment. We want to make sure that the AI system is going to behave and show the same level of performance in the environment and with the data during the deployment compared to what it had seen during the training. In technical term, it means that we want to make sure that the model is not overfit. The privacy preserving of the data of the model. Recently, I think about a month or 2 months ago, Google published a paper showing that some of the information from the data, from the training data, can be inferred from the model itself. So care and work need to be done to make sure that data integrity, security, and trust has been enhanced and ensured. Explainable and interpretable, a very important topic. It is important under or already a legal requirement for some disciplines that the algorithm must be able to explain how they come to the conclusion they come to. But this is a really difficult thing. What we mean by explanation, at what level, for what users. So we had a paper out on principles of explainable AI, and we had a workshop in January to go over the comments that we have received. And if you're interested, I can keep you informed and plugged into that research as well. Bias is a really important topic. We have heard a lot about the discriminatory nature of some of the algorithms, particularly for face recognition. I just want to say something here that going back to the importance of terminology and taxonomy and having a shared understanding, we need to know what bias is. And there is, you know, you may think that the term bias is as old as history itself, so we must have an agreeable definition of bias. We don't. And most of the community are referring to bias as the statistical bias, which has a ISO standardized definition of that. The treatment or the error rate is going to be different for different subsystems or demographics. And if we go with that definition, bias is not always a bad thing. Sometimes you design bias in the system. Example of that is insurance, the amount of insurance you pay for car based on age and maybe even gender. So my sons are paying higher insurance for their cars than I do, and we think that it is fair. So that we are working with the community to understand these core building blocks. These are technical requirements. This is an effort to take the principles and translate them into requirements that can be designed, implemented, tested, and sort of I use the word that going from principles to practice. Next slide, please. I'm going to switch gears and talk about standards and importance of standards. And a lot of things that I'm going to talk about has been mentioned in this report that Lynn kindly mentioned during her talk, and that was a task that we had as part of the executive order to develop a plan for U.S. federal government engagement in development of technical standards for AI. What we did as many of our efforts is just bring the community together, convene the community. I should have said it at the very beginning that trust and working with the community is really important for NIST. And this comes from a couple of characteristics of NIST. One and most important is that we are non-regulatory. Second one is the technical excellence. And in that note, while we have really good scientists and really deep bench, we know for sure that we are not the smartest. You know, our scientists are not the smartest. That's why we go out and work with the community to build on the collective wisdom of the community. And that's exactly what we did in development of this plan. Next slide, please. One of the things that the plan talk about, and we asked the community, is tell us what AI technical standards and related tools are needed. And what you see here, sort of a word map, is what we heard from the community, that they want standards around data and knowledge and networking, metrics, trustworthiness, privacy, governance, concepts and terminology came up a lot, safety, risk management, and while the focus was on technical standards, the issue of societal and ethical considerations, fair deployment and use of the AI system was also mentioned and came up. And then the emphasis was on development of technically sound standards that are fit for purpose and are timely. The timeliness is really important. If it's too rushed, then you may not get the right scientific foundations and technically sound standards. If it's taking too much time, then it might be irrelevant. Another really important issue to consider that development is that, again, for the timeliness, is making sure that innovation is not stifled and standards is written in a way that allow for innovation and advancement. Next slide, please. The plan also talks about what standard characteristics are important. How do we know that this is a good standard? And in that topic, it talks about several things. It talks about standards that innovation oriented. They allow, they're not too prescriptive and allow for innovation to happen. The issue of the cross-sector versus sector-specific, as we in standard lingo we refer to them as horizontal and vertical. So horizontal are foundational standards that are technology agnostic, use case and domain agnostic, and can apply to all technologies. And vertical are standards that are focused on certain technologies and use cases. And we need both of them. We need a definitions of we need what constitutes trust, those technical requirements that that can be applied to all sectors, and the definition for each of them that can be applied to all sectors. But when we go and, for example, focus on healthcare versus autonomous vehicle versus some other applications, then the issue of the bias or explainability or vulnerability will have some specificities for those applications. The standards that should be flexible and regularly updated, particularly for a technology such as AI with this rapid pace of evolving and innovation that's happening. They have to be sensitive to ethical considerations to ensure the fair and transparent use and deployment. Clearly stated scope and intended of use to make sure that they are only being used, they're fit for purpose, and we know when to use them. Monitor and manage AI systems. It's really important, particularly for AI technologies that are learning from interactions with the system. So they are not deterministic by nature. They keep changing as they interact with the environment more and more, and use clear language. So they are the requirements are clearly described so that they are not open to multiple interpretation. If they are open to multiple interpretation, then interoperability, that's one of the main goal of standards, is not achievable. Next slide, please. And the other thing that that report talked about, and we are a really big fan of that at NIST, is a very healthy ecosystem of different standard development efforts and activities. We believe that having multiple, this ecosystem and this diversity of SDLs is a very healthy thing. And the plan talk about characteristic of SDLs that particularly federal agencies should look for to engage and participate. And one of them is consensus-based, is having a very clear rule of games, and the decisions and the deliberations are done in a open, transparent, and with respect to majority and consensus viewpoint. It's inclusive and accessible. Everybody that wants a seat around the table can have a seat, and so it's not just restrict participation. Multi-path in terms of looking at both traditional and more innovative venues for standard development. For example, open source has been talked recently a lot about them. Open and transparent processes for development. This is really important, so we know how decisions have been made. And then globally relevant. More and more, as we see, the technology and AI market is global. So it's important to have standards that are globally relevant to avoid fragmentations of market. Next slide, please. And it also talks about, the plan talk about different level of participations for federal agencies at standard development activities. But I think this is all true, that standard, you can have these 4 levels of monitoring, participating, influencing, all the way to the leading. So you can just, for example, an agency can just monitor the activities and projects that's going on, or can participate in the development by providing technical contributions, being around the table and discuss them, can influence them by trying to provide some quantitative data to the development of the technically sound standard, or leading the standard by actually proposing new work item and seeing them through the development. Next slide, please. I think that's where I pause for any discussions. I think I should have some time to answer questions now, but also maybe later. I wasn't looking at how much time I took, but you will see here some where to go and get more information about AI standard in particular, but also the parent webpage talk about the research work that we are doing in AI. Thank you, Nevan. I pause here for any question.
Thanks, Alam. And for the sake of time, if you don't mind, we might defer. We had some questions that came in the chat. We'll go ahead and push those to the roundtable. Again, it was just an amazing briefing, and we really appreciate how informative it was. We look forward to continued collaboration with NIST. You're an incredibly important partner for us, and as you work and your team works very hard to elevate our collective understanding of AI and ML. So thank you so very much. Next, we have our standards panel, as you referred to in your briefing, and that is going to be moderated by Jay Kadawala. So I'd like to turn it over to Jay now for what we know to be just an amazing panel with some esteemed colleagues.
All right, thanks, Nevin. Just have a couple of quick announcements. A reminder that CPSC will be publishing a meeting log on our website that will include a brief synopsis of the forum today, along with slides from our speakers. And all registrants will be emailed a link to the document once it's available. If you have any questions at any point, use the chat tab in your GoToWebinar tool window, and you can type questions which we will either consider at the end of this panel or towards the end of the program when we have a larger Q&A portion. So again, my name is Jay Kadawala. I'm an electrical engineer at the CPSC. I was chosen to moderate this panel because of my technical background, standards development organization experience, and my legal background to pinpoint definitions as they relate to standards development. As many participants might know, building on a strong definitional foundation and framework is extremely important to building standards that are useful, that are useful and important for the consensus process, and also for introducing incremental improvements as technologies advance and progress. Much like our first panel, we have 3 speakers, and we'll follow the presentation with a Q&A session, time permitting, of course. These speakers share vast knowledge with regard to these processes and are eager to share with the group their knowledge, understanding, and experiences with regard to artificial intelligence and machine learning concepts. Our first speaker is Deborah Prince. She's a standards program manager at Underwriters Laboratories, located in Research Triangle Park, North Carolina. She has over 25 years of experience in that role. In that time, Deb has managed not only specific requirements regarding consumer products, but also groups of standards and their interrelationships. This will become apparent as she discusses AI and ML concepts with broad consequences for products, but also among standards, and ultimately consequences for consumers. So with that, I'd like to introduce my UL colleague, Deb Prince. Deb?
Thank you, Jay. Can you hear me? Okay, great. Again, thank you for the opportunity to speak in this panel.
What I plan to do today is take you on a journey starting with traditional standards and what risks they look to mitigate, moving forward into what risks have evolved as products become more smart. So next slide, please. And then one more. All right. So I want to start with what I'm calling a traditional safety standard. An example would be, say, cooktop ranges, UL 858. And I want to talk about the kind of risk that traditional standards have looked at. They may start with construction requirements, the frame of a stove, the frame, the enclosure, the accessibility to live parts, environmental concerns such as corrosion issues, electrical concerns where you have the grounding, you have insulation that you deal with. Then you would move on to protection against injury to the person. That would be your sharp edge test, the strength of the glass, door integrity, surface temperature of that oven. Then you move on to some performance testing. There you would see temperature test, abnormal operation test, endurance test. You might have production and manufacturing testing. And then you would move on to marking and instructions. Your markings where your warnings lie, the instructions on how to use the product safely. Next slide, please. So really the next evolution we saw is when software was added to the product, right? That software allowed remote access. Now users can turn on their coffee pot, lock their door, turn on their lights, adjust the thermostat, close the garage door, all while using a smartphone or a tablet. Now, when you have the smart capability, you also have increased risk. Next slide, please. What might you need to look at? Cybersecurity concerns and the fact, can the product be hacked to override a maximum temperature setting of the device? You have electromagnetic capability concerns that you now have to look at. Does the device interfere with other devices in this vicinity? You need to consider interoperability. You also need to make sure that the functional safety of the product doesn't change. And that functional safety is tied to the product and not that software interface. You need to make sure that that software, the remote operations of said software, cannot disable any protective control or protective function. Then you have to think about the over-the-air updates. Are you going to allow that? Should you consider it? If you do allow it, you need to look at, were those updates complete? Was there interruption? If you're allowing a safety critical change to be made to a product, do those updates have to happen immediately? Or can the user actually decide when they're going to do that update? And I can tell you from experience, when I look at my app, sometimes I'm months late on updating an app. So if it's safety critical change, you want to have some conversation around what you want done with that. Next slide, please. Now, as we move on the evolution of software added and standards here, we're going to talk about artificial intelligence and machine learning. What happens when you add AI or ML to a product or a suite of connected products? Next slide. You add those to the product. Do you have an adverse risk to another product? So would that machine learning change the product that's in a suite? Does it have unintended consequences to those suite of products? So you need to always remember that in addition to the AI and ML in products, that you may have traditional products hooked up within that. You may have some that are just smart, and we need to look at all of those. maybe I'll over off my slides, but so let's go back to the example. Yeah, all right, this is the one I want. So let's go back to the example I said about traditional safeties and warnings. Okay, so now those traditional safety and warnings were to aid the human. When you have AI and ML, human becomes less important in the loop or completely out of the loop, right? They are not the operator anymore of the product. Those warnings, examples, electric blanket, do not plug in while the blanket is still wet. The blow dryer, paraphrasing, but don't operate while in the bathtub, right? The toaster oven, unplug before cleaning. When you use AI or ML, you may be, like I said, removing humans as the user. So in theory, these products could be deemed safer, but actually what changes is your risk profile that you have to look at. We have years and years and years of data of how a human would interact with a product. With AI, you have to consider all the different ways that the product can be used, all the ways the products could work. You look at the worst case scenarios. You have to look at all the environments and the conditions of use. And then what would you do if the product ends up being outside of those operational design domains? How would you handle that? You even have to consider if it's a product that can be transferred back to the human. Next slide, please. Next slide. I'm out of order. So we believe at UL that we have a unique approach to create a narrative, a story per se, a safety case argument. Next slide. In the safety case approach, right, the manufacturer tells a story. They tell the story about everything they've considered, all the environments of use, all scenarios and judgments. The standard does not tell you specifics on how to mitigate the risk, but requires you to consider all those risks and state how you plan to mitigate those risks. Next one. All right, next slide. So a safety case is a structured argument supported by a body of evidence that provides a compelling, comprehensive, and valid case that a system or product is safe for a given application in a given environment. You have your claims, you have your arguments, and then you have conformance, which is validated by an independent assessor. And what we mean by that independence isn't that you have to use a third-party certifier. What we mean is the person that develops the software for this particular case is not the same person that is validating that software. We want that level of independence in there. Next slide, please. So an example of a standard that we have at UL that addresses some issues with the safety case and with AI and machine learning is UL 4600. This is a relatively new standard. It was published back in April last year, and it's for the safety and evaluation of autonomous products. The biggest focus of this standard right now has been with autonomous vehicles, but it can be used with other applications. So, like I said, UL 4600 uses a safety case structured approach. And the criteria that's defined within the safety case structure is set up where you have mandatory requirements, and they are strictly what that says, mandatory. Then you have required requirements. And what's the difference here? Well, required requirement would mean that you don't have to do it if it doesn't apply, if you can argue that it doesn't apply to your product, such as you do not have to have in your ODD that your product will, how you handle snow, right? Driving in the snow, because you claim that your product will never be sold or used in an area that has snow. So you're arguing why that is not required or does not apply. Another example is maybe you do not use machine learning in your tool, so therefore that would not be required. We have highly recommended, we have recommended. In addition, we have the have you considered. We have a lot of examples, and then we have common pitfalls that you might find in that. So from here, the next 3 slides are going to give you some examples of machine learning and AI within UL 4600. Please note that these are out of context, but I wanted to illustrate kind of how the standard shows how you would address like this a machine learning clause when you're building out your safety case, when you're telling your story about why you're safe, how your product is safe enough. So this came out of a section that was talking about the autonomy, functions, and support. And here is where you would address machine learning, training, and B&B approach. I'm not going to read through all of it, but it does show you that for this situation, these are required elements. They're not highly recommended or recommended. And you would go through the shows, you would describe the machine learning. It gives you a couple examples of what kind of description. You would describe the architecture and the hyperparameters. Again, examples. You define those performance metrics and evaluations against those metrics. Again, you're telling the story of how your product is safe. You have your traceability of performance, you have your arguments, then you show your evidence. And again, tools have been in there. And I said that this was a unique case that it has pitfalls. Our standard is unique in the fact that it has our pitfalls. So here's one that I pulled out that just happened to have a pitfall saying machine learning techniques are generally prone to overfitting, resulting in lower than expected performance in the real world operation. Next slide, please. All right, so this is an example of another example of a machine learning clause. Again, data selected, data cleaning you have to show. You have to describe your algorithm selection, your machine learning architecture, and your modeling. And again, out of context, our standard, if you ever want to take a look at it, they are free for view on our website. So again, next slide, please. And one more example of an AI clause. Again, this was in the same section as the previous one, autonomy, functions, and support, where the first one was the machine learning. This is how you deal with the AI. Again, there's this one is a little bit different in the required, right? It has a required that you have to identify and describe it. You have to argue it. Highly recommended has some highly recommended things that you also add into your safety argument. And then recommended items. Next, please. So in conclusion, I'd like to say, as manufacturers gain experience with UL 4600, another unique thing that we built into the standard is a recommendation that knowledge be brought back into the standard. So what you might expect is that they're proposing expanding pitfalls with experience, right? They have expanded use cases. I could see that as we learn more, things that maybe were highly recommended really need to be required, or sliding the other way. So really important, sharing the knowledge of new technology, especially a rapidly changing technology, will help build a safer product. As more and more consumer high-tech products engage with AI and be built with more AI and machine learning, standards development organizations are going to have to be flexible and nimble to address that ever-changing technology needs without being prescriptive. And we believe that UL 4600 is a unique example on how to address that. So thank you. And Jay, I will shoot it back over to you for the next panelist.
Well, thank you so much, Deb. Our next speaker is Heather Banco. Heather is a senior manager at the American National Standards Institute located in New York City. She comes to us today with over 17 years of experience in this capacity. She is the main point of contact for ANSY's Nanotechnology Standards Panel. She is also the administrator of the U.S. Technical Advisory Group, also known in the industry as TAG, to International Standards Organization Technical Committee 229 on nanotechnology. She is the secretary for Working Group 3 regarding health, safety, and environment on that same committee, and the secretary for ISO Technical Committee Subcommittee 13 on powered lawn and garden equipment. Today, she will speak with regard to ISO IEC Joint Technical Committee 1, Subcommittee 42 on artificial intelligence. CPSC is fortunate also to have ANSY's perspective on artificial intelligence and machine learning. With that, here is Heather Banco.
Thank you, Jay, and thanks to CPSC for inviting me to participate. Once again, my name is Heather Banco and I work for the American National Standards Institute. And really, I'd like to introduce folks today to the work of JTC1, SC42, and some of the work we have underway that might be of relevance to this community. So, next slide, please, Jay. So for those folks that may not be familiar, I do want to give a little bit of an introduction to JTC1, which is the Joint Technical Committee on Information Technology. JTC1 was established back in 1987, and it is actually the only joint technical committee that exists between the two major non-treaty organizations of ISO, the International Organization for Standardization, and IEC, which is the International Electrotechnical Commission, because there's interaction and information on both sides that fits under this JTC1 umbrella. The scope of JTC1 is to serve as the international standards activity in the field of information technology. On the U.S. side, the ANSI has served as the secretariat of JTC1 since its creation back in 1987. We provide the management and administration of this technical committee, and we nominate the chair. The chair for JTC1 currently is Phil Wemblum of Intel Corporation. Next slide. A little bit of the structure of JTC1. Obviously, information technology covers a lot of various areas. So at this point, there are about 22 active subcommittees under JTC1 looking at JPEG, MPEG, which we all know are the image files, coded characters, IT security and privacy, biometrics, and obviously the latest, which is artificial intelligence. On the U.S. side, the U.S. is very engaged in the work of JTC1. We participate in 19 of the subcommittees and hold the secretariat for 7 of the subcommittees. So the U.S. is at the forefront of engaging in the information technology standards. At this point, there are 4 working groups that operate directly under the JTC1 structure, looking at smart cities, 3D printing, trustworthiness, which is a newer one, as well as quantum computing, which is the latest working group out of JTC1. I would note that big data was a working group previously under the parent JTC1 committee, but because data is so integral to operability of AI systems, that it was transferred to SC42 when our committee was established. In addition to the working groups, there are 11 advisory groups under JTC1 looking at things relative to the administration of the standards committees under JTC1, as well as exploring new opportunities or new areas of engagement, such as autonomous vehicles or the brain-computer interface. And again, the U.S. is an active participant in these advisory groups, participating in 10 of these. Something else that's different within JTC1 versus the other ISO IEC committees is we have JTC1 past submitters, which is an expedited process which helps fill the gaps of the ISO IEC portfolio portfolio relative to ICT standards. Next slide. So I just want to provide a little bit of background now about JTC1 SC42. I'm not going to go into when we were established. It was back in 2017, but really focus on the scope of this activity. I know everybody today, or a lot of the panelists, have focused on trustworthiness or maybe industry-specific standards. SC42 is unique in that we don't do industry-specific standards. As Elham Tabasi noted, there are horizontal standards committees, and SC42 is one of those. Our scope of work is to standardize in the area of artificial intelligence, serving as the focus and proponent for JTC1 standards program. And I think one of the more important features is providing guidance not only to JTC1, but other ISO and IEC committees that are developing AI-specific applications. We see those committees as the customers that will utilize the horizontal standards that are developed by JTC1 SC42 when they are formulating their own industry-specific standards relative to AI. As you would expect, AI is a very hot topic. It's kind of the word of the year, or the word of the last few years. So we've had a very strong growth of the committee and the work program. We started, I think, with about 18 P members, and now we're up to 30. We've more than doubled the number of national bodies that have been participating and engaging with this committee since it was created back in 2017. And we have a very large participation from not only Europe or Asia or North America, but Africa and the Middle East. So this is very much a globally engaged, globally relevant group. We started with two projects focused on concepts and terminology, not only for AI itself, but relative to developing a framework for machine learning. And now we have over 23 active projects and new work items underway. So this is not just a very static committee as you would expect. It's very dynamic, and there's a lot of engagement and interaction from the membership. Some of the areas that I might go into a little bit later are that we have a project on management system standard for artificial intelligence, something that's been raised by quite a few of the panelists, explainability of artificial intelligence, functional safety, AI data lifecycle. Once again, we develop horizontal standards, so we don't anticipate everybody utilizing them exactly as they are. We hope that the customers, our liaison members, our liaison relationships will utilize our standards when they're developing their industry-specific items. Next slide, please. I'm not going to go over the motivation. The panelists before me have talked about this a lot. I would just note, as Elham Tabasi again noted, AI is going to be ubiquitous. It's going to enter and impact all of our areas of life, whether it's work or play or school. And when we're looking at adoption of AI-related standards, while certainly the technology capability is of primary importance, we're also looking at other issues relative to societal, ethical implications of artificial intelligence, or any regulatory requirements. Something that's also a little more unique about AI is that you have a diverse stakeholder ecosystem. So it's going to be in medical and health applications, fintech, manufacturing, smart manufacturing. So all of these industry sectors are going to be greatly impacted by artificial intelligence, machine learning, and the various technologies underneath. So what this essentially means is that standards aren't just going to be focused on the technical requirements, even though that's going to be a key, or looking at traditional interoperability. We're looking at other issues relative to the societal impact, issues relative to bias, or ethical considerations. Next slide, please. So as I noted, while we are an ICT standards group, we are looking at the broader context in the world at large. So we're looking at the non-technical requirements of KPIs, regulatory and policy requirements, the application domain needs, and then we translate those into the technical requirements. As I noted, we're building foundational standards that the communities will hopefully utilize. As I mentioned, we have projects relative to terminology and frameworks. And the focus is really to not just focus on the technical, but look at the use outside of the technical requirements. And it's our hope that this will promote the development and utilization of AI standards in more industry-specific areas. Next slide is a nice visual schematic that our chair has developed, and he speaks to it much more elegantly than I do. But this is the ecosystem approach that SC42 takes. So we look at the non-technical trends and requirements, whether it's application domain requirements, regulatory and policy requirements, issues around societal, certainly trustworthiness is a major issue, or ethical concerns relative to AI. And then we assimilate those requirements and develop horizontal and foundational projects, whether it's related to data standards, reference architectures, use cases, frameworks. And then we deliver, our intention is to have those deliverables utilized by our partners, our customers, to develop domain-specific standards that build on our deliverables that would then be implemented across diverse application domains, as I've noted before, healthcare, fintech, consumer devices, etc. Next slide, please. So this is kind of a nice visual aid, and it makes it easier for me to talk in general. As you can see, the committee has grown exponentially since we began. Our first meeting was back in Beijing in 2018, and that's in the bottom corner. And on the top left-hand side is our last meeting that we had in person, which was in Tokyo back in 2019. And as you can see, there's great interest, great engagement globally under SC42. In terms of how we develop these projects, we have currently 6 working groups that look at foundational standards. That's where our concepts and terminology work is done, as well as our management system standard. Data, again, data is a major element, not only for artificial intelligence, but definitely you need large amounts of data to help the systems run. So our working group 2 on data actually originated as that working group originally under JTC1. Probably our biggest working group and one of the greatest for this community is on trustworthiness, ensuring that the systems that are developed ensuring their integrity, ensuring that there is maybe, I know Elham mentioned there's different types of bias, but looking at algorithmic bias, functional safety, all of that work is being done under our trustworthiness group. We have a group on use cases and applications, a group on computational approaches and characteristics of the AI systems themselves, and then we have a joint working group looking at the governance implications of artificial intelligence. Obviously, AI doesn't exist in a vacuum. There's definitely things that people need to look at in terms of what is the implication for regulatory bodies or decision makers when establishing AI within their organization or government. Next slide, please. A number of these projects already. We have a management system that's just recently begun development. Some projects that may be more of interest to this group are projects on functional safety and AI systems. The functional safety identifies properties, safety risk factors, methods, and constraints to help developers apply AI technologies appropriately within their organization. One of our newer projects is on objectives and methods for explainability of ML models and AI systems. And this is to help improve the trustworthiness of these systems, looking at guidelines for AI applications and AI systems lifecycle processes overall. As I noted, we currently have 23 projects underway, and our complete work program can be found at ISO.org. Next slide. specific AI management system standard. It has been drafted to apply to any organization of any size, whether a big corporation, multi-country global corporation to small corporations. And the hope is to help them to develop or utilize artificial intelligence responsibly, to pursue their objectives efficiently, and to meet any regulatory requirements or obligations that they may face. Again, even though it's under our, our foundational work, this is intended again to help ensure trustworthiness in the organization and in the system and process itself. And it wants to assure that the organization has considered issues that are maybe not technical requirements, but again, those larger societal requirements of fairness, inclusiveness, accountability of the system. And it really is hoping to allow organizations to check how well it would meet their objectives relative to the use of the AI system. And last slide, please. So just a few concluding remarks about SC42. It's the first international standards committee of its kind looking at the full AI ecosystem. As I noted, SC42 has a very rapid growing work program with 29 projects either published or underway, 6 working groups, an extensive community of people and organizations engaged in the development. We have an extensive and diverse liaison network, whether internal to ISO and IEC, but also ITU, which is the International Telecommunications Union, the European Commission, and the Organization for Economic Cooperation and Development. We are part of ISO, IEC, and JTC1, and we look forward to continuing engaging with the larger community to identify what their needs are relative to AI standards and hopefully fulfill those needs in a technical manner that we can. And last slide is just thank you and the contact information for the chair and myself. And I want to thank everybody for their time today and look forward to further discussions.
Thank you, Heather. Now let's move to a different type of stakeholder. Our next presenter is Dave Wilson. Dave is the Vice President of Technology and Standards at the Consumer Technology Association, located in Arlington, Virginia. These are the same folks that put together the Consumer Electronics Show. Dave and his team manage many groups of industry volunteers to develop consumer technology standards. CTA is currently working on standards in health and fitness, wellness, audio-video systems, privacy and security, in addition to the artificial intelligence topics being discussed today. Dave is a member of the Audio Engineering Society and Institute of Electrical and Electronic Engineers, IEEE, as well as the Society of Motion Picture and Television Engineers. That sounds interesting. Let's get started. Here's Dave Wilson.
All right, thank you, Jay, and thank you to the CPSC for the opportunity to participate in today's forum. And as a participant in the SC42 activities, I say thanks to Heather for that great description. Next slide, please. And so quickly about the Consumer Technology Association, CTA is a trade association representing the world's leading innovators, from startups to global brands. And those innovators support more than 18 million American jobs. And as Jay mentioned, CTA owns and produces CES, the most influential tech event in the world, held every January in Las Vegas, except for this year when it was held in cyberspace. We are very pleased to be here today. Next slide, please. So this forum is about AI and related technologies like machine learning and consumer products that are themselves AIs. As CPSC recognized in the background information it distributed ahead of the forum, Children's toys, residential appliances, and recreational products are being marketed touting the use of AI and the use of machine learning and related technologies to improve product efficacy and consumer experience. In fact, in addition to products that tout these technologies, there are many other AI products that do not tout the fact that they are AIs. AI technology is rapidly becoming necessary for successful business plans. The growth of AI has been fueled by massive amounts of data collection made possible by the internet and continuing increases in data storage capacity as well as computer processing power. So next slide, please. So here are just a few examples of AI or machine learning in common use today. Mapping software. Mapping software is one of those examples. It analyzes traffic patterns in real time and recommends the optimal way to get from point A to point B. Ride-sharing apps use machine learning to predict rider demand, to optimize the placement of drivers, to estimate driver arrival times for passengers, to figure out optimal pickup locations, and more. Next, please. AI spam filters, as was mentioned earlier today, continuously learn how to better identify unwanted messages and block them by using data from a variety of sources, such as the text in the message, or the message origin, or your past reaction to similar messages, etc. Next slide. Personal digital assistants use machine learning to better understand natural language commands and questions from humans. Next. Streaming services use machine learning plus vast databases of audience reactions to music and video, plus your reactions and your viewing habits to recommend things that you might like. Next, smart thermostats learn from the heating and cooling patterns in your home to anticipate, and automatically adjust the temperature to suit your preferences. Next. And some toy dolls use natural language processing and machine learning to listen and respond to children. So when it comes to the product safety issues that are typically addressed by CPSC, it's not clear that an AI requires a new approach. How a smart TV goes about recommending what videos to watch would not really be expected to impact how safe the TV is. Likewise, the audio communications that a toy doll has with a child would not be expected to affect how safe the doll is. There may, as mentioned earlier today, maybe there's privacy or security issues, but safety, I'm not so sure. In general, as long as a product incorporates safeguards that keep it from becoming unsafe when used by a human, then whether it's an AI or not would not be expected to impact how safe it is. In fact, in all of the examples that I listed, shown here on the screen, I cannot think of how any of these would be any less safe than another product performing the same function that's not an AI. Next slide, please. So CTA believes that a product designed to be safe when operated by human intelligence is also likely to be safe when operated by artificial intelligence. The safeguards that make a product safe are just as effective in both cases, we would think. Next slide, please. To illustrate this point, let's consider the case of the smart thermostat. An AI that is a smart thermostat could be used to control something that's potentially dangerous, such as a gas burner. However, gas burners have safety systems built into them to prevent them from harming people or property. So let's go into some detail on this, and as a good example of how products have built-in safety features that prevent AI systems from making them dangerous. Next slide, please. So many gas burners, like you might find in your furnace or your fireplace, have a pilot light. That's a small flame that's always on, like you see there on the lower left quadrant of this slide. It's the blue sort of rocket ship looking thing there. Next slide. Well, when gas is allowed to flow through the main burner, the small pilot light flame causes the main burner gas to ignite. thus creating the larger fire that's used to heat your home. The flow of gas to the main burner is controlled by a valve that's represented by the red knob that's the farthest right there on the slide. There's the two red knobs, and the one on the right is the one controlling the main burner gas. There's also the other valve that's on the left that controls the flow of all of the gas to both the main burner and the pilot light. So as I'm sure all of you are very well aware, gas is dangerous. If a room fills up with gas and a spark goes off, there can be an explosion. If the room fills up with gas and a spark doesn't go off, but there are people in the room, say perhaps sleeping, they could die from just breathing in the gas. But as long as the gas is coming out of the burner and burning, it's not a problem, because if it's a natural gas system, the product of this combustion is mainly carbon dioxide and water vapor, neither of which are deadly to humans. So when you have a gas burner system like this, it's extremely important that you don't let gas flow through the system if there's no fire. That is, it's extremely important that gas not flow if the pilot light goes out. So I promise this is related to AI, so just hang with me here. Next slide, please. So here's how the gas burners address this hazard. First of all, the valves that control the flow of gas, shown in red on this slide, are by default closed. The way that they get opened is by applying a voltage to them. If there's no voltage, then the valves stay closed, gas does not flow, and nothing happens. So within the burner system, there's a device called a thermopile. That's the green, the thicker green line there on the right, just under the pilot. A thermopile is made up of several thermocouples, which are connected together. There's also typically a thermocouple in the system, but let's not get too complicated here and just show the thermopile. A thermocouple is a piece of metal about the diameter of a wire, and a thermopile is about the diameter of a pencil. And the way that they function is they're made up of two different types of metal, and when those two merged different types of metal are heated up, a voltage is created. This is because there's the two different types of metal, they each react differently to the heat, and this causes a voltage between them. So the important bottom line function of the thermopile is it's a way to use fire to create electricity. So remember, we said that the valves, the two red things, have a default position of always being closed. Their default position is no gas gets through. But when a voltage is applied to them, then they open up and let gas flow through. So as long as the pilot light is on, the valve stays open and gas continues to flow. But if the pilot light goes off, there is no more voltage supplied to the valve. It shuts off the flow of gas, and this is an important safety feature, of the burner, preventing uncombusted gas from filling up the home. So let's go to the next slide, please. So there's a bit more to the story. We need to get to the part that really relates to AI, which I know you're all anxious to hear about. So beyond basic safety circuitry that we've already discussed, there's also the control circuit that's used to turn on the main burner. The pilot light's there, it's on all the time, and it's providing an electric signal to the main valve that keeps gas flowing through the system, but that valve that controls heat to the main burner stays closed because you don't always need heat, in your house. So that valve only gets opened up when it's asked. And next slide, please. The way that valve gets asked to open up, voltage gets applied to that second valve, and it gets opened up and lets gas flow to the main burner is through some form of a switch. That could be, a wall switch. It could be a wireless remote. It could be a plain old, dumb thermostat, or it could be a smart thermostat. So now we finally gotten to the point about AI. So imagine that you have a smart home and your thermostat is an AI, and it uses machine learning to figure out your habits and learn how best to set the temperature in your house. So, well, what are the safety concerns associated with having an AI controlling your furnace? Well, I would argue that there really aren't any, because the main hazard would be if the thermostat, that is the AI, turned on the main burner without realizing that the pilot light was out, thus filling up the house with gas. However, if it tried to do this, it wouldn't be able to turn on the main burner because the lack of the pilot light would have caused the main gas valve to close and no gas could flow through the system at all. So safety is built into the system, and it doesn't matter whether a human tries to turn on the burner with a wall switch, whether a plain old dumb thermostat tries to turn it on, or whether an AI tries to turn it on. The main burner valve will not let gas through if the pilot light is out. Safety is built into the system regardless of who or what is controlling it. So that, in a nutshell, explains why CTA believes that products designed to be safe when controlled by humans are likely to be safe when controlled by AIs. We just went through in detail this example with the gas burner, but there's other products that also have safety built in. They may have fuses to prevent, electricity from flowing if the current is too high. They may have some sort of mechanical safety feature to prevent human body parts from coming into contact with sharp edges. And earlier today, one of the other presenters gave an example of how a water leak detector might get soaked by a fire sprinkler system, and that the water leak detector would think that it's a leak and shut off the main water supply to the building, thus shutting off the fire sprinkler system. But the simple solution for built-in safety there is to have the fire sprinkler system on an independent water line so it cannot be shut off by the leak detector. And I'm not an expert in that element of building codes, but I suspect that there are building codes out there, at least for some types of buildings, that require that there be the fire suppression system be on a separate plumbing line. So there's a long list of ways that safety gets built into products. Next slide, please. So what does CTA think that the CPSC should do when it comes to AI and machine learning? Well, we think that CPSC should coordinate its effort with other federal agencies and other stakeholders to ensure that its work is consistent with the work done by others, which it's doing very well today with this forum, and that CPSC should continue to support industry-led consensus-based standards. Next slide. And on the subject of industry-led standards, just to let you know, CTA is one organization that's been developing standards related to AI and tangentially somewhat to safety, maybe not product safety per se, but trustworthiness. CTA's Artificial Intelligence Committee is addressing the use of AI in healthcare, and it recently published a standard that identifies core requirements for an AI healthcare solution if the AI healthcare solution wants to be considered trustworthy. The standard is ANSI CTA 2090, the use of artificial intelligence in healthcare, trustworthiness, and it's available for free at the very convenient URL on the bottom of the slide there, or you can just search for CTA-2090 and you'll find it. Next slide, please. So in conclusion, CTA's view is that a product designed to be safe when operated by human intelligence is very likely to be safe when operated by artificial intelligence. I know that there's concerns about privacy and security, but we view those as separate things that are not really the same as artificial intelligence controlling a product. So we think that if a product is safe for humans to operate, then it should also be safe for an AI to operate in most cases. So thank you. So next slide. Thank you so much for the opportunity to share our thoughts today. Turn it back to you, Jay.
Thanks a lot, Dave. I want to take a moment to thank all of our panelists. We did have some questions, but we're going to move those to the Q&A portion towards the end of the program. So I just wanted to extend an invitation to our panelists to join us for the Q&A session at the end of the program. Definitely, we want your input for specific topics that those questions are asking of you and also other participants. So please join us for that part of the program towards the end. It's now time for our lunch break. And so during the lunch, CPSC will still show some informative videos for all the participants that are interested in that information. And so everyone, please plan on joining us back for the remainder of the program at 1 p.m. Eastern Time. So that's 50 minutes from now. And we'll resume with panel number 3 at 1 p.m. Thank you so much.
Pop quiz. What is CPSC?
Something regarding consumers and safety?
Consumer Product Safety Commission.
The U.S. Consumer Product Safety Commission, or CPSC, is a small independent government agency with a large mission. We protect the American public against unreasonable risks of injury or death from consumer products. From toys to cribs, CPSC protects the public by issuing recalls, developing mandatory safety standards, research and testing, product screening at the ports, and developing educational campaigns like Pool Safely and Anchoring. The Consumer Product Safety Commission also provides resources designed to help keep families safe. Get the latest recall information at cpsc.gov or download the new Recall app. Join our Neighborhood Safety Network and download life-saving toolkits for your family and community. Go to saferproducts.gov to research and report unsafe consumer products. Need to talk with someone? Call the CPSC hotline and speak to one of our trained professionals about your product safety concerns. For nearly 50 years, CPSC has put your family safety first because your safety is our business.
Having a larger facility with more high-tech equipment will help the CPSC be more efficient and productive in testing products that could pose a danger to consumers.
I'd like to welcome you to the Outdoor Power Sports Testing Laboratory. This laboratory is equipped with data acquisition equipment as well as this tilt table built into the floor where we perform the parking brake test that is part of the standard. As you can see, the vehicle on the left continues to move. The standard says that the vehicle should be able to maintain its position on this slope facing both downhill, forwards, and backwards for 5 minutes without failing, and clearly the one on the left has not passed that test.
This is the cyclic testing lab. What we do here is we simulate the lifetime of use for cribs, for example, by running them through our crib shaker test, crib impactor test, side rail impact test, and then our slat test. And combined, these simulate a lifetime of use by a typical child out in the field.
This is the durable children's product testing area. We have the toy lab also over here, and what I'm going to be showing you guys today is the walker stair test. And what we're looking for are skid pads on the underside of the baby walker. Right now there's only casters on it. There should be rubber pads here so that when it falls over the stairs, it stops short and doesn't tumble. The velocity of the 8-pound weight falling will create a set speed that we know a child can achieve. So obviously, if it had the skid pads on it, it would have stopped short and it wouldn't have gone over the edge. This is the impact testing area, and what we're looking for here are any small parts or sharp edges that break off during the impacting. Depending on how old the child is, depends on how high we'll drop it from. Pretty simple test, but we're going to take it down so that it breaks one of the laser beams, but not both. That would be too far. That'd be outside the regulation. And again, if we get any small parts or sharp edges out of that, that's a failure.
You are in the bike helmet impact lab, and here we test helmets. This particular test raises up the helmet so that it reaches an impact velocity of approximately 11 to 14 miles an hour, and that is roughly comparable to a lot of bicycle helmet impacts and injuries. This is an important test because it ensures that bike helmets comply with the federal regulations. And in this particular example, like I've got in my hand, on the outside, looks very, very similar to anything else that you would see in the marketplace, and yet it broke. So that's why we test.
This is the CPSC Flammability Laboratory. We have the capability of evaluating mattresses, mattress pads, and children's sleepwear to the federal regulations. In this new lab space, we have a special burn room that is capable of handling larger scale fires. The room is instrumented with a special hood that can measure the heat release from the fire below. This is an example of the children's sleepwear test. The sample is hung in the test cabinet. Small flame is held for 3 seconds to the bottom edge. It's a vertical ignition. Once the specimen is ignited, it's allowed to burn until completion. As you can see from this example, large flames burning vigorously. It would not give a child the opportunity to react very quickly, and therefore this sample fails the test.
We're here in the chemistry lab of the CPSC, and we test children's products for lead in paint and plastics. We're testing using X-ray fluorescence, and that's something we do with the same instruments at our ports of entry. We also have another special kind of XRF called an HD XRF, which we can use to measure lead in paint down to 0.009%, which is the regulatory limit.
One of the other things we do in the chemistry lab is test for phthalates. We have a brand new instrument called the Direct Analysis in Real-Time Mass Spectrometer. It's a real advantage for testing for phthalates. Traditional testing requires a lot of sample preparation. We have to cut the sample up, dissolve it in some harsh organic solvents. We run instruments, their run times can be anywhere from 20 minutes to a half hour. But this direct analysis instrument allows us to put the sample in without any sample preparation. We can just take a quick glass tube, rub it on top of the sample to get some of the material off, and put it into the instrument. Hot gas runs over the sample and brings it into the instrument, and the instrument actually measures the mass of the different molecules that enter. We can look at the printout, get an idea of what molecules are in there, and then we get a quick yes or no answer: are there phthalates?
The CPSC stands for safety, and this state-of-the-art facility is a testament to our renewed commitment in keeping families safe.
Just one more rinse and you are all done. I wonder who that could be. I'll be right back, sweetie.
Children can drown quickly and silently.
About 2/3 of in-home drownings occur in the bathtub.
Oh no! Call 911!
Turning your back for a moment could mean missing out on a lifetime of moments. It only takes a few seconds for a child to drown. Never leave young children alone in the bathtub or around a container of water. Visit cpsc.gov to learn how to prevent in-home drowning.
While pools are an obvious risk, parents shouldn't let their guard down around other hazards such as bathtubs, buckets, toilets, and other water-bearing containers. A child can drown very quickly in only inches of water. Bathtubs account for the highest percentage of in-home drowning deaths. The majority of bathtub deaths and accidents occur when the caregiver is not present. Always keep a baby at arm's reach. Never leave a child alone in a bathtub, not to answer a phone or door, or to retrieve a towel or other item. If you must leave the room, take the child with you. Never leave an older sibling to watch a younger one bathing or playing near water. A baby bath seat, no matter how seemingly secure, is not a substitute for supervision. A bath seat is a bathing aid, not a safety device. Even when a child is in a bath seat, you should always be in arm's reach of the child. Buckets and pails, found in every home, are a real hidden hazard. Never leave a bucket containing even a small amount of liquid unattended. When finished using the bucket, always empty it immediately. Young children are drawn to man-made landscape ponds, which are becoming more and more popular in home gardens. These features often have no barriers to prevent access by young children. Children can fall head first into a toilet. Keep the toilet lid down to prevent access to the water. Consider using a toilet lock to stop young children from opening the lids. Consider placing a latch on the bathroom door out of reach of young children. Remember, little children can drown in only inches of water. Don't leave children alone around bathtubs, toilets, buckets, and other water-bearing containers in the home.
Whether it's careful candle placement or checking the warning label on holiday lights, simple safety tips can go a long way in preventing fires and injuries this year. When purchasing an artificial tree, do look for the label for fire resistant. Although this label does not mean the tree won't catch fire, it does indicate the tree is more resistant to burning. When purchasing a live tree, do check for freshness. A fresh tree is green, needles are hard to pull off from branches, and do not break when bent between your fingers. The bottom of a fresh tree is sticky with resin. When tapped on the ground, the tree should not lose many needles. When setting up a tree at a home, do place it away from fireplaces, vents, and radiators. Because heated rooms dry out live trees rapidly, be sure to monitor water levels and keep the stand filled with water. Indoors or outside, do use only lights that have been tested for safety by a nationally recognized testing laboratory, such as UL or ETL. Use only newer lights that have thicker wiring and safety fuses to prevent the wires from overheating. Check each set of lights, new or old, for broken or cracked sockets, frayed or bare wires, or loose connections. Throw out damaged sets. When using lights outdoors, do check labels to be sure that they have been certified for outdoor use and only plug them into a ground fault circuit interrupter. Keep burning candles within sight. Extinguish all candles before you go to bed, leave the room, or leave the house. Keep lighted candles away from items that can catch fire and burn easily, such as trees, other evergreens, decorations, curtains, and furniture.
Keep your holidays as safe as they can be. For more tips, visit cpsc.gov.
I decided I wanted to launch a mortar shell style firework that you might buy in a fireworks stand. I put the mortar shell actually inside the tube, made sure that it was all the way at the bottom. I lit the fuse, and then I decided to hold the fireworks above my head. The mortar shell then exploded inside of the tube instead of launching out of the tube. When the mortar shell exploded, I have a scar in this hand and I have a scar here, and literally what happened is my hands folded over backwards. So off of my left hand, I lost my pinky, I lost my ring finger, I lost the tip of my middle finger, and I lost my thumb. On my right hand, I lost my index finger, the tip of my middle finger, and severely damaged the tendons in my thumb. The doctors at the time didn't think that they were going to be able to save my thumb, that they thought that most likely they would have to amputate it, but they were able to save it, thankfully. These were legally purchased fireworks. I had used them in the past, and I'd had plenty of experience with them for years and years of shooting them, and had never had anything go wrong until this one exploded inside the tube, detonated in my hands. The biggest thing I would like to get across to everybody is that things don't always go as we plan. Fireworks, mortar shells are very dangerous. People die using them, people get hurt using them, people lose fingers using them, and it changes your life forever. So I would say leave the mortar shells to the pros and leave them on the ground if you're going to use them.
Uphill, downhill, through the mud, and through the trees. ATVs can take you on an adventure. But before you do anything on an ATV, take knowledge to the extreme. Know the basics. Take a training course. Wear a helmet. Don't ride on paved roads. And don't ride tandem. That's knowledge you can take anywhere an ATV takes you. For more information, log on today to atvsafety.gov.
You ready to go home?
Yeah, sure.
All right.
Here she comes. She sure looks ready to take on this ride.
That's right, Megan. She's been riding at the top of her game lately.
I love how she puts away the headphones.
Yeah, she's not about to be distracted.
And look at that poise. She slows down at intersections, making sure the path is clear.
Nice, smooth braking. Here's that bump. Could be trouble. Will she lean back and use that same smooth braking technique?
Indeed she does.
Look at that expert parking. And that's how a champion gets it done, folks.
When they were younger, my kids referred to us as the toy police, which we affectionately call ourselves as well. I think a consumer assumes when they walk into a store that the products they're looking at are safe, and that's where we come in.
Anything that could potentially harm consumers, my job is to stop it here.
We're co-located with CBP, Customs and Border Protection, at the ports. We make sure these products are safe and are not going to harm children, loved ones, or their home.
We review incoming merchandise, based on what's listed on the manifest and the shipping lines. We decide what shipment might be the highest risk and what we really want to take a look at. We bring the merchandise into a warehouse. They strip out the whole big container, and then we go through that merchandise. And we open up the boxes, we see what's inside.
Now, if that's toys and children's products, we're screening for lead, we're screening for small parts, we're screening for certain labeling requirements.
And then we try to decide if it's something that we need to test further, if it's something that might be hazardous, if it's something that we cover, and we think may look like it poses a little bit of a hazard, then we'll go ahead and we'll do some screening and some testing here at the port.
Unfortunately, when we're screening products, we still see lead. That's lead in paint, lead in content.
When you go out and you buy a toy for your child, for the most part, you're thinking that this is something that is going to be fun and that your child is going to like, and you shouldn't have to worry that it's going to harm them.
It's easy to be passionate about our job because we keep people safe.
We all go to the store. We all have, families. My kids play with toys all the time.
Most of us are consumers. Most of us are parents. It's a rewarding job in that you know for a fact that you are preventing injuries and you're preventing house fires and kids from getting hurt.
We want to make sure that you're not going somewhere paying your good hard-earned money and then you bring home a junk product that's going to end up hurting you and your family.
Welcome back. I hope everyone had an enjoyable lunch. For those of you just joining us, I am Nevin Taylor, Chief Technologist at CPSC. In this role, my primary goal is to set the agency on a solid path for establishing policy on AI and ML as it relates to consumer product safety. To this end, there is an initial framework to assist in the development of policy and provide an approach to analyze this technology in consumer products. Please allow me an opportunity to provide a quick overview of our proposed 4I program, which is the framework that outlined in the public notice and referenced at the front of the forum. If I could have the 4I chart put up, please. This progressive program is designed to screen for the purposes of identifying the components of AI and ML in consumer products. For those products that do have the basic ingredients for machine learning and artificial intelligence, then we have the next step, which will assess the implications and the functionality of the many features that this technology offers. Then we'll go to the third phase, which is analyze the impact they have to ensure the consumer safety. And finally, unlike most products that only improve when they come out with a version 2 or the manufacturer upgrades or the industry designs new capabilities, this particular product in AI machine learning has the ability to, upgrade and evolve itself. So we will take a fourth phase to ascertain the iterations as they adopt in a radically evolving marketplace. We are fortunate to have a panel of industry, academia, and government subject matter experts to speak to the specifics of each of these endeavors, moderated by Einstein Miller. As a reminder, please know that this forum will be recorded and potentially made available to the public. Einstein?
Thank you, Nevin. Hello, everyone. Good afternoon. My name is Einstein Miller, and I'm an electrical engineer here at CPSC. This panel will highlight a proposed framework for the CPSC to approach AI and ML in consumer products. The goal is to ensure that consumer products with AI and ML capabilities are safe. Our first speaker is a collaborative team of mechanical and electrical engineering students from Worcester Polytechnic Institute, or WPI, will be addressing the identify part of the framework. This project team, all of whom are in their junior year at WPI, worked on a project about identification of AI and ML in consumer products. This project was a partnership with the Consumer Product Safety Commission to develop a methodology to identify AI and ML in consumer products. In this 10-week project, WPI students wrote a report on AI and ML identification and presented the results of their work to the Consumer Product Safety Commission. They will also present their results to you today. Here to introduce the team is Dr. Holly Alt, Professor Emerita, Mechanical Engineering, Director of the Stockholm Project Center, and Co-Director of the Armenia Project Center at WPI. Thank you for being here. The virtual floor is yours, Dr. Alt.
Thank you, Einstein. It's a pleasure to be here. I'd like to take this opportunity to thank the Consumer Product Safety Commission for hosting the students. The students worked on this project as a part of our global projects program. WPI has over 40 project centers around the world, and we've been working in Washington, D.C. with various federal agencies since the late 1970s. So you can see we've had a long partnership, and we've enjoyed the support of the Consumer Product Safety Commission for many, many years. This year, 4 students, as Einstein mentioned, worked on the initial phase of the 4I project, and that was the identification of artificial intelligence and machine learning in various consumer products. And so this was quite a challenge for 4 students who are not computer science majors and who have a good solid engineering background, but they learned a tremendous amount. And so at this time, I'm going to turn it over to the team, Ben, Austin, Tyson, and Logan, and let them tell you what they learned during their 7 weeks working full-time with the Consumer Product Safety Commission.
Yeah, thank you, Professor Alt. So I'm just gonna kind of get right into it. So thank you everyone for coming. Our project was artificial intelligence and machine learning in consumer products. We focused pretty much primarily on the identification of artificial intelligence and machine learning in terms of the 4I system. Next slide, please. So the issue that the CPSC faces is that artificial intelligence and machine learning are emerging technologies that are not currently well defined, but very common in consumer products. It is important that we are able to confidently say whether or not the use of AI or ML poses a threat to the safety of consumers. Helping with the identification of artificial intelligence and machine learning in consumer products, as they are new and emerging technologies, is essential. Next slide again. All right, so before we, all right, yeah, so this is our project goal. Our project goal is to create a methodology to determine artificial intelligence and machine learning capability. So that is gonna turn out to be a sort of screening process or system to decide if a product we deem as artificial intelligence or machine learning capable. This is gonna involve creating some working definitions, and also we will need to identify the base components involved in a artificial intelligence or machine learning system. What I mean by components is identifying kind of which parts, both physical and conceptual, are needed for us to deem a product as AI ML capable. Next slide, please. Yeah, turn it over to Austin.
Thank you, Logan, for giving the overview of our project. Now we'll get into the specifics of AI. Next slide, please. Throughout the course of this project, our team has created an applied definition of AI. Definitions of AI vary among experts, so it's crucial that we lay a foundation to what AI is for our project. AI is a field of computer science that allows the system to interact with its environment in a manner that resembles human decision-making. Now we'll discuss what are the main components that make up an AI-capable system. A component is the aspects or qualifications that are necessary for the existence of AI. It was determined that AI is made of these 4 components: data source, algorithm, computation, and connection. Next slide, please. The first component is data source, used by a device to collect input. An AI system relies on some form of input to be processed. In many electronic devices, sensors are used as a source of data, and a sensor is a device that collects input data that can be processed by the system. For example, photocell or ultrasonic sensor. And also on the slide, you see a keyboard. And a keyboard signifies human input, or other examples of that is touchscreens, switches, potentiometers, or things that are done by human manipulation. Next slide, please. The next component is algorithm. An algorithm is simply the software code in the system that allows for the device to make decisions. Or in other words, it is a set of instructions designed to perform a specific task. Next slide, please. Computation capability is a third component to make up an AI system. Computationally usually requires central processing unit, or CPU. A CPU manipulates data collected from sensors to allow the system to make intelligent decisions. The operations of a CPU in a system are to fetch, decode, execute, and write back. Common examples of a CPU are microcontrollers, embedded processors, and microprocessors. Next slide, please. And the last component for AI is connection. Connection is a linkage through networks that allows for the flow of information throughout the system. Common examples of connection is a data bus, an electronic point-to-point connection for the purpose of transferring binary code through a system. Oh, another example is IoT, or Internet of Things, a group of connected products that send data to the cloud to be processed. Information is then sent back to the device so the device may respond. Next slide, please. Putting these components together, a system can now be identified as AI capable. Our team decided the best way to portray this relationship between the 4 components was a decision tree. In a decision tree, you must answer yes to all these questions for the system to be AI capable. Each step summarizes what the component does in the AI system. We envision this tree working when examining a consumer product. The CPSC can use this tree when studying a product to see if the device is AI capable by going through each of these questions. Now I can demonstrate the use of this decision tree and some examples of consumer products in the next slide. A standard home security system. These usually incorporate cameras, door sensors, and motion detectors. Those would be your data source. Algorithms would be the if statement in the system. The machine will respond to the given input based on the sensors. A processor will process the information, and connection allows for the flow of information throughout the system. Therefore, answers yes to the following questions, so the system would be AI capable. Next slide. A hoverboard. The data source for a hoverboard would be the gyro sensors in a device to keep it stable. Algorithms would be in the system to give response to given input that is placed by your feet. There's a CPU in the device, and there's connection throughout the whole system. Therefore, a hoverboard would be AI capable. Next slide. Your standard Christmas lights timer. The data source would be, there'd be no data source throughout the system, no algorithm, computation, there's no computation because there's no CPU in the system, and the only connection would be the outlet to your external device. Therefore, answer is no to all the questions, so the system is not AI capable. Next slide. And then you got your standard headphones with a microphone, as I'm wearing right now. The data source would be the sensor or microphone on the headset. There's no algorithms usually found, no CPUs in the headphones, and the only connection would be the connection from my headphones to my external device. Therefore, it only answers yes to 2 of the questions, so the system is still not AI capable. Next slide. Finally, we got your power tool. The data source or sensor would be the switch to activate the device. There'd be no algorithms, no CPUs, and no connection to the system. So the system is not AI capable. Next slide. Now that we've discussed AI, the components involved, and the process of identifying capability, now we'll talk about machine learning. Ben will walk us through what machine learning is and how it can be identified.
Great, thanks, Austin. So Austin just went over artificial intelligence, gave our working definition, the components of AI, and then went through our screening process and gave some examples of AI in consumer products. So now we'll go through a similar process with machine learning. Next slide, please. So for this project, our working definition of machine learning was that ML is the process of a system gaining knowledge or experience from giving data and improving its performance over time without being explicitly programmed, which involves monitoring, modeling, and measuring. So we'll talk about those components on the next slide. So like I said, monitoring, measuring, and modeling are the 3 components for machine learning capability. And in order to be considered ML capable, the product does have to have all 3 of those components. Next slide, please. So the first component is monitoring. And monitoring is about assessing outputs to observe the information. So that terminology can be a little bit confusing, of assessing outputs, but machine learning takes in answers to create more accurate or better answers. So a common example is baking cookies. If we wanted to use machine learning to bake better cookies, then we first need to start with a batch of cookies, and that would be the output. So monitoring assesses outputs. Next slide, please. And the next component for machine learning is measuring. And measuring looks at the differences. So the image you see here is a bunch of different pictures of mops and dogs. And a common application of machine learning is image processing, where the ML system would look at these different images, find the differences, and be able to determine what the image was showing. Next slide, please. And the final component for machine learning is modeling. So the ML system would measure, take all those differences, and then create a model. So an example of that would be a vacuuming robot that, as it travels throughout the same rooms over and over, it creates a model of that room so it can successfully navigate. Next slide, please. So just like AI for machine learning, we've created a screening process. And the main question for machine learning is whether the product is able to change its behavior over time. So a system that is improving and gaining experience indicates that it has machine learning capability. And there's those three components of monitoring, measuring, and modeling. Next slide, please. So now we have some examples of machine learning capable products. Something like a smart refrigerator or an automatic vacuum might be able to change its behavior. The refrigerator might be able to recognize user patterns. And the vacuum, as I was saying before, is able to navigate through a room, find the differences, and create the model. So these types of products would be machine learning capable. Next slide. A normal electric fan doesn't change behavior, has no components of machine learning, so it's not ML capable. Next slide, please. A normal TV monitor also doesn't change behavior. The monitor doesn't monitor, it doesn't measure or model, so it's not ML capable. Next slide, please. So that was machine learning. We went over our working definition, the different components, and some examples of ML and non-ML capable products. And now Tyson is going to summarize our project.
Thank you, Ben. So let's quickly cover some of what we covered today. So first off, we talked about the working definitions of AI and machine learning. Flowing into that, we talked a little bit about the components and the screening process of AI, which involve the data source, algorithm, computational capability, and the connection, and talked a little bit about the screening process to identify AI-capable products. And lastly, we also covered machine learning capable products and that screening process, so the components being monitoring, measuring, and modeling. And we also identified specifically how to identify high machine learning products. And that should cover most of the key ideas of phase 1 identification. Thank you for listening.
Thank you, Logan, Austin, Ben, and Tyson. The next presentation is on the implications of AI ML by Swathi Young. Swathi is the Chief Technology Officer at Integrity Management Services, Inc. Swathi has over 20 years of experience across many organizations such as Amtrak, SunGard, GE, and Oracle. She's also a crusader on the forefront of change with regards to machine learning, AI, and emerging technologies. Swathi also founded and runs DC Emerging Technologies, an active industry-oriented group that now boasts over 2,000 technocrats. The group focuses on harnessing emerging and disruptive technology, such as the Internet of Things, 3D printing, unmanned aircraft systems, AI applications, and more. Swathi is also affiliated with the American Council for Technology and Industry Advisory Council, ACTIAC. In 2020, Swathi was selected to be a member of the Forbes Technology Council, where she shares her expert insights in original business articles on Forbes.com. Thanks for speaking today. Swathi, the virtual floor is yours.
Thank you, Einstein, and good afternoon, everybody. Today, I'm super excited to cover the implications of AI and ML in consumer products. Next slide, please. As we all know, the mission of U.S. Consumer Product Safety Commission is to protect the public from unreasonable risks of injury and death from consumer products. Next slide, please. And I often like to joke, debate, and discuss with my friends. Obviously, when in terms of digital products, we avail a lot of free products. And when the product is free, especially digital products, they say the consumer is the product. But some of my friends would like to debate with me saying, of course, the artificial intelligence robots are coming for the humans. And humanoid robots are going to overtake humans, and artificial superintelligence is actually going to lead to the death of humanity as a species. So I like to remind them and say, let's not debate about the humanoids and the robots. I think in the near future, there are more chances of your house getting burned down by smart devices than robots taking over the world. Jokes aside, I want to acknowledge the smart devices and smart consumer products we use from the moment we wake up to the moment we go to bed. So think about waking up and check your email, and you all know this spam filters in your email uses machine learning. Then we open our garages or our front doors that does have artificial intelligence enabled safety products that are being used, and then so on and so forth. But of note is there are also smart ovens these days that have cameras and would detect the temperature and personalize the way you want your food to be warmed up, as well as smart refrigerators that taken to the extreme can order your milk and eggs for you. How I wish I had that already. But on another note, I want to emphasize that imagine the smart refrigerator actually notices that nobody is at home for the last couple of days or weeks, and it decides to turn off the refrigerator to conserve electricity. In doing that, it can lead to perishable foods, which is a biohazard to us. And the smart oven, which I've given as an example also, if some hacker happens to manipulate the timing of the oven or the temperature of the oven, it can actually explode, it can burn, and also cause a fire in your house. So I think in the near future, the chances of us actually facing dangerous conditions at home using smart devices is much more than robots taking over the world. Next slide, please. So AI is the new electricity is a very famous adage by AI expert Andrew Ng, who is the co-founder of Google Brain. And you know, he also co-founded Udacity, from which you can actually learn machine learning, you know, online programs and stuff like that. But this is interesting that AI is the new electricity. I think AI is ubiquitous today, and whether we know or not, or whether we like it or not, it's prevalent everywhere. And it has an impact on us as humans in the way we think, work, interact with other people. But more importantly, why are manufacturers using AI and ML in consumer products? That's a question to be pondered upon. Next slide, please. So essentially, in a nutshell, consumers today are very technologically savvy and they want a wow experience. Gone are the days when I am happy with getting the same experience as my neighbors. I want a very hyper-personalized experience. And consumers also are demanding convenience. We are so used to getting everything at the tip of our fingers, whether things delivered at our doorstep or summoning a taxi cab and so on and so forth. And from industry perspective, everybody wants to stay ahead of the game and be thriving in this competitive marketplace. So introducing emerging technologies into the products is one way of staying ahead of the game. So essentially, more and more consumer products can include potentially AI and ML. And you have seen from other speakers before me some examples, and I would be also showcasing some examples today. Next slide, please. So let me go back and demystify this overloaded and ambiguous term called artificial intelligence. I'm going to go back to the origin of that terminology and borrow the definition from John McCarthy, a Stanford professor who coined it in 1956, saying, intelligence demonstrated by machines in contrast to natural intelligence displayed by humans. And it's an umbrella term whose subfields range from robotics to machine learning. Here, I want to emphasize the last sentence. It is an umbrella term with many subfields. I think when it comes to AI and the analogy to electricity, it's important to know that AI is this whole set of various functions and features. And for example, here are some subfields that I've given here: vision, speech detection, natural language processing, robotics, machine learning. These are all the subfields that John McCarthy is talking about, and each one can address a certain problem, whether it's in consumer products or not. Next slide, please. So what exactly is machine learning? According to some reports, about 60% of the actual use cases in industry today actually use machine learning. So 60% of AI use cases use machine learning. So in that context, what exactly is machine learning? I'm sure you heard a lot of definitions today in this conference, but here is my definition, again taken from some of the AI experts working on Google Brain. AI that uses algorithms that automatically learn without being explicitly programmed is machine learning. So those of you who are familiar with software, traditional software programming, the difference is in traditional software program, you can follow a set of rules or if then conditional statements, whereas with machine learning, a lot of data can be fed into the algorithm, and algorithm can learn patterns based on statistical modeling and advanced math and produce an outcome that is sort of a predictive analytics in the case of one example of machine learning. And here I will provide the anatomy of a thermostat. This is a Nest thermostat, but think of any smart thermostat, and I'm borrowing this image from New York Times. So the anatomy of a Nest thermostat, what you see, the temperature displayed is just an LCD screen, but all the magic happens behind the scenes that you can see to the right of your diagram here. So you have a microprocessor that sort of controls the different functions, but embedded throughout the body of this particular thermostat is different kinds of sensors. So you have near field motion sensors, far field motion sensors, ambient light sensors, temperature and humidity sensors. So all these sensors are basically reading various information. For example, the near field motion sensor, ambient light sensor will detect the presence of a person inside the room. So often when you're away for weeks together on vacation, you would come back to your house where the thermostat is set at a very if it is a summer, it's set at a very high temperature. If it's winter, it's set at a minimal. So it goes into the eco mode, conserving electricity for you. So these sensors detect the presence of people in the house and if there's any motion. And the temperatures and the humidity sensors at the back actually detect the actual function of this particular thermostat. What is the temperature and humidity in the room? And over a period of time, if you go and see in the Nest thermostat or any other smart thermostat, you see historical data of the temperatures that you have either personally set or it has detected in the room and it continues to be at that particular temperature. So for example, I wake up at 2 a.m. suddenly and I see I'm feeling very cold in winter. And the temperature is 69 degrees based on historical data, you can actually reset it to 72 degrees Fahrenheit and so on. So the important thing to notice is also there should be an opt-in feature. An opt-in feature so that any human can change the automatic settings. Of course, the automatic settings are there for convenience, but unless and until the human has an opt-in feature, we might have a situation like HAL in 2001 as Space Odyssey. We want to avoid that. Next slide, please. So what exactly are the features of AI ML products? I think a lot of this has already been covered, so it is a refresher here. Based on the smart thermostat that I just covered, you can think of it having sensors, microprocessors, Wi-Fi connectivity. So this component that I forgot to clarify in the Nest thermostat is very crucial because as consumers, we love our convenience at just my app should actually enable me to adjust the temperature. So the Wi-Fi connectivity is another important component. It might have an antenna to connect to your Wi-Fi network and so on. And through that, the remote operations using a smart tablet or a smartphone is possible. But the crux of the problem or the challenge, and in some cases, the benefit is actually your software and the data. The data is the information that the product is continuously learning and reading or sensing in this case. And that data most probably gets uploaded to a cloud server owned by the manufacturer in most cases, as well as there is software that controls the programming that can have frequent updates. And these are important to note because I would be presenting some of the challenges these two particular components can bring to the table in the context of consumer safety and potentially leading to dangerous situations. Next slide, please. If you can play the video. The previous slide. Give it some few seconds. Yeah. If you can play the video for a few seconds. Can you enable volume by chance? Okay, I can describe what's happening here while they figure out the volume, but here Moxie is an educational toy that is helping some interactions with a child here. Interestingly enough, Moxie actually won an innovation award by the Time magazine in 2020. And if you actually watch the video, you can see it on YouTube afterwards. If we can play with the sound, it would be awesome. Essentially, what they are showcasing is Moxie is very interactive. So it helps the child to read a story. It helps the child to actually draw something. It's there lending an ear when the child says that the friend doesn't play with him and says it's okay, and so on and so forth. And so it's increasing the interactions with the children. And while Moxie won this innovation award from the Time magazine, it's interesting to note that a couple of years ago, a similar educational toy, it's an AI-driven educational toy called Kyla, that was actually banned in Germany. There were many questions that were raised and concerns raised. In fact, the World Economic Forum published a report about these sorts of toys for children, because one of the interesting things and a very imperative to understand in the context of children is you should not be violating any children's rights here. So think about the data that they're storing, all these conversations that a child is having with an AI-driven toy. Where is the data being stored? Obviously on a manufacturer's cloud server, but how is the data being used? Is it used to derive any psychological metrics of the children? Is it used perhaps to even do some marketing to the parents? And what rights do the children have over the data that's collected about them? So these are some open-ended questions. And this is where the lines are very blurry between physical products and digital products in the context of artificial intelligence. The other question that's raised is that hackers can easily hack the system sometimes and can potentially lead to dangerous situation. And the last but not the least, sometimes the educational toy can lead to dangerous situations. For example, if a child asks the toy, I want to play outside, it's sunny and a beautiful day, and the toy says, sure, why don't you go outside and play? Unaware to the toy and the parent, the child can open the door and go outside, leading to a dangerous situation, because depending on the age of the child, your unsupervised playing outside can lead the child to dangerous situations, and that's a question of safety as well. So in the context of some of these AI-driven products, it's not just what are the use cases that you're testing, but what are the second-degree use cases in the case of a child asking, can I play outside example. So it's very crucial to think about the second-degree impact of these products. Two more examples. You have already seen a more funnier photograph of an autonomous vacuum cleaner. And here I also present an autonomous car in the context of consumer products that are totally driven by AI. So for those of you who already own an autonomous vehicle, you do know that there are constant software updates that you receive and so on. But the question that's baffling the Department of Transportation is, who is liable? Is the investor who creates the programs liable? Is the person who's actually writing the algorithm liable? Is the person testing the product for various scenarios and saying that we have tested it liable? Or actually the CEO and the actual organization as a legal entity, are they liable? So these questions are still open-ended and gives a lot of heartburn to regulators, because it's, although the level 5 autonomy in cars have been tested for a couple of years, it's still not on the roads. The autonomous technology we see on the roads is not level 5, but more around level 3 right now. The reason being all these open-ended questions about safety, about legal implications is still very important to consider with legal compliance and regulation viewpoint. Next slide, please. So what exactly are the implications of AML products? So we did mention that the implications might involve this hyper-personalization and might involve attacking you because of the hyper-personalization, or on the other hand, while trying to optimize performance in real time, it can lead to dangerous situations and undue consequences. And obviously, in terms of remote operations of products, there is a potential for hackers to hack the system there. Next slide, please. So in this context, here are some steps that CPSC can think about to validate AI/ML products and functionality. Number one, I think it's always important for to ask the manufacturers of the product to declare if there are features of AI and ML embedded in the product. This is crucial because it's not enough to say it's a smart refrigerator. You have to understand what software goes into the control of that refrigerator in order to determine the implications of the AI/ML functionality. And then you review the products for the AI/ML functionality and make it ready for testing different scenarios, because in the context of AI/ML, use cases and scenarios is key. Every use case is very unique and it has to be tested for the particular use case. And you validate the inputs and outputs and give a certification. But more importantly, the certification has to be renewed every single time there's a huge software update. In fact, I have heard certain smart refrigerators are not actually notifying the consumers whenever there is a software update. And software update has implications that every update can lead to dangerous situations or potential safety hazards. So recertification is also very crucial. So these are the high-level steps I would envision the CPSC to follow. And hopefully we will continue this conversation about AI and ML. Next slide, please. Thank you so much. Please feel free to connect with me on LinkedIn, Swati Young, Chief Technology Officer at Integrity Management Services. Thank you again.
Thank you, Swati. Next up, we have Dr. Mahmoud Tabador addressing the impact and analyze component of the proposed 4I framework. Dr. Tabador is the Global Head of Predictive Modeling and Analytics, Machine Learning, Data Science, Data Analytics, System Modeling at Underwriters Laboratories Incorporated. Dr. Tabador has over 14 years experience in predictive modeling and data science in a variety of industry segments, including consumer and industrial electronics, medical devices, telecommunications, regulatory, and automotive, just to name a few. Dr. Tabador has extensive know-how and hands-on experience creating strategy, developing business models, and executing digital services built on data science and data analytics-driven modeling, machine learning, and AI technologies. Dr. Tabador, the virtual floor is yours.
All right, thank you so much. Appreciate the time. So today we want to talk about what we consider an impact of artificial intelligence, machine learning on product safety. We do believe it's significant, and we hope to make that case today. Next slide, please. So there's a lot of discussion here on what's artificial intelligence. And so for us, it's very simple. You know, intelligence itself is a broad area. Under it is human intelligence. And then under human intelligence, there's artificial intelligence. And when we think about intelligent agent or a learning agent, what we mean is an agent that has a goal in mind. And so they make decisions and they act on decisions in a way to achieve that goal. That to us is the simplest kind of explanation, working explanation of intelligence. And the artificial part is very simply that these agents are created by humans, and for now, they're mainly computer-based. The point that this slide tries to make is there's certain elements to being intelligent. One is you have to be able to observe your environment. So there was a mention of sensors. You need to pull in information. So for instance, a autonomous vehicle has LiDAR, radar, camera, so you can observe that environment. Now, once you observe the environment, you have to bring that information in and recreate that state. Again, an autonomous vehicle has to know whether it's on a two-lane vehicle versus whether it's approaching an intersection. So there's this whole idea of you have to act on a decision, you have to have a goal. When you make that, take an action, there may be, depending on the environment you're in, consequence, there's a reward, you know whether you're moving closer or further from a goal. So this is overall kind of our idea of how a artificial intelligent agent would behave. Next slide, please. So now when we talk about intelligence or how we use intelligence, you know, as humans, we have a problem, we think of the problem, we come up with a design, we make a product, we use that product, and we learn and reuse. Right now, most AI products are in the use stage. That means as the product's being used, there's AI incorporated in it to improve the features, the functionality. Though there is more and more work being done on the design stage, we will focus on this part today. Next slide, please. And the reason there is so much use of ML, AI, or proponents of AI, ML in terms of safety is because it's unspoken almost that humans are the cause of a lot of safety issues. You'll see here products that have very unusual warnings. You may wonder why we have these warnings. They should be obvious, but nevertheless, humans have a way of taking products and using it in an unintended way, resulting in unsafe conditions. And this is one of the selling points of ML AI, that if we remove the human element, that should hopefully improve the safety of certain products. Next slide, please. Now, what we did in late 2018 was kind of peruse the literature, see what's available on products, AI-based products, and issues of failures. And what you'll see here is a list with most of them in the last few years, mainly because of the proliferation of AI products. But the key message here is, you know, a lot of these companies that have deployed AI products, these are companies that are very good at machine learning, artificial intelligence. Nevertheless, they've still had failures, they're still learning, and it shows you the challenge in terms of understanding all the ways that failures might occur with AI products. Next slide, please. Now, when we talk about AI products, this is just a building on what's embedded software system safety. So we've had products with software in them for decades. There are already standards in place. We have some understanding of the failures, and that's what you see here. For instance, cybersecurity. That's always been an issue with embedded software systems, especially with connectivity. Those failures still apply to machine learning based systems, but what we're saying here is there's actually AI specific failures. That is, AI as a technology has its own failure modes, in addition to what we already see with embedded software system safety. And it's possible even those traditional embedded software system failures you see could be exacerbated with AI. Next slide, please. So here's a list of what we call some of the practical AI safety concerns. We're not going to go through all of these today. We're only going to touch on some of them. But nevertheless, there is a list we've identified of what we think are some practical AI safety concerns. If we can go to the next slide, we're going to touch on this first one, this first challenge, which is what you see here is a vacuum cleaner, a traditional handheld vacuum cleaner. A person will receive this vacuum cleaner, use it to clean their house. In testing this vacuum cleaner, we simply need to make sure that it's durable, it doesn't result in any kind of electrical shock, catch on fire, etc. So there's a series of tests that this product can be run through, and as long as it meets all the standards, it will be considered safe. If you can click, Einstein. Thank you. So the challenge here is that now the user is part of the product. With an autonomous vacuum, basically now the operator of the product is part of the product. So for very simple example, if I'm vacuuming the floor and I hit my wife's toe, she's going to be upset at me, not the vacuum. But now that the operator and the product are one, that's what's being tested. So think of a car, same with a car. In the past, the car is separately tested and the driver goes through a separate licensing. Now those are combined. And so now the testing challenge is much harder in the sense that what is the worst case scenario? There actually isn't possible to come up with a worst case scenario. And this, what you see now on the right is pictures of kind of things that have to be considered in testing. How good is this vacuum cleaner at detecting objects, especially people, especially children, whether they're moving, whether they're not moving? In other cases, what are called edge cases, that may be scenarios that are rare, but nevertheless, like approaching a stairs. It isn't necessarily about the idea that you don't want the vacuum cleaner to fall down the stairs and break, but it's more that it may fall down the stairs as somebody's walking down the stairs, and that can create an additional safety issue. So you can see from the safety challenge, it's now dramatically different. This difference between the product and the user being separate, but now being combined, changes substantially the way in which we can test things and create a assurance of safety, because now there is no worst case scenario. Can you go to the next slide, please? So as we talk about this challenge for standards, there's a couple issues that come up. And the first one is what's called this operational design domain, or the operational space. Where is this device going to be used? What is the environment? How complex is that? And you can understand that at one extreme, for instance, there might be a robot that's in a warehouse, a very controlled environment, maybe very controlled routes, all the way to a car that's outside in weather, different road conditions. And the definition of that operational space is now important. In the past, in standards, since we could come up with a worst case scenario, it didn't necessarily matter where the product was used, but now that product use is extremely important. And so the scenarios themselves almost become part of the test plan. The other aspect is this idea of learning on the job. We talk about machine learning, and we talk about the idea that it learns, but you can lock that learning. So you could train an algorithm, lock it in terms of its learning, put it in a product, deploy the product, and let it run. There's other forms of machine learning, like reinforcement learning, where it's learning as it's operating. It continues to learn and refine. And so that learning on the job, whether it's actually a locked or what we call an unlocked algorithm, is a big challenge. It's a big challenge mainly because when you certify a product, everything about that product, all the details are relevant in terms of the construction, the software, the algorithms. And so if any of those things change, essentially the product may have changed. So this learning on the job of these AI products is a big challenge for standards. And we'll talk a little bit about how we'll address that. And then, as I mentioned, is this idea of sensing and perception, because that's the key. If an AI product can't even understand the environments it's in, it's already going to be set up for failure. So that's another challenge of standards, is this idea of now trying to figure out, is the product even understanding its environment properly? Did we design the right environments? And then is it making the right decisions based on that? You can go to the next slide, please. So a little bit on this lock versus unlock, and this was going to be an animation to wow you, but I don't think it'll work. There's this idea of exploitation versus safe exploration. So exploitation is this idea of you have an algorithm, you've trained it, you lock it, you're using what you've learned fully, so you're exploiting what you've already learned, versus the exploration part, which is you're still learning. So there can be a balance. You can have what are called greedy algorithms that are keen on learning a lot as they're moving along. And so there's this question here of, can you actually do safe exploration? Can you explore in a way that you still know you're within your operational domain, that you aren't making any decisions that are beyond your capabilities, things like that. So these are all still very cutting edge areas of research that are still being investigated. But it's important to understand this distinction between lock, unlock, exploitation versus exploration. Next slide, please. So, this concept of failure modes of machine learning is important. Here's an example, and you may have heard of this idea of a brittleness. What you see are pictures of a red sports car. And what you see is two pictures, one on the left, one on the right. As far as I can tell, most human visual systems, they don't see a difference. If you can click, please, Einstein. When these pictures were sent through a classifier, the picture on the left is the original picture, and the picture on the right is picture that's slightly changed with some noise, and that noise is shown in the middle. Is it working? Yeah, thank you. All right, and what you can see is it went through this classification algorithm, and on the left, that's the original picture. It correctly identified it as a sports car, and on the right, it identified it as a toaster. So what was essentially random noise was enough to disrupt and change its prediction. And so these are one of the challenges. This is what's referred to as the brittleness, and that the output can change significantly based on small changes to the input. And this can be a potential failure mode. Again, it's not across the board, but it is one potential failure mode, especially of image classification algorithms. Now, if we take this the next step, if you can go to the next slide, here's another example of traffic signs that, at least to us now in this case as humans, we can tell they're all stop signs, but it's been found that classification algorithms will not, it's possible they wouldn't be able to recognize these as stop signs. And these are one of the challenges, again, we have in terms of understanding all the potential scenarios that an AI product may be used in, especially depending on its sophistication. And it can basically, this is another route to hacking. People could manipulate signs if they knew this was a possibility and affect the performance of an AI product, in this case, an autonomous vehicle. So you can see that it is a big challenge in terms of AI in multiple ways, both from the testing side all the way to how it even operates in actual field conditions. Which can you go to the next slide, please? Which kind of brings us to our conclusion that really there is a difference in the risk profile of AI products. And there's an additional aspect which we need to talk about. So up to now, we've talked about the learning rate, this idea of lock versus unlock, the unique failure modes that AI products have. Plus now imagine the connectivity and the scaling. Last week, there was I read this press release that this vacuum cleaner, we seem to use that example a lot, autonomous vacuum cleaner sent out an update. And obviously they thought it was a simple update, but the result was customers were reporting their vacuum cleaners were acting drunk. So they had to go back and resend that. So imagine this connectivity. Now you have thousands, hundreds of thousands of products that all get the same update. And if there's a flaw, now you're going to get a flaw that's scaled much more so than it would be on an unconnected product. So to us, there is some concern here in terms of how AI, machine learning, changes safety, the safety challenge, and the risk profile for products. The next slide, please. So with this in mind, as we mentioned, safety-enabled products are already susceptible to whatever is the traditional embedded software safety system issues. Those are already addressed, but there are very AI-specific risks. And we've talked about some of these, and some of them we still haven't even mentioned. For instance, the interpretability of AI, this bias and brittleness, the scaling, emergent behavior. So there is an assumption too that as we have more AI devices out there and they start to connect and to each other, that safety will get better. Well, we've seen there are instances where as you scale systems and complexity goes up, you get what's called emergent behavior. That's behavior that isn't obvious in any individual product, but only comes about as many products work together. So if products are only being tested individually, there's no system level test, and that only happens in the field, well, then that's a concern. And that's kind of the multi-agent problem. And then finally, it does depend on how the AI product is being used in terms of decision-making. It can be anywhere from a tool that automates, that means removes the human and it does everything itself, like an autonomous vehicle, or whether it's meant to augment and complement human decision-making. And both of those still have to be considered. So it's not enough to just test the product even of itself. You have to understand how it's used. You have to understand the life cycle of it. And by having that holistic view, can you really then start to make some statements about the safety of an AI product? The next slide, please. And so, as was mentioned in the standard session, what we found is that because of the challenge with the worst case scenario no longer being available, because now there's so many scenarios that may have to be considered, that really you have to build what's called a narrative. You have to tell a story or develop a safety case. And we have to be comfortable with this idea now that we need to document. We need to use our technical judgment and rationale to create a document now that demonstrates what we'll call the domain of trust, because every model has a limit on where it's safe and where it can work. And so it's really important to have this kind of approach. And the UL 4600, which was already covered in a separate session, is based on this approach and our learnings in this area. So with that, I thank you for your attention.
Thank you so much. Looks like we're having just a little technical difficulty, but not at all a problem. That was a fascinating briefing. Now we'd like to hand it off to Dr. Gil Altovitz, and he will be speaking on the fourth I in our 4I program on the iteration or how AI evolves through machine and deep learning. Gil?
Great. Thank you, Nevin Taylor, for that introduction. And so we'll just wait for the slides to load up. There we go. So we'll be talking today about AI iteration. What happens when AI keeps learning? So as Nevin mentioned, Gil Altovitz, Director of the National AI Institute over at the Department of Veteran Affairs, and I'll take you through some of the framework that's part of this overall framework that Nevin Taylor's put together in support of that effort. So if we go to the next slide. Yes.
Give some background on you. Gil is the director of the National Artificial Intelligence Institute and a faculty member of Harvard Medical School in the Center of Biometrics Informatics. He is the director of that Biometric Cybernetics Laboratory and the core faculty member of the Children's Hospital Informatics and Program. He is also affiliated with the Department of Electrical Engineering and Computer Science at the Massachusetts Institute of Technology. He is a co-chair of the HL7 Clinic Genomics Working Group and on the Clinical Working Group Core Executive Group for the Global Alliance. His research focuses on integrating genomics within healthcare settings, as well as international collaborations involving genomics clinical data integration. His work on iterative methods for big data in the biomedical informatics space has been published and presented in more than 30 peer-reviewed publications ranging from academic journals and international conferences to 3 books. So it is really a pleasure and a unique opportunity to have Gil with us today. We're really looking forward to your presentation. Thank you, Gil.
Yeah, thank you, Nevin Taylor, and for all the listeners here. So we'll be talking today about AI and iteration, what happens when AI keeps learning. And so in this first video here, you see basically a number of agents, kind of representatives of people that are playing hide and seek. So there's a hider who's has a few minutes that they get to hide behind somewhere, and then the seekers who get to then look for them after a few minutes and try to find them. And so what, it seems like a typical game, right, where, after a while that the seekers may find the hiders. And that's what, the AI learned at the beginning. And so typically the seekers will win after a while once they find the hiders. But what happens is that if you have the model and that's how the model is, and you finish the model in that way, that's how the game will always work. But if you have AI keep learning and or have different conditions, what you can actually have is unusual situations arise. And you can actually have cases where the seekers actually never find the hiders. And we'll take a look at that in the next example here. So if we go to the next slide. There we go. What we see is that see here in red are the seekers. They're frozen for a little bit of time, while the ones in blue have a chance to move around. And what they do is they actually build a shelter. And so once their shelter is actually completed, there's actually no way to actually get inside that shelter, and so that the seekers can never find them. So essentially, they kind of broke the rules of the game in some sense, and the seekers never are able to win in that case. And so that's kind of an example of where you may want to monitor what's going on in terms of AI, because it may not follow the same rules that you expected it to. If we go to the next slide, we'll see an example of what's called box surfing. This is this whole framework or this whole virtual world was created by OpenAI, and these videos are from that. And so what you see there is that one of the seekers in red will actually use one of the ramps to jump onto one of the boxes, and then they can surf, and then they will surf all the way up to and into the shelter. You can see right now it jumped on that box, and it's going to hover over and then kind of be able to jump into the shelter and win the game in that way. There we go. So that was, again, not something that the creators of the game expected, not something that you expect in hide and seek, but it's something that can happen over time. And so that's another example of where monitoring is important, because sometimes it's hard to tell what are the conditions and what are the rules in the game or in the situation, the product, that are such that they may result in something that you didn't expect. So if we go to the next slide, we'll take a look at a few of the different things that have been going on in the federal government. So there was a memorandum around guidance for regulation of artificial intelligence applications that came out of the Office of Management and Budget, and this was around guiding artificial intelligence applications outside of government. So that's one reference point that has been useful, and it talks about how to do regulations and so forth within different agencies and organizations. In the next slide, we'll see another example that came out recently, which was around an executive order around promoting the use of trustworthy AI in federal government. And you'll notice there that G Item G there is around regularly monitored. So that was recognized as an important feature for something to have that character of being a trustworthy artificial intelligence. And so this executive order promotes, it basically sets a minimum bar for agencies to consider the types of things that are important to have in their applications when used within government, and if not, to essentially retire those applications after a certain amount of time. And so that's what we'll be focusing on, the regularly monitored in the rest of this talk, and a few of these other ones also will come into play in terms of being responsible and traceable and accountability and being performance driven. So if we go to the next slide, we'll see that, and this is part of this framework around to make this possible, is around having to be able to qualify, to have a baseline, to baseline that origin, to assess the current state, kind of have a base case there, and then to quantify, to benchmark the references to ascertain the future state. And we'll see examples of this in a little bit. And then it's important to monitor, so you can distinguish the evolution of iterations to gauge progress over time. And of course, to measure, to discern transformation, to grade the potential for a safety mishap. So if we go to the next slide, we'll take a look at how to make AI and ML consistently safe and reliable within such a framework around iteration. Because while traditionally rules have been fixed, in machine learning, things can evolve and transform. So it's important to discern, to develop an index to monitor and measure, and to differentiate, to quantify and qualify safe capabilities. And that way you can ascertain the evolution of AI and ML in consumer products. We'll see an example in a little bit, as well as, and then see how they transform and when they evolve. And it also lets you, of course, monitor and measure, as we mentioned, the maturization of the AI and ML in the products, and to track that transformative effect in the consumer products. So you can determine when the evolution occurs and it goes beyond safe operations. So let's take a look in the next slide at a case study. This is actually was done over at the FDA under Health and Human Services, but many of this, as you'll see, applies directly and can be mapped onto this framework. And so the FDA had proposed this framework for where you can have modifications to AI or machine learning based software. And they modeled it as software as a medical device. And so the idea there is that in the past, kind of when software is approved, it can't change anymore. But here, the AI machine learning models, they may modify themselves over time as they learn more, or as they have new contexts or new conditions or get upgraded. And so it can learn continuously, and that means that whatever was approved initially may not be what is actually being used in the product. And so that's why this is kind of an unusual case, but one that really is the same, at the heart of the same problem that is faced, by a number of different organizations, such as around consumer products and so forth, where in the past, many times algorithms were only approved and kind of locked before they were marketed, but now there's this need to potentially adapt and iterate after that. And so how can you do that? And that's what, if we look at the next slide, we'll see how that was approached there. Which is building on their pre-cert program. So the idea, and if you remember this qualify and quantify were from the earlier framework we mentioned, it maps very well to what was done there. The qualify is to really maintain that culture of quality and organizational excellence by adhering to good machine learning practices. So that's the first part there. And then it's important to quantify. That is so that you can require that initial pre-market assurance of safety and effectiveness. So where they submit this predetermined change control plan, if there are going to be changes, what are the limits to that change, so that you have a description of the algorithm change protocol, and you have the software as a medical device pre-specifications, and so that you can understand when you would need more monitoring and so forth. if we go to the next slide, then we'll see how that takes shape. And so that's where the next stage, this is equivalent to the monitoring aspect of the framework, right? Where you can allow for modifications after the initial review. But if it goes outside that framework that was agreed on, as I mentioned in the previous slide, then the FDA can conduct this focused review and kind of monitor that and see how that modification is. And of course, it's important to measure, and that's the final one, where you're going to require the manufacturers to report on updates and that were implemented as part of that approved plan, and using the performance metrics for that software as a medical device. So kind of that's an important aspect so that you can be transparent about notifying users about any updates or monitoring of that performance. So you can see how this framework here and the FDA framework can kind of map together in this really nice way. So if we go on to the next, and I believe, yeah, well, this is kind of the, just to show, to really emphasize, you know, at the VA, we are using a number of different products where safety is of paramount importance as well. And it's the largest integrated healthcare system in the country and so forth, and it really integrates a number of pieces together. And so anything that's done by the CPSC, it would be great to learn about that and to take that forward and within different agencies such as the VA. If we go to the next slide, we'll actually skip through a couple of these just to make sure we get through to the next part. Yeah, so great. So basically wanted to just say if people have any questions, feel free to contact us as well. And about our experiences, happy to share more. And we also have an interagency work group on actionable AI in health and wellness. People are welcome to participate in that as well. So with that, I'll pass it back to the panel and for any questions. Thank you very much.
Thank you, Dr. Altovitz. I want to take a moment to thank our panelists for those great presentations on the proposed 4I framework, as well as taking the time to join our forum today. To the audience, we just want to let you know we appreciate all the great questions for this amazing panel. We will collect those and present them at the roundtable discussion later on this afternoon. I would like to invite the panelists to that discussion as well. Let's thank our panelists. We have a 10-minute break. Let's convene again in 10 minutes for our next session. We'll play, have some CPS videos in the background during our discussion, during our break. Thank you.
Congratulations! Whether you just had a baby, expecting a new baby, or taking care of a young infant, it's important to create a safe sleep environment for your baby. Hi, I'm Nikki Fleming, spokesperson with the U.S. Consumer Product Safety Commission. Today, I'd like to take a few moments to show you how to create a safe sleep environment for your baby. The safest place for your baby to sleep is in a safe crib, bassinet, or play yard. These items should never be placed near a window as they create a serious fall hazard and a risk of strangulation on window blind cords. Additionally, please remember these safe sleep tips. To reduce the risk of SIDS and suffocation, place your baby to sleep on his or her back. Do not place your infant to sleep on their side because this is an unstable position and the infant will tend to flip onto their stomach. This is an important recommendation from the Consumer Product Safety Commission and the American Academy of Pediatrics. Never place your baby to sleep on top of pillows or comforters. Remove these items from the crib. In fact, the vast majority of deaths associated with an unsafe sleep setting are caused by a combination of using extra bedding and placing a baby to sleep on his or her stomach. Make sure the crib has no loose or missing parts or slats. Cribs with broken hardware or even a missing screw can have their side rail become disengaged, allowing your baby to get caught between the crib mattress and side rail. Only repair a crib with parts provided by the manufacturer. Makeshift repairs can create new deadly hazards. The mattress should be firm with a tight fit on all 4 sides and no gaps or spaces. If you can fit more than 2 fingers between the mattress and the crib side, your crib is unsafe. Keep monitor and other cords out of your child's reach, as these cords can pose a strangulation hazard. Lower the mattress as soon as your child can push up on his or her hands and knees to prevent climbing out of the crib. Visit cpsc.gov or call the CPSC hotline to check if the crib model has been recalled. So, when selecting a crib, make sure it has not been recalled. When using the crib, regularly check to be sure all parts are secure. Don't put extra bedding or stuffed toys in the crib with an infant, and always put your baby on their back to sleep. To stay informed on the latest safety information and to receive free recall alerts, visit cpsc.gov, keepingbabiessafe.org, and aap.org. We would also like to hear from you. If you have any concerns about a product that could pose a danger to an infant or child, contact CPSC at 800-638-2772. Now we hope you and your baby can have both a good night's sleep and a safe sleep. Sweet dreams.
What is a drop side? A drop side is a movable side of the crib that gives mom, dad, grandma, or any caregiver easier access to the inside of a crib. A traditional drop side slides up and down.
Are all drop side cribs bad?
Not necessarily. CPSC only hears about cribs with problems, not the ones that are fine. On the whole, a drop-side crib has a tendency to be less structurally sound than an identical fixed-sided crib, and thus it is more susceptible to problems from use, being moved, storage, and assembly.
How can I tell whether my crib is safe for my baby?
Every time you change the sheets, check that all visible hardware, every bolt, screw, track, and clamp is securely in place. Make sure the drop side is on its track and functions well. With the mattress out of the crib, wiggle all the cribs to see how tight all the joints are. If the crib remains wobbly after tightening all hardware, look for loose wood-to-wood joints that may be causing the problem. Stop using the crib if loose wood-to-wood joints are found or if you cannot fully tighten any screw. Also, if one side of your crib is loose, do not push that loose side against the wall and continue to use the crib. The wall, along with a loose side, can create a space in which a child can get caught and smother.
What are immobilizers? Should I use one?
Immobilizers are protective devices that stop drop sides from moving up, down, and outward. If your manufacturer makes an immobilizer specifically for your crib, CPSC staff recommends that you get one and install it on your crib. Only use immobilizers on cribs that don't have missing or broken hardware. These devices protect your crib's hardware and limit movement so that a child can't get stuck between the drop side and the rest of the crib.
Can I just fix my crib myself?
Do not try to fix your crib. Do-it-yourself crib repair can be very dangerous and the results can be deadly. Infants and toddlers have died in crib with makeshift repairs. Untested screws can loosen and all kinds of tape, wire, and zip ties stretch, no matter how tight they may be at first.
My crib has a drop side, but I don't use my drop side. Do I still need to check my crib?
Yes, you should always do regular checks on your crib to make sure the components are tight and are not broken. Parts can still break and become loose even if the drop side is not used.
My crib has broken or missing pieces. Now what?
Stop using the crib and contact the manufacturer and report the problem to the CPSC.
Stop using my crib? Where do I put my baby to sleep?
If your baby is less than 6 months old and is not yet able to push up on their hands and knees, you can put your baby in a bassinet. If your child is older, you can use a play yard. If you believe your child is too big or able to climb out of a play yard, use a mattress on the floor or a toddler bed.
The safest place for baby is in a crib that meets current standards. Beginning June 28, 2011, all cribs sold must meet new federal requirements for overall crib safety. These new requirements prohibit the manufacture or sale of traditional drop-side cribs, improve slat strength, make hardware stronger, require tougher testing, and improve mattress support durability. America now has the strongest crib safety standards in the world. CPSC has recalled over 11 million cribs since 2007. CPSC has also received reports of 32 infant deaths associated with detached drop-side cribs. Our goal is to prevent these tragedies from ever happening again. Contact the crib manufacturer to see if your crib complies with the new federal standard. For more information on crib safety and the most up-to-date information on creating a safe sleep environment for your baby, visit us at cpsc.gov/cribs.
Welcome back, everyone. Before we continue, as a reminder, this forum will be recorded and potentially made available to the public. Up next is a panel to discuss safety considerations of artificial intelligence and machine learning relative to consumer products. We are fortunate to have Jacqueline Campbell as our moderator for this event. Jacqueline.
Thanks, Nevin. I also want to thank all of our participants who've been with us today. I know it's been a long day, but hopefully you've been enjoying the discussion as much as we have. This panel is going to be a little bit different than our previous panels in that we're not going to have presentations, but rather we're going to engage in a guided discussion focused on AI and ML as it pertains to consumer product safety. So this is kind of where we take all this information that we've been hearing today and have a discussion on where we see AI and ML and what its safety implications are for the consumer and the products they're using. So we have a number of questions for our panelists, but we do welcome our audience questions as well. However, I do want to just be very clear that this is not the panel we were discussing in terms of where we'll answer previous questions from previous panels. That's going to be the follow-up session that we have next that Nevin's going to be leading. So we do have 5 panelists. I invite them to join on their webcam or if they're comfortable. We're going to engage in about a 40-minute discussion. Thanks, everyone. So I am happy to introduce all of our panelists now. Let's see, do we have Adam on? Okay, if one of our tech folks can try to get in touch with Adam and see if we can get him on, I'll go ahead and start our introduction of our other panelists. So Karen Athanas is the Executive Director of the Testing, Inspections, and Certificates Council. She's been involved with the conformity assessment industry for over 10 years, has assisted in the development of numerous standards and requirement documents, is trained as a lead auditor in standards such as ISO IEC 17025 and 17020, ISO 17065, and ISO 15189, and has worked to design and provide training on those standards. Thanks for joining us, Karen. We also have Nancy Cowles, who is the director of Kids in Danger, which is a nonprofit organization dedicated to protecting children by improving children's product safety. She has a long history as a consumer advocate, having spent nearly 20 years at Kids in Danger and 8 years before that as executive director at the Coalition for Consumer Rights. It's good to see you, Nancy. Thanks for being here. Travis Norton is Director of Technical Services. Thanks, Travis. America's Region for Bureau Veritas. He has a decades-long career with BV, filling many technically focused testing management roles for the company. So a lot of very focused testing experience there. Thanks for being here, Travis. We also have Michael Wickland, who's the general manager at Emergo. Is that the way you say it? Or is it EMERGO? Okay, by UL, which it's the product development consulting arm of UL, where he leads. Is that correct? Yeah. Okay, thanks. where he leads a 70-person team that delivers human factors research and design services to an international clientele consisting of medical, pharmaceutical, IVD, consumer product and commercial product, and software industries. So also in addition to his decades in human factors research and consulting, he has also served as a part-time lecturer and professor at Tufts University for over 33 years. Finally, if we can, hopefully he's going to be able to join us, we have Adam Wood, who is a member of the American Advanced Technology Academic Research Center, co-chair of the AI and ML Value Proposition Working Group, and a Harvard key collaborator supporting convergent research and applied solutions at the intersection of future work, technology, and workers. Through these efforts, he advises the US government and others to better understand the influence and impact of emerging technologies on workers, and also to implement measures that would reduce the density and duration of future market failures and economic crises. So Adam, I hope you're going to be able to join in here on the conversation.
Thank you very much, Jacqueline. Yeah, we're still working on the webcam, but I can hear and see everybody. It's nice to be with you.
Oh, perfect. Thanks. I'm glad that that's working out. So one thing that's great about having a panel like this is that we're coming after a lot of really great speakers who've had terrific information. Yeah. So I have like a billion questions, even beyond those that we had prepared for this. So I'm just going to kick it off, and I want all of you to feel free to just kind of jump in, and we'll of course try to stay focused on consumer product safety, but analogous lessons learned type things would be great to hear. So I'll just start off with one of the things that really captured me from some information earlier, which is bias. And one of the things that I think is really important here at the CPSC is that we understand that AI and ML are dependent on the data sets from which they're programmed and learn. So it's really important to understand how we should be looking at the consumer products use of these technologies with regards to vulnerable populations, such as children or differently abled consumers. But then there's also a component, and I raise it now because I know we're going to get into discussion, and I think it's good to have kind of both of these things. But this idea of biasing towards safety too, which was raised by with Elham, our speaker from NIST earlier. So I think that if someone wants to jump in and talk a little bit about that, we could get the discussion started.
Sure, I'll jump in as the first speaker just to say that when evaluating systems and really any compliance program, having a traceable data set is important. And so NIST has talked about this, of course, and I think a few others, but having reliability that the data set is equivalent to the population for the device's use, but also that someone has evaluated it to make sure that it is going to function and result in the product or the response of the AI system that you're expecting. So that would be kind of my starter for everybody.
Yeah, and actually, Andrea, this morning they talked about training data methodology and how outcomes can be manipulated based on that. And I think your concern, Jacqueline, is valid. In particular, the limitations of the data set can create bias. So I think that to the point Karen's making about what data sets are you using and what methodologies are you using, that automatically defines some constraint. And I think as part of the evaluation process, which we'll get to later, I think it's important to understand those constraints with respect to what's covered or not covered with respect to safety assessments.
Thank you, Travis.
Yeah, I agree with those things. I also just think, from our perspective with trying to protect children from unsafe products, it's not that different than what we see in traditional products as well, and that's a manufacturer, in this case maybe a programmer, someone who kind of really doesn't understand the real world use of their product and how children interact with things, and might not account for that in how the product responds to certain actions because they're not expecting them. So the bias is clearly something that I think we all agree needs to be dealt with, but I think also just really having an understanding of your consumer who's going to be using the product, assuming, especially for children, as we've seen with you know, screens during this time of pandemic, that if it's entertaining the child, there isn't going to be direct supervision that the manufacturer might have in mind. You know, the parent is obviously nearby, but not sitting watching every move. So those are kind of the things when you're designing for children, whether it's AI or the product itself, you need to take into consideration.
Okay, well, we're going down the panelist line. I guess I'll add my voice here. You know, when I think about design and I consider the concept of universal design, which is that you are providing accommodations in your design solution that are good for people who otherwise might be on the tails of the distribution of who the majority consumer is. The idea is not necessarily to design proportionally to the number of people who are going to be using it, so to speak, but rather consider all the needs. So you might have a small minority that's using the product, but we don't want to necessarily discount their needs or how a product might adapt and evolve based on the needs of the majority versus the whole set of people using the product. Particularly when it comes to safety, it may be that the outliers, the edge cases, are the ones where you need to be particularly concerned about the performance of the product. And so if you're designing in a manner that accounts for the needs of those edge cases, perhaps as powerfully as the mainstream user, you might be going in the right direction.
Thank you. Adam, you're welcome to jump in too if you'd like. Adam, if you are, you're muted, or we've lost you. Okay, maybe you can jump in a little bit later. No, that's all really great. Did anyone want to speak to this idea of biasing towards safety, with the idea that perhaps, especially for products that are intended for children, that there may be some opportunities with AI or ML that could help us make products more safe than the, like Nancy was saying, than the traditional products? Are there some opportunities there that you could see?
Yeah, I think definitely there's a lot of opportunities for that, to bias, or as we say, making the safe choice the easy choice when children are using something, that it's, you know, kind of that choice architecture, you're guiding them towards doing something safer with the product rather than more dangerous. Someone mentioned earlier things that could cut off if they're not used right, if the guard is removed, that kind of things. You could have those kind of developments. So I think that is obviously something that should be built in. And, you know, the good thing with AI is you can continually learn and then update those procedures that might be different with a, you know, just a traditional product. You actually have the opportunity to see how it's being used and make, you know, modifications. And we can also use that same AI when there is a problem with the product to, you know, alert the user or make the changes, the software changes, or even take it out of use.
Terrific, thank you.
I think that AI kind of creates a lot of variability in the behavior of a given product, or perhaps even the configuration of the product. And, you know, I draw a lot of experience from the medical space where, based on standards and regulatory expectations at FDA, for example, human factors professionals and designers in general are trying to take a risk management-based approach to design. So I think there's a lot of benefit in thinking about, let me put it this way, becoming the worst pessimist you ever met and thinking about all of the ways in which things might go wrong, either people making mistakes or use scenarios evolving in ways that actually take pretty intensive analysis to sort out and list. You know, if we take a simple product in the medical space, like a glucose meter, you know, those little devices where you test your blood, you can actually come up with several hundred ways in which a use error could lead to possibly harm. And those harms might vary from kind of minor, negligible to catastrophic. And I think that mindset could be quite helpful thinking about AI, ML enabled products. It's not like you can envision, you know, an infinite number of scenarios, but you can go through a pretty intensive exercise to imagine the way the product would evolve, the way people will interact with it, and imagine things as pessimistically as possible going wrong, and asking yourself the question, have you mitigated risk through design features and other methods to make sure that people aren't going to make critical mistakes that could put themselves at risk of significant harm.
Actually,
Yeah.
Michael, thank you for saying that, because that gives me the opportunity to plug one of the things that we always talk to manufacturers about, which is that misuse or unintended use is a valid use scenario. So going through that process, I agree with you from a risk perspective it should be a part of making safety decisions for your product. So thanks for raising that.
Yeah, it's a way to move beyond wishful thinking and aspirations of having a very safe product, and actually taking a structured, systematic approach to achieving it. Maybe not reaching perfection, but reaching a level where the residual risk is pretty low, at least according to your analysis, and perhaps even doing things such as doing user research and usability testing to confirm that the risk mitigations are effective.
Yeah, I completely agree with Michael. I think that, specific to the role of independent commissions and QSMOs, I think that, we're talking about AI and ML to inform and guide innovators' best practices and user experience simultaneously. I think that privacy is clearly, something that's important, and in order to really codify the standards and requirements that the differential privacy that we understand, but the mathematical definition of that would quantify privacy risk as well as additional consumer protections commitments to the consumer. I think that everything that Michael said is spot on.
I'm glad you made it back, Adam. Thank you.
Yeah, this is I don't think that this is an anomalous situation.
Well, there's always going to be something when we have, I think this has become part of our culture of meetings now, right? Where I think I've seen it likened to a seance. Are you there? Can you hear me? I can't see you, right? But all joking aside, we're glad you made it back. I did want to get a question out to our testing folks, because I think this is one, as I'm a member of technical staff. I did want to just kind of get out there to get your feedback on, how is it that when we're talking about these products that are learning, that is constantly changing and transforming in potentially real time, maybe it's just with updates, but potentially real time, with potentially different outcomes for different consumers, whether it's due to the data set or it's due to the environment it's learning from. Is it possible that we could be in a situation where AI enhanced products could maybe have to be evaluated as one of a kind products? Or do you think that there are means that we can approach these products in groupings that are reasonable?
So Mahmoud had talked about this earlier, this idea of, a device being locked before being released to the market. And I think there was even one of just the previous discussions about, the FDA authorizing products that are locked so that it's not learning in the environment. As a citizen, I feel more comfortable with that approach because I think it gives you a lot more control and constraints. And then you could do a version update on an algorithm and release it. As a test engineer, I like the idea of these things being out there and the creativity that's necessary to figure out what the parameters are, starting with intended use of the product. And then there's been a lot of great discussion earlier about what is the operational environment that it's operating in, and starting to think about the foreseeable use conditions that inevitably we have to think about those parameters. There has to be some kind of guardrail. You can't test an infinite variety that's out there in the consumer environment, as you can imagine. But there are a lot of experience over the last several decades where we know that certain behaviors can result in hazardous conditions. And I think we can apply those. And I think some of the standards that raise questions like, what if you consider this, if you consider this, a checklist type approach, makes a lot of sense with respect to, at least within the boundaries of the intended and foreseeable use of the product. and the unintended use of that product, that you can create a boundary around those questions on a checklist and come up with some really creative and interesting ways to evaluate. There is a limit to that from a cost prohibitive nature from testing, but I think that a lot of those parameters can be explored and understood with respect to whether a hazardous condition can occur or not. The nature of the product itself may also give rise to hazards. Does it have a battery that can be short-circuited and cause a hazard? Is it mechanically mobile? Can it move around and knock things, or can it stub your toe? So these kinds of questions may be able to limit the parameters by which you're evaluating and bring the scope of it more into focus.
I think there's a parallel to some of the work that's done to validate the use safety of software products. Take, for example, again, pulling from my primary domain, medical, take an electronic health record. The way they are developed is a company will create essentially a base model, if you will, and then they go in and they tailor it to the healthcare institution where it's being implemented, which suggests that every single implementation, perhaps even different implementations within a hospital system, will be different. So the question then becomes, how would you go about ensuring the use safety of that kind of system? I think what it's come down to is essentially saying, here's a base configuration that is representative of the real world, or here's a series of base configurations. And, you know, in terms of due care, we can at least evaluate these. And perhaps some of them are pushing the limits in terms of the functionality and the conditions of use. I think you got to essentially do a degree of sampling and make sure that the degree to which a product can go in a certain direction in terms of its functional capabilities has limits. I think Travis used the word guardrails. There are a lot of products that have guardrails where the functionality can vary within what's considered a safe range. And after that, it should shut down. And I would imagine that clever designers and maybe even the AI could be programmed to understand what those limits are or what those ranges should be. And there's basically an out of bounds performance region that you wouldn't allow the device to go into.
Yeah, I totally agree. And there's lots of similar applications where things can trend in the wrong direction. You can go from fully functional to biased just based on the information that's coming in. And so understanding the limitations of the machine learning or the AI, what is it meant to do, and how can it drift, so to speak, to produce results that aren't expected, is controlled within the parameters of the algorithm for the AI. And so understanding what the purpose and what's meant to happen when the AI runs, and then measuring for controls so that you know that if it has gone in one direction or another, will let you know if a correction needs to be made. So I think, as Travis noted, when building these systems and connecting them to consumer products, having a good knowledge of how they're going to be used and how they might drift into an unsafe region helps to set those parameters to prevent risks to safety.
I've got a very simplistic example.
I was just about to ask if anyone had any examples of like small algorithm changes that would result in potential safety implications. So thank you, Michael, for reading my mind.
Well, mine is more conceptual. I'm not sure it's really
okay
from reality, but it's an example. Suppose we imagine an AI-enabled toaster, and you know, day after day it knows when I'm pressing a button to get the toast just right, and has some sensors that tells if I'm using a bagel or a pumpernickel bread or whatever I'm using. It's just getting smarter and smarter, so I just have to put the bread in there and it toasts it. We wouldn't want that toaster to be enabled to get it to the point that it chars the bread or things catch on fire. And you would assume that that smart toaster could be designed so that even if you wanted your bread to be charred, it wouldn't allow that kind of outcome.
Yeah, that's a good thing to point out. So Adam, can you think of an example of how maybe a small change in the algorithm could result in significant safety implications to the product? I'm not putting you on the spot. I just wanted to give you an opportunity to jump in.
I mean, yeah, you know, first and foremost, I think that, you know, agencies should pay particular attention to the controls in place during the development phase to ensure that basic consent and integrity and the availability of the information that's being processed and stored and transmitted by AI systems is adhering to standards that are set forth by the government. Now, I think that there have been recent challenges, obviously, that the United States has had in some particular areas, and the opposite of what we're trying to do and codify our standards here, and nation states that utilize artificial intelligence and products without those standards and without those codified requirements, ultimately that are monitored, that could breach that algorithmic state of going into deep learning. Embedding AI, ML, and deep learning into consumer products without that type of vetting is tantamount to building a digital system of social control, which is counter to the bedrock of freedom and democracy and equal opportunity. So I think that in the event that we review the extent to which technology is having an adverse effect, again, relative to AI and ML and the safety considerations, I think that, what we have to do is reinforce the importance of those standards and ensure that independent commissions such as, the CPSC are following that applied guidance and ensuring that they're working with innovators to make sure that we're not limiting, the extent to which we can provide consumers with the products that ultimately they're going to utilize in their day-to-day, but understanding also that the extent to which collection would ultimately have an adverse effect on the consumer safety itself.
Yeah, you actually, that's a interesting thing to raise. I mean, maybe you're not using the language we typically would use at CPSC, but I think I get what you're saying. I mean, certainly manufacturing is not done so much in this country anymore. It's usually done offshore, especially for consumer products, at least. So being able to make sure that we are partnering with our other countries where we do a lot of manufacturing and getting the word out on our requirements and making sure that these are things that are on the radar for those other governments is a really good thing. So that's very interesting. I did want to also raise the idea here, and this will be right up Michael's alley because I'm going to talk about people and AI. And I know when we spoke earlier, Nancy had said something about everyone wants their own personal assistant. It's very attractive. It's it's very value added for a product to make it unique to the consumer. What are some potential, I mean, obviously there are some positives there. One, that you can have a much better user experience, but are there any concerns about the over-reliance on the technology, or maybe from a safety perspective, folks having too much trust in the technology and maybe changing the way that they might react in, especially for CPSC, a safety situation? Would anyone like to comment on that?
Sure. Well, I said it was right up my alley. It is. I think the automation in general and AI is a great thing. I think people welcome it when it makes their life easier, more entertaining, maybe even safer. And I think the flip side is that whenever we give things up to automation or AI, we have to work pretty hard to fully understand what's going on. Since it's automated, we assume the thing will do its thing. And I remember when I was younger, you sometimes had a car with a choke, and you had to pull the choke out to start the car, and it's very self-evident that that's how you do it. And then when there were automatic chokes, you just forgot about it, and now people don't even know the car has that functionality. That's great if it works nicely. You don't need situational awareness of what's going on if there's nothing to worry about, and it always works well. But I do get concerned if the system fails and it's doing something important. You know, in human factors, we call it taking over supervisory control. Will people know what's going on? Will they know how to step in and do the right thing to continue to have the function working properly, or disable it if things are going awry? I don't know. You start to become more disconnected from what's going on. It's a black box, and you just assume it'll do its thing. So you want to avoid situations where some sort of failure of the system or any reason why the person has to jump in and take over. You want to avoid system designs where somebody isn't going to maintain that situational awareness, will just be kind of confused and perhaps run into trouble. You know, when I think about these systems, people are trying to figure out very simplistically, what is the thing doing? What are all the possibilities? And why is it not working? And if you get down to that basic level, I think any good system or any good AI-enabled product should keep people up to speed and informed and connected to what's going on in case that product is doing something critically important to them. And how to achieve that gets us into all kinds of design principles, and might require more of an investment by some people than they're willing to give. So I think people are kind of a partner in this. If they want to be disconnected and just let the thing do its thing, they might be putting them at some degree of risk. I don't know how to get rid of that. I'll yield the floor.
You know, I think one of the earlier presentations, I think, said this pretty well, that AI adapts and conforms to customer preference. I think that was Julia that said that. And, you know, that gets us what we want, right, as users of these devices, but it can also set up conditions that manufacturers would never anticipate. You know, as you start to give specific rules to a device or an ecosystem of devices, disabling safety mechanisms. I think the example we used in one of our pre-discussions was, you know, maybe I'm in the kitchen and I'm not a good chef, and every time I cook, there's a lot of smoke in the kitchen. So, you know, if I'm in the kitchen and I'm telling my hub, if you're hearing jazz, I want you to disable the smoke detector because I know I'm going to set it off. And does it then learn, right, whenever there's jazz playing, to turn the smoke detectors off? And does that create a hazardous condition? And that's not something that a manufacturer would anticipate. There should be lockout controls that say, well, wait a minute, if you turn off your smoke detector, understandably, you know, there's this nuisance factor that consumers want to be able to have. But at the same time, should it turn itself back on, or should it alert you that it's disabled and continue to bother you until you re-enable it in some way? So this ability to customize it and to give it, you know, a rule, right? In my home, this is the rule, is a challenge. And I think that is also an opportunity for us to customize these things further. But there has to be these limits that it's not going to compromise safety, that a safety mechanism isn't going to be disabled in a way that is going to result in a significant hazard downstream.
Mm-hmm. Yeah, and definitely education, I think, will be needed because there's so many applications of AI. We've heard of tons today in every industry, in every way. I use AI to look for trends in data, you know, for business aspects. I use AI to learn foreign languages. But we learned today that AI can't even read a stop sign in different ways, because if you obscure the data, then you make it harder for the AI to read what it's looking at. Well, the same thing happens for learning programs or trying to teach children using AI, is it can become confused. And so knowing the limitations so that trust isn't ultimate, because you should always verify the data you're being given as accurate. We get this in the conformity assessment industry all the time. You can use an Excel sheet to do your math for you, but you should still be double checking that it's doing it correctly. You shouldn't have that ultimate trust that the information being provided to you by a machine is accurate until you've checked.
Yeah, I think that points too to the need to continually monitor, both on the part of the manufacturers, but also on regulatory bodies like CPSC and the consumers themselves, to kind of so that you get this information, you know, so that the products aren't causing harm. But I think there's also another, you know, use for AI and machine learning in product safety in terms of finding those hazards that maybe consumers don't even realize are hazards. Whether it's in product reviews or other information where you can kind of look for those words that might indicate a problem that wouldn't be clear to the consumer. And the only other thing I wanted to raise in terms of that monitoring is one thing that's kind of crossed my mind as we've been talking is, at least with the Consumer Product Safety Commission, with Section 6B, with reports of problems with these products, you know, having some roadblocks to getting out to the consumers who are using them. I think that's something CPSC needs to look at closely to make sure that we're not, you know, there's not a glitch where some of the useful information is falling into a hole somewhere where it can't be used to improve whatever the products are.
I agree. I think that agencies, you know, they should carefully consider the societal benefits and corresponding distributional effects before, you know, we overregulate, provided those regulations and products are being created within U.S. jurisdictions. I think that from the standpoint of monitoring and measuring for the value of AI versus measuring and monitoring against implicit biases inherent in exactly what we, you know, just said about a stop sign, computer vision, facial recognition, and preferences on apps, especially apps again that are created outside of the U.S.'s purview. That public trust in AI is incredibly important, and you know, I think that the transparency and subsequent disclosure will ultimately just increase trust in the public square and probably increase confidence in AI applications in the future.
Yeah, I mean, it's a fine balance though, which I think is what everyone's saying, right? You want trust in the technology, but you don't want over reliance. So for example, you know, some of the technology that vehicles have now, like when you go over the line a little bit and it like nudges you, right? You know, one of the things that could end up happening is that you could maybe decide, oh, I'm tired, and maybe if you didn't have that technology, you wouldn't drive, but maybe if you do, you're like, oh, well, you know, it'll nudge me, I'll be fine, or something like that. Or, you know, certainly, and this is one we obviously do a lot of work with children's products. You have a new parent who's very tired and you know, and obviously concerned about safety for their new child, and you know, do they over rely on technology that has you know, put forward a big like safety improvement, but maybe there could be some fallback. So I think that, you know, we're obviously concerned that whenever there are these big shifts in whether it's a manufacturing shift or it's a shift in consumer actions, that's something where you can start to, you just wouldn't have thought of like what the outcomes would be of those things. And certainly this is a disruptive technology, right? And so, you know, when you think that consumer actions could change so much due to this technology, you know, we're a regulatory agency, as we all know, so we're reactive in nature. And we're of course trying to get out ahead and learn as much as we can about this to try to get ahead of it from a safety perspective, right? But fundamentally, you know, this is something that we're going to see the product when it comes out, right? And so I think that the points are well taken about being at the table when we're talking about guidelines and participating in consensus standard. So I appreciate all of that being consensus standard. So I appreciate all of that being raised. We are at 3 o'clock, which I believe is the end of our panel, but we are going to jump into a panel where we're going to be, Nevin's going to introduce a couple of concepts, and then we're going to revisit questions that we've had throughout the day. So I hope that all of our panelists can stay for that section and answer any questions that we've had from the audience. With that, I do want to thank all of you. This is a great conversation, and I appreciate all the different perspectives. So please, I hope you stay on and we can basically continue our panel. Thank you. Nevin, I'll hand it back to you.
Thank you so much, Jacqueline. And thanks to all the panelists and participants for joining us today and being part of this very important discussion on consumer safety. While they're bringing our panelists and presenters on for our final roundtable for today, I wanted to say that today's discussion perfectly framed a lot of opportunities and challenges related to artificial intelligence and machine learning, relative specifically, to, of course, to consumer safety. First slide, please. As CPSC endeavors to assess the safety implications of emerging technologies relative to consumer products, your insights and questions are extremely enlightening as we gather input and feedback from stakeholders. This support by CPSC engagement in IoT working groups, participation in ASTM development of standards, guides for safety and connected products, and partnering with the National Institute of Technology and interagency agreements to explore consumer connected products, just to name a few. Next slide, please. Today's AI ML forum, go ahead and build it out for me if you would please, is an initial step to explore the implications and impact of AI and ML relative to consumer products. As we're all aware, this starts with the culture of safety in the design, the development, and deployment of AI and ML as outlined in federal AI ML principles, illustrated earlier today. The next part of the process is to monitor and measure progress. NIST's efforts in this area has identified how best to do this with these emerging and evolving technologies. It is these standards which offer the means to assess and analyze and ascertain the potential risk to the consumer. As illustrated in the FOIA program, which provides a means to, as it describes, identify or screen for AI ML components and assess the implications of those capabilities. Through this programmatic process, we can determine the potential safety implications in consumer products. This roundtable is a unique opportunity to clarify and comment on the options and opportunities to ensure AI and ML consumer products are designed, developed, and deployed safely. With this in mind, many of our panelists are available for questions to clarify and provide insight as to how best to proceed in these endeavors. What we have done for you is there's been a lot of amazing questions presented throughout the day. And what we've done is we've tried to group them and create a question relative to the highest level of interest. And so I would ask that go ahead and bring on all of our panelists that are available for our roundtable, and I will go ahead and address the questions that have been presented throughout the forum. And we very much look forward to any comments, questions that they might have relative to those questions and provide some new additional insights. So with that, let me start with the first question. What is currently the greatest concern that you all have relative to artificial intelligence and machine learning in technologies?
I mean, I'm still here, Nevin. This is Adam.
Great.
So I think that, you know, my biggest concern would be the risk of foreign influence. I think that that's, again, given that a majority of consumer products are manufactured overseas, there's always that inherent risk. So I think, you know, just speaking for myself, I think that the risk of foreign influence should always be a consideration.
Okay. Does anybody else want to speak to any safety concerns you have relative to these technologies in consumer products?
Sure, it's Andrea. So following up on that, I agree supply chain integrity is definitely a concern. But another concern, taking a step back, is whether the build process itself is set up in such a way as to create safety by default. We're building very quickly because we can, not necessarily in the ways that we should, and not thinking about interaction effects in particular and what kind of a world we're building for consumers and what their lives will be like experientially if they do build a house and a daily life reliant on all of these technologies that are not transparent to them and that they can't tinker and fix themselves.
Excellent. Thank you for that. It was really insightful. Does anybody else want to address that before I move on to the next question?
I'll make a comment. I think part of the concern I have is that the nature of failures can change from what's called a thin-tailed to a fat-tailed. And what I mean by that is very simply products that are human operated at one extreme, individually run by humans, and at the other extreme, they're fully connected, fully autonomous. You might have fewer individual smaller incidents, but when you do have an incidents, the scale will be very large. And that changing nature is something I think it's worth considering.
Thank you very much. Any other comments before I move on to our next question? Great. How would you propose we proceed in supporting the manufacturing design, development, and deployment of AI and ML relative to safety? And this is, I believe, put toward, the question was posed specifically to talking about, the voluntary consensus standards.
I have a quick comment. I think manufacturers for many, many years in many domains have been encouraged to apply human factors engineering process. Obviously, I'm a bit of an evangelist when it comes to that topic. They've been encouraged to apply it for their own well-being as well as the safety of the consumers. You see this in many different industries. So I'm a strong proponent in getting guidance out that would say, okay, if you're trying to optimize the user experience and protect them, make sure you preserve safety, what are some of the characteristics of a design that would do that? I think there are some core principles that could be communicated that might be news to some manufacturers. Some of it would be common sense, but that's helpful as well. But I would perhaps publish some guidelines and also prescribe an approach to validating that what you've created is going to be something that can be used safely and effectively in the environments, in the scenarios that you have in mind. That's different than the agency saying, okay, we are going to require for any product to come to market, it's got to be evaluated on these bases. That's different. But if you give the guidance, prescribing good design principles and good process, that might move the needle a little bit in the right direction.
That's a great point, Michael. And also from your perspective, you shared, I think it's critical to consider that feedback loop. What's the expectations from these products? And more specifically, what can we depend on from them? And with that in mind, does anybody would like to speak to, what do they think a consumer product, a safe consumer product looks like? Relative, of course.
I'll comment briefly. When we developed a ASTM standard specifically for connected products, we started with some principles, that it shouldn't, as a nature of being connected, it shouldn't compromise safety compliance to rules, bans, or standards that already exist. It shouldn't introduce a hazard as a result of being connected. It shouldn't disable or disarm or impair effective safety control mechanisms. Should issue notifications, cautionaries, or warnings, in the event that a hazardous condition may occur. So I think, when Elham was speaking earlier from NIST, there was a pyramid of the trustworthiness of AI that starts at these kind of foundational principles. I think really kind of from the technical requirements that evolve into these methods and case studies and requirements, which eventually become policy. So I think that the standards development is a key translation from these guidance principles into test cases, into eventually policy.
So does anybody want to address what I mentioned previously, the safety culture, and what that expectation would look like within those consumer products, relative, of course, to safety to the American people?
Yeah, I mean, I think when you're talking horizontally, it's more discussing the goals of the performance rather than being specific to a certain product or technologies. Is what does safe mean? What, in a functional sense, what does safe mean for us? You know, there is a definition that CPSC has, but how do we apply that to a broad range of different types of devices? And so rather than saying it has to have this technical characteristic or this one, really looking at what the end result performance for any device to be considered safe, I think is essential.
So I'm really glad you brought that up, because when we speak to safety, we really kind of look at it in three kind of areas. It's design, you know, how it was made, its development, how it's put together, and then of course, you know, its deployment, and that's more the environment it's being utilized in. It was addressed earlier today, I believe it was by UL, you know, about a hairdryer. You know, they're inherently safe used in the right environments. You can't use them in the bathtub. It doesn't work that way. Can anybody, I'd really be curious to dive more into this, you know, how much of the design is impacts the safety concerns? How much is it in the, you know, the development of you know, not just how it's designed, but how it's put together, and how much of it is in deployment? And in traditional sense, that's a pretty well-established process for a particular, you know, a traditional product. But when it comes to AI and ML, it is a different perspective. I would really be curious to your thoughts on what that looks like and what areas we need to look very closely at so that we understand what we're seeing.
I'll jump in and hope I'm not doing too much talking. I think a safety culture in many industries expects that the developers will take a do not blame the user view. It's very easy to dismiss product failures, accidents that ensue as a result of somebody making a mistake. And I think a bunch of us get a little upset when we hear about pilot error. It was the pilot's fault. You know, we have some evidence that people blunder about maybe between 1% and 3% of the time. The rest of the time, they're trying to do the right thing. And so a mindset that assumes that whatever happened, even if somebody was forgetful, fatigued, wasn't demonstrating great dexterity, if we assume that these are all expected normal conditions when you talk about human beings, then what you do is you have a burden of responsibility to design to accommodate those shortcomings. If somebody's very forgetful and forgets a very important step, well, that is something you could foresee. And so I think a very good safety culture is one where you hold the user harmless and you look at every possible use error in kind of a non-directional way, use error versus user error. And then you go about the task of mitigating risk through design, through training, through warnings, and some of the weaker mitigations, but principally through design, so that you can assume the worst performance of the user that one could describe as negligent, even careless, and presume that's just kind of the state of humanity. And I think that makes a big difference if you take that approach. And that approach has been implemented pretty well, let's say in nuclear power and in aviation more now, in the medical domain. It probably has a good place in the consumer world as well.
This is Andrea.
Yes, Andrea.
Yeah, and I just wanted to jump in on that as well. So I think I agree that we look to design in particular because you can't fix bad design in deployment and at the point at which things are going wrong. And in particular, we have a problem with respect to coding practices because even today, most engineering students are not taught security. as part of their engineering curriculum. So you have a generation of people building software into products that lack skills in some core ways unless someone teaches them along the way. And so one key role that I think CPSC can have is in helping to connect the people building the products with the resources that are available to ensure that the people who are critical to the design process have the resources and knowledge to build well, not just build quickly.
I really appreciate you bringing that up. One of the things that it all starts with the architectural design first and foremost, and then from there, you take how you produce that. One of the things that's always hard to know though is how creative can the user become? In other words, how are they going to use this product in unforeseen ways? And how do we create a feedback mechanism to, we talked about monitoring and measuring, and that's more specific, we'll get to in a moment, about AI in its evolving state. But how do we get a feedback mechanism to understand when this technology is being used in unforeseen ways?
I'll start. I don't know if you remember at the very end of my presentation, I talked about how we're trying to build that into our UL 4600, having a feedback so that we have this running list of examples, pitfalls, concerns as that autonomy features mature, right? So I could see a similar need in this area, and I think we've had some off-topic discussions on this, and maybe that's a place that CPSC could house that known knowledge there, maybe even similar to like NIST known vulnerabilities list and things like that, where you can actually go to and see some of the risk inherent in the products or best practices even, right? I think you can have either or a combination thereof.
And I want to just build on what Deborah said about the UL 4600, which is, again, part of our recognition of this challenge with ML AI. It's very different, but what we want to make sure is that learnings are captured, because there's, whether we want to admit it or not, quite a bit of our learnings from safety come from accidents, from things happening and going wrong. And with ML AI, there's some concern that things can go wrong and we don't learn anything. Plus, every technology only informs us a little bit. And so we have to bring all that information back. And so we're trying to move away from this model where a product manufacturer will hand us a product, you run the standard. That engagement has to happen early on. As soon as you even think of a design, why are you designing it to? What are all the ways? You have to almost use your imagination and imagine all the ways your product could fail, and then document all that and capture that, and then be willing to share that, at least in a way that, and that's really the challenge, is pull that information out without jeopardizing the proprietary nature of some of these products and their algorithms, and create a safe space, what we call a safe space to share this information. That's really what 4600 is attempting to do, is what I would almost call like a living document. That's how it's designed to be.
I really appreciate that concept of a learning environment. With that in mind, how do we develop the opportunity to work, hopefully collaboratively, so that through, best practices and lessons learned, because, obviously we all could be the benefactor of that, but in my view, the greatest benefactor is the consumer, because as we're learning from mistakes already made, then we don't have to repeat them, or even have them occur that we don't realize until somebody gets hurt. How do we create that collaborative opportunity? Because I do believe that the right approach to this is through a consensus standards. Anybody would like to speak to that, please?
Yeah, I can give a comment on that. I would think that in one aspect we could have developers and manufacturers maybe coming together and creating data sets that they found when they're manufacturing their products and sharing those data sets. And so we could have a collaborative culture in that way. As far as ensuring that happens, I mean, that will be difficult. However, I think that in some ways we could, maybe the CPSC or other organizations, when it comes to a specific product, I see them maybe putting out like a letter grade on certain products, A, B, C, D, right? And no one wants their product to be falling into one of those, C or D categories. And so that could incentivize maybe certain companies to go about implementing these voluntary standards, and then also coming together and collaborating so that the companies are all on the same page.
This is Heather. I mean, to me, the biggest way is to engage with the standards organizations themselves. I mean, we have UL sitting here. We have ISO IEC J2C1 sitting here. There's other standards organizations that are developing standards in this area, IEEE, CTA, and if the product manufacturers or CPSC has an interest, I know it's difficult sometimes because there could be technical barriers, but just getting a seat at the table to raise those concerns that you would hear from consumers, or if you're a product manufacturer, concerns that you see, to kind of level the playing field globally in terms of developing something that will ensure safety, not just in the US, but in other areas as well. It's easy to talk about setting up collaboration, and I think collaboration is great. But we already have that in a lot of areas because we have these groups set up and they're developing standards in these areas. So I just always encourage participation and engagement with the standards organizations that are working in this space.
And I would just add to that it's so important to make sure that you have consumers as part of that process. Some standards organizations are better at that than others, but I think that to leave that important part out of the standard setting is you're going to have to circle back and address the concerns they may have raised if you don't hear it from them in the first place.
Thanks, Nancy. You took the words right out of my mouth. I thought that was great. How do you create that environment so you can collectively capitalize on it for the benefit of the consumer? Because I think that's all of our end goal. That when the consumer's happy, whatever position you sit in, that's the end goal, is to ensure the consumer's happy. And of course, ours is to make sure the consumer's safe. So how do we best proceed? It sounds like there's a lot of efforts going on in that area right now. How do we capitalize on all those efforts?
So one comment I would make, Nevin, is standards are still not the first step. Standards will be developed based on a body of knowledge. I think it's actually the body of knowledge in terms of how AI systems can fail that still needs work. Like, we need research in that area, collaboration to continuously understand how these technologies can fail, AI, ML-based technologies. They're moving quickly. We see, as you know, we've mentioned companies have already released products that are failing. That, to me, that body of knowledge is where we need to start hitting in parallel to the standards, and then create that feedback loop between the body of knowledge and the standards.
Yeah, I agree. I think the other thing worth considering is, there was an initiative we did in the unmanned aerial vehicles space where we found a lot of people had a lot of different standards, some of which were overlapping, but ANSI had pulled together a standardizations collaborative and was able to map, who's working on what, and then to create kind of an organizational framework that we were able to then understand where there was overlap and where there was opportunities for collaboration, but also gaps. So while it would echo with what Mahmoud was said earlier about there is definitely more research and more knowledge sharing needs to be done, I think one of the parallel steps might be some kind of standardization collaborative to try to map what is out there and see where there's opportunities for synergy or to identify the gaps that we know we ultimately need to fill.
I would agree. That's a really good idea, Travis. There's been a lot of mapping done in autonomy and that, but not really in the AI, ML space in consumer products. So
one thing that I've observed in my domain, the medical domain, is that there was really quite a good partnership between FDA and standards organizations and the public. And it may be that the agency has done this on many occasions, and I'm a little bit behind the curve, but there was one point in time where a product called an IV infusion pump, something that's delivering hydrating fluids to the body. Those products were implicated in a lot of accidents, a lot of injuries and deaths. And so what FDA did was they sponsored a number of industry events where people came together to have a bit of a summit to talk about the problems, probably a lot of panels just like this one. And the deliverable from that effort was a safety report. So if you want to look at a good exemplar of saying, here's a challenge, we want to promote greater safety, producing a report that actually had a lot of value, that tried to make a difference was good. Another thing that has been done is quite a few workshops where manufacturers very interested in doing a better job, but perhaps underpowered in terms of their insights on what to be concerned about, come to kind of joint meetings conducted by faculty from the federal agency and the standards body. You know that FDA and AAMI have done a lot of this. Maybe there's a model to follow there, that sort of continuing education of the marketplace, the availability of some guides that come from a lot of intensive manufacturer and agency engagement would be helpful.
So this is Heather again. In my other world, in my other life, I work in nanotechnology standards. And we started that at ANSI. You mentioned the Unmanned Vehicles Collaborative. One of the first ones that ANSI had was our nanotechnology standards panel. And that's essentially what the NSP did, is we brought together the scientists, the academics, the government agencies, and the standards organizations to identify what needs there were out there, what could be done in the next 5 years, and who could do it. Because obviously the collaboratives that we have are not set up to develop the standards per se, and we already have within the United States a large number of organizations that are working in this space. It was really to identify, as you noted, where there are gaps, but where the standards groups that we have set up already can help respond to those gaps, and where they can fill those gaps with standards with their experts that they already have in place. But it is a good option in terms of bringing together the interested parties and identifying what the larger needs are. That being said, I would also, again, really encourage people to actually become active participants in the standards process, because these collaboratives are great because they're identifying issues, but they're not going to be the ones to solve the problems at the end of the day. It's going to be the standards organizations that do that. So that is certainly an option, but I just want to stress the importance of participation in the process itself.
Mm-hmm. And certainly appreciate the CPSC and NIST and others hosting roundtables and workshops like this to bring in that larger stakeholder community. It's so important, especially for individuals that maybe can't make the time or financial commitment to participate on standards, to also have this as an avenue to share their thoughts and how these new technologies will affect them, so that we can consider that in the standards process.
No, it's a great comment. One of the things I often look at is, standards a lot of times are established to support policies, and we started today with Lynn giving it just a great presentation on a whole host of things, not the least of which were the AI principles. In there, a lot of us recognize that when we talk AI, everybody's worried about security and privacy, trust, all very good things. But I was very, very gratified to see that safety was listed as one of the AI principles. In relation to that, let me ask you, certain policies were established for a certain purpose, and those sometimes were done some time ago, and as things evolve, change, and transform, that purpose might not be, as relevant today as it was maybe 50 to 100 years ago. I mean, we don't have a lot of policies on horses, which I'm sure they did at one point. We have them on automobiles, which is more relevant because most of us don't have horses, but we almost all have automobiles. So thinking in those terms, what policies are holding us back and what policies are driving us forward? And more specifically, I'm more interested in what policies could drive us forward so that we could make sure that, as we move forward, we can do so in a way that best serves the American people.
I can speak to this one. I think one challenge that we have, and I was addressed in our presentation, was talking about how we have a lot of human-focused laws, and the AI is intrinsically non-human. And so you have like negligence laws or certain other types of laws that center around personhood. And so I think there's been a few suggestions on how to change that. And one of them was establishing like a predetermined level of care. And this goes back to the standards discussion that we were having. And so instead of trying to apply our existing laws to these products, maybe we establish some predetermined level of care and have an entirely new liability structure where if there's AI contained in the product, here's the guidelines that need to be followed, here's the data sets, here's the algorithms. We get the experts together and we can decide on certain basic standards that need to be followed. And if those aren't followed, then it's a strict liability going forward. And so I think that's one solution that's been proposed. I won't comment on whether I think it's good or bad, but I think maybe establishing new liability models to incorporate AI into the laws itself will be a good, maybe a potentially good solution going forward.
I completely agree with Julia. I think, you know, and I will speak to where privacy policy, you know, is falling a bit short. You know, most existing laws and regulations relative to that focus on personally identifiable data, and they rely on legal concepts that have less relevance to differential privacy. There are currently, where I think we can improve, you know, there are currently no guidelines at a national or even at an international level on how to safely implement that differential policy or any other approach to digital privacy for that matter. And I find that that's germane to what AI and ML applications are embedded within consumer products. I think that there's an urgent need and a really great opportunity to update that framework, and specifically to promote investment in the adoption of modern understandings of privacy and new tools for privacy protection. I think that can only benefit you know, the American consumer.
I also thought it was interesting what Pablo was saying earlier from the EU about the sectoral standards and the evolution of the GPSD. I think that's worth taking a look at as well, Nevin.
This is Andrea. So I think one of the other things that we have not yet taken advantage of is the opportunity for interagency cooperation to help identify the winning practices that have pushed other agencies forward and to engage with existing regulatory authority to the maximum extent possible within the context of the particular sectors that various agencies work with. And I think that's one opportunity for moving forward. In particular, the FDA was referenced, and the FDA has a lot to offer by way of good example. In particular, the fact that they did have to do recalls because industry was not complying with the pre-market, post-market, and other guidance on various topics relating to software safety. There's also a set of dedicated teams inside the FDA who work solely on these issues. So the ability to have the adequate resources on an agency by agency basis is something that Congress can definitely help with too.
Yeah, that's a great input. One of the things I think about is, you know, when the driverless vehicle first came along, I was, you know, this was some time back, people said, what did I think about this? And my first response is, I think it needs to be a driver-assisted vehicle. It's the same technology, but as you introduce it into places, you know, at what point do you hold, and it was said before in this roundtable alone, you know, if something goes wrong, is it the designer's fault? Is it the developers? Is it the deployment, the environment it's in? And as we look at these things, if it's not clear, you know, what these look like, then it really becomes hard to monitor and measure this evolving technology as it continues to change and transform over time. So with that, let me ask the panel here. As these technologies continue to evolve and new technologies come out and our reliance and dependence on them continues to grow, what advice would you offer us to ensure, that they're being done in a safe manner, and that we have all the means to monitor, all the things in place to monitor and measure these capabilities and the impact and the implications they have to the American consumer?
I'll speak up. This is Nancy. I think that there's been so much great information here today in terms of, we all need to kind of absorb it, and so many people have been working so hard on this. But I think one thing that struck me and was brought up again and again is kind of that transparency and disclosure, is that just as open as we can keep all the activity that's going on in this area, as people consider new standards or guidelines, or even collecting the data, that be a transparent process. So when people want to get involved, they have a way so that if there's problems, they can be addressed. And so I would say, I think that's pretty important for the next steps.
Thank you, Nancy. So with that in mind, talking about next steps, and it's a nice transition. I always look at I look at the past to inform the present. It was Winston Churchill who astutely said, the further back you can see, the further forward you can look. So I'm thinking about what the future has to offer specific to these technologies. And you see all the movies where, the robots, all the sci-fi movies where the robots take over, and there seems to be that constant fear. I say that there's a certain degree of credibility you have within the technologies, and from that you develop the confidence, and that grows into a level that you can trust it. So as you look to the future, what do you foresee the conversation that we're having maybe on the same topic, a couple of years, 2 to 3 years, 5 years, 10 years from now? And where do you see this going?
I can start with what I see short term. I think goes back to, I think there's going to be some needed conversations on liability, right? Who's at fault here? There's the fundamental who's at fault, and then there's the public perception, right? And an example with a car, 16-year-old driver has an accident, you might have a different feel than your expectation of a vehicle, an autonomous vehicle that's doing it, versus a 40-year-old person. I think you have different levels within there, and I think that those conversations need to occur before in the short term. So
yeah, I think that some of the additional topics that I'm working on is, when it comes to digital transformation, the requirements and challenges and deployment of it, placing an emphasis on the importance of emerging software and embedded AI, ML, and robotics as well within the labor market for all sectors. We have to highlight the requirements for digital transformation via the advanced emerging technology applications that we've discussed. And we have to explain the benefits of the adoption, modeling that prevents diseases and financial crises, and the opportunity for enhanced partnerships and shared responsibilities, amongst a variety of teams via implemented technology and correlating all the training that's required to reduce the cost of care and reduce transaction cost and combat inequality within societies. I think that we will have a number of opportunities to open the floor for discussion in the future to engage on the arguments involving those costs and benefits of stress testing and deploying those models of computational fairness, adversarial and counterfactual testing, and the extent to which cooperation between workers and people that produce these products the machines that are utilized to, that are critical in the success of these new technologies. And then again, as was just emphasized, the laws and regulations to protect the American consumer in the aggregate.
Thank you. So as I think about how do we, obviously looking at the future, looking at the past, I always look at what we can do in the present. And that said, what would you propose would be things we should be thinking about? How do we monitor these technologies, for safety in consumer products? And how do we measure, the impact they're having? And are they, safe in most operating environments for the consumer? I mean, there's a lot of products that were brought up today that, like hair dryers. Those are inherently unsafe when you're drying your hair while you're taking a bath. It doesn't end well. But under most operating conditions and in most environments, it's a safe thing to have in your home, and it serves you well. So when it comes to these AI and ML technologies, what do you think in the present that are good measures and indicators for safety that can be monitored to assess this risk analysis on a product to determine is it safe, by design, by its deployment, and in most environments? Travis, you do this a lot with testing. Did you want to comment to that?
Yeah, I've been thinking a lot about all the different presentations that that people put out there, and I think that it's a combination of cobbling together some of the best practices we've heard throughout the day. First, I thought Austin had a pretty good decision tree on, is this device AI capable? And later we talked about the pyramid of building up trustworthiness. And I think that when there's some great suggestions about looking at existing definitions and existing safety standards for products that are known to have hazards, and as you start to think about kind of the path you're on of, does it have that functionality? Does it have an inherent safety issue? I think that it is possible to get ahead of this as opposed to the historical approach of waiting for, a lot of bad things to happen and then we'll analyze the data. I think that it is possible to look at a lot of these ways of categorizing where, in let's say from this, in connected products, we looked at a lot of products before they were connected and said that if it became connected, then here's a hazard that might not have occurred if it wasn't connected. So I think in the same space with AI and machine learning, we'd ask the same kinds of questions. I thought there was some really great content around the FDA approach as well, that, this idea of having, the algorithm is locked before it's released, and that, a substantial impact has to be validated prior to release. So there's a number of these things that I think come from these different sectors that can be cobbled together into a way forward. And then the standardizations collaborative might help us understand where there's gaps. But I still think these are early days. And I think that Mahmoud's request to do more research and for us to continue to study and understand and share the need for transparency. There's a number of these parallel tracks that I think we need to be on in order for us to be able to understand what's in scope, what the potential hazards are, what do we not know about this, and where will these potential hazards emerge? And I think that's when we can start collaborating around being proactive as opposed to reactive on some of these issues.
That was wonderful.
There's one more element to the FDA approach, if I could throw it in. This is Andrea again. So the FDA gets some of its reports of problems from computing experts at large. So they engage very actively with, for example, the security research community to look for safety flaws in medical devices proactively, including going out to conferences and setting up testing stations in collaboration with manufacturers and letting crowdsourced knowledge happen to identify the types of safety problems that a consumer is likely to experience. So that's something else that is a very viable path forward here for CPSC, and those pathways have already been charted by both the FDA and the FTC, and it's something that I think would work for CPSC as well.
Thank you so much for that, Andrea. So, I mean, this was a phenomenal conversation. I know it's the end of a day. We've covered a lot of ground, but I just want you all to know this was extremely informative, and I want to thank you for just an insightful conversation that has been most helpful. And on behalf of all of our guests that are registered, thank you, panel, for your words of wisdom. Before we close the forum today, I did want to remind everybody that CPSC will be publishing a meeting log of our website that will include a brief synopsis of the day, along with slides from our guest speakers. All registrants will be emailed a link to the document once it is available. As we stated, we are in the formative phases of developing a framework. We are and these are the very initial stages of an overall effort as we look forward to the ongoing dialogue and encourage you to reach out and share any further information that you believe will be helpful to CPSC to ensure safe products for the American consumer. As such, please know that your feedback is important to ensuring AI and ML consensus standards are established to address an evolving environment. It is through these ongoing efforts that will establish a pathway forward to ensure products that are safe for the consumer. In closing, I would like to thank our speakers for their insightful presentations and for all who contributed to this informative forum. I'd be remiss if I didn't thank those within CPSC, like our Artificial Intelligence Machine Learning Working Group, today's moderators, and our amazing tech team who worked so very hard to put this exceptional forum together. I especially want to thank each and every one of you for your interest and efforts to ensure consumer products are safe.